haven't done it forever and I don't want to.
Yeah, you just like if you just do it with witness. Like I proved it in like 20 minutes earlier. Oh, did I lose my work? Oh no, I have a new tab here. Like this is what one of the cases looks like. And once you prove the exercise for the reader, then you're done.
Exercise for the reader.
It's an
Oh, that's
induction
that one.
game.
Yeah, yeah, yeah. I
Yeah,
did that
yeah.
earlier. It wasn't.
Exercise for
Okay,
the
it's actually
reader.
not that bad. It's secretly not that bad.
Um,
I think high key, like on a midterm, like it's totally fair to just put exercise for the reader and and leave it at that. Or on the exam. I think you have to realize that like he's not like he's you're not getting the bulk of your marks just for it being green, like just for the whole thing being entirely green, but for showing him that you're like understanding the proper steps.
there's also
So
I
like
don't know if you guys knew this. There's something very important he said here. Um, You are allowed to duplicate question cells and leave several attempts in your submission. The best attempt will
oh,
count.
that's interesting. Okay, I didn't actually know about that.
I did not know about this or realize this before, but basically that means the strategy is if you do some attempt and it's not working, don't delete it, duplicate the cell and start over, and just leave all 14 attempts in there.
True, true. That's really funny.
So yeah, that's I like how we just dropped that in here. Like I
Yeah,
don't think
that
anyone
was
knew
not
about
there in
this
previous years, I
before.
don't think.
Um, and like it makes sense. Like thinking about like I know how the grader works because it looks at each top level item separately. Like you can add if you can well I know for a fact you can add an entire new question and the grader just ignores it because it's looking for specific theorems. So
Yeah, that
it
makes
makes sense.
sense.
It looks at all of them and then takes the maximum of the grade. Um, but yes, that is a very important strategy, I would say. And with that
Yeah, that's a
said,
really good point.
it seems like some people don't know the keyboard shortcuts. You can either just click here and use the options. It also tells you the shortcuts. Shift D to duplicate, um, regular D to delete, A to add above, V to add below.
Me deleting the all the exam questions by accident and then panic saving.
Well, it would just reload.
But then I've saved I though that I lose all my saved work on the other questions. It's unlucky, really.
Huh?
I hate it when that happens.
But yes, it is. Yeah, don't delete the exam questions. Bad
Yeah,
idea.
ideally avoid that.
Um, I guess I can open up 10.4. Um, we just want to go through it then, or
I can go through 2 if you want, but yeah, I think we could definitely do this one.
um, yeah, maybe I will just. Oh, that's not what I wanted. That is not the right file. This one. Um, so he did have a couple slides on ghost variables. These are just some reminders about while loops. Um, so I guess it was basically just these couple slides. But his explanation is that ghost variables make proofs easier. They can be used to keep track of values that are important for understanding the logic of the program. And then he says, like, with language support, they're compiled away to avoid runtime cost. I don't actually know what languages support this, but and I think that was about all he had to say. But in here, he says a little bit more. So the ghost variable doesn't influence control flow, doesn't influence the values in the proper program, so it doesn't influence the result, and it's needed only to make the invariant easier to state and easier to prove. So if you've
Mhm.
proved 10.3 and 10.4, I think everyone would say 10.4 is definitely easier.
So
Um,
I guess the logic is that in the exists that we have in 10.3, like you kind of that use that exists at every step, like now we're giving it an actual value that'll exist in the program.
yes, that's exactly what it's doing.
Mhm.
Because yeah, that exists quantification in 10.3. It's also important to notice it like an exists quantification in general can have one or more values that make it true. That exists quantification has exactly one value that makes it true.
Yeah, and now we're giving it a name and an actual update rule to make it
And
very
yeah, now we're
useful.
giving it, now we're making it a variable and giving it and actually updating it. Um, yeah, so like he even says it here. The ghost variable integrates part of your proof structure into program structure. Assignments to the ghost variable give it the values you would have used as witnesses in your exists introduction steps. Except here's a typo. This should be. You guys
Oh,
were doing this in week 7.
we didn't have the maybe we had this in my year. I don't know. I know so I actually when
Oh,
I took this course, I never did the exercises. I only did the homeworks, so I have no clue if we had this or
that's
not.
crazy. How did you pass?
I'm just goated like that, you know?
Okay, that's
Literally,
fair.
last year was my first time seeing the exercises. I had not touched them in my year.
That's insane. Like, did they not do them in tutorials or
Well,
what?
no, they did. I just like I don't know. I would like kind of roll up to my tutorial and maybe pay attention if I was feeling like adventurous.
Okay, that's fair, honestly. Um,
I think I skipped half my LC3 tutorials unless there was an assignment or a quiz. Or sorry, we
that's
didn't have quizzes, but there was like I remember there was like the only time I really went for a purpose was because we had like a multiple choice question on one of our assignments that I didn't know how to do.
um, that's kind of insane.
Yeah, that's okay. These exercises are optional, right? Like
Well, everything, nothing's for marks this year, but I
so
wouldn't say
true.
they're optional.
No, they're optional. You don't have to do them. They're a scam.
Sure. Um, I guess let's just. I might as well actually prove this. If
Yeah, sounds
everyone's
good.
just if everyone's here. Um, so um, I'm gonna set this up with the lemma structure where like I just use lemmas for everything because I think that's probably the easiest to digest. Um, so I
Do you do them
guess
for the post and precondition? I feel like my structure is typically that I just leave the precondition and post condition in line, and then I do a subproof for
okay,
the while
actually
loop.
that's fair for this one
11:16了。
because the precondition and
嗯
post condition are easy for like sorting zero where they're like 100
Yo, yeah, for I
lines.
feel like for sorting zero, that's completely true, but I feel like for the simpler ones, like it's definitely like what I would expect for the
Okay.
exam. It should be
Um,
fine to just leave it in here.
so
第一题，
how
我
did I miss
靠，
this already? Okay.
If you do that, how do you get rid of that? I actually don't know what the hotkey is for that.
Control Shift V, Control Shift V.
谢谢。
Okay. Oh, so I've probably just done it while trying to paste before. Nice.
不明
Oh, sorry. What am I even doing? While with invariant. Um, and then he gives us the invariant. Oh wait, and then that gives us. I promise I know what I'm doing. Wait, what? Oh my god, what am I doing? There we go. And then so that's the post condition part, and then we just do the assignments looking bottom up as always. And I hope everyone knows by now you can do assignment with substitution and just do it all in one line. Someone's microphone is on.
You know, I don't even think I know how to do the assignment the other way, like in two explicit steps. I don't think I've ever done it that way.
You just do assignment and then a substitution step.
That makes sense. I've never seen it before.
Oh, there's a maximum amount of viewers on the stream. Oh, I guess.
Oh,
Oh,
interesting.
I think
Oh,
that's the
wow.
advantage of. I think stage channels allow unlimited viewers,
Yeah,
maybe.
okay. Wait, how many fucking people do we have? Holy shit.
Yeah.
How many viewers does it say on your stream right now? 50. Oh, it's only 50?
50.
What? That
Um,
might be a server boosting issue, but that's actually I feel like I'm actually surprised that's the limit. Would have thought it'd be higher.
um, I think it's a pretty artificial limitation, from what I remember.
Yeah.
Um,
Okay. Well then, yeah, we probably have to switch to the stage. Okay. Hmm.
does does the stage work with more than 50 viewers as well?
I actually don't know.
Because I know if you turn on your camera, it limits it to 50.
I think it's you know what? I think we just need to boost the server, guys. I think it's literally a server boosting issue.
I'm not sure if it's a server boosting thing.
I'm literally looking at it right now that if you boost it to level 2, then we can get 150 seats.
Is that really how it works?
I'm literally hang on. I'm looking at it in the perks right now.
Discord. Oh, it can increase in stage channels with server boosts.
Is it this
Okay.
specifically stage channels, or do you think it's
I
just
think
the
so. I think
video?
it's specifically. Um,
Doesn't that mean that we don't have enough seats even if we go to the stage then? Huh.
um,
Clearly, we should start doing this on Twitch.
that's what I was about to say. So I need to hop onto Twitch right now. Wait. Stage channel caps. Okay. Yeah, we need level 2 to get 150.
Guys, we need people to boost. Come on, there's gotta be people in here with Nitro. We need to boost the server, guys.
What level are we at right now? None.
Why
Yeah,
can't I boost
none.
it? We don't currently support upgrades to Nitro for subscriptions through Apple. Held,
Oh, because you have to. I think you have to do it through your phone to do it.
Oh, okay. I guess maybe that
And
makes
I
sense.
think I'm not sure if you can do the paid boosts. Wait, let me just double check this.
This is so skilled.
I mean, we can also switch over to. I think we can also switch over to Zoom because I think McMaster has like an insane Zoom plan. I'm not using
Yeah.
Teams, but I
Oh,
will use Zoom.
that works, I guess. This is so good.
That's.
You can boost it. All right, boost it up. Let's go
So,
level
so
2.
I think we need how many boosts do we need? 7.
Wait, isn't it just wait? Is level? Hang
I
on.
think we need level
I thought we
2.
started level 1. I thought it's 7 boosts to get past level 2.
No, you need to get because level 1 is the same number of video stage seats.
Oh, lame. Okay. So we need 7 boosts. Damn. That's crazy, Pablos.
Boost the server 7 times.
Is he actually just gonna boost the server 7 times?
This is crazy for 2LC3.
Oh
I
my
think a
god.
boost is like $3 with Nitro or something.
21 bucks. That's like work. That's literally that's 20 minutes of work, you know? Like it's chill.
20 minutes?
No, wait, that's more than that. Hang on. That's
Well,
an hour of work. That's an
if you're
hour of
working
work
at
with a
Shopify, maybe.
What if I stream the other stream? That is the You know what? He's cooking. He's cooking. I like it. That's hang on. Actually, let's do it. Hang on. We're gonna do I'm gonna pop out the stream and then let me stream that properly. I'm gonna stream this window precisely. Okay,
This is so
guys,
bad.
does this relay streaming work? This is ingenious plan.
Okay, it's just gonna be even more delayed.
It's okay. It's okay. The delay's not important. We're not watching a video game here. It's just calc check.
Well, who says COMPSCI isn't a video game?
It's not a live action game, like it's a strategy game. It's
So
different.
we're doing the partial correctness, but we're doing the precondition.
Yeah, I'm just streaming the stream. Yeah, exactly. Because you'll have.
Do you want me to record locally as well, or does it not matter? Okay, because yeah, because I would need to figure that out. I don't think I have OBS installed. And I don't think anyone's gonna have time to watch this anyways.
You'd be surprised.
Okay, did I do this right? Um,
It just doesn't know what invariant is, but yeah, the rest
yeah,
seems
it
good.
doesn't know what invariant is, and I'm missing a couple steps. I guess we'll just quickly do the precondition and stuff here. I think these are like should both be fairly obvious for the steps to take here. Whoops. Or, wait, yes, that. Um, definition of concatenation for empty list. And actually, I'll do this at the same time. Membership and empty list. Reflexivity. Reflexivity.
Why do you put that twice?
It's this and this.
Oh, it's two equal. Oh, it's so blurry on the stream. I literally can't see.
Oh yeah, sorry.
No.
Should I make it even bigger?
That's fine. Yeah, yeah, yeah. Cool.
Yeah. Okay. It's probably because I think it might be streaming at like 1080p, but my screen is actually like 2K.
It doesn't matter that much. I wouldn't worry about it.
Okay.
Yeah.
Um,
You also, I realized that I didn't know this because when I did membership in I just put that whole thing to true. Like, if you technically are lazy, that false equals false. You could just make that true, and then you could just make the whole thing just the word true. Just the
what do you
false
mean?
equals false line above. Or you have that. Just replace that with true.
Yeah. I'm just
I was trying to remember why I didn't have to do a triple equals when I did this.
yeah, I think like whatever. Like
Yeah, it doesn't matter. This works
the
fine.
the,
Yeah.
the preconditions, there's always a couple of different ways to do them.
Yeah, yeah, yeah.
So that's that. And then the post condition, this is an easy post condition. So we just because we have the negation here, negation.
Wait, is there a theorem for that?
Yes.
I've been doing double negation with like definition of not equals this entire time.
Yeah, okay, we're good. And so then abbreviated replacement, substitution. Right. Identity of concatenation. And then abbreviated replacement, substitution again. Kidding. So the post condition and precondition are relatively straightforward here. Any questions about these?
Hey guys, if anyone has questions, feel free to just interrupt us in the middle. That's
Yeah,
kind of what we're trying to
just
do in this call. Like, yeah.
yeah, just interrupt or put it in the ideally in the void the channels text channel. If you put it in the 2LC3 channel, I won't actually see it. Yeah, so we've proven 2/3.
I think that's explain like the law condition. That's like the membership is this.
Wait, sorry, I didn't hear that. Did you hear that, Daniel?
I couldn't really hear.
So we explain the wall condition.
Um, this part here. Here.
Yeah. Yeah. Before the
Okay.
it was proved that post
So this is just the while structure. I have the invariant here we were given. Then I put the while rule. So I put, or sorry, you put the program correctness brackets or whatever. Then you put the while statement, and then you say, I'm just saying while with invariant here. So what I was about to do is actually make my invariant lemma. You could also say while with subproof and put the subproof there. I just think it's cleaner to separate it out. So this is just the standard while structure. Invariant, then you have the hint, and then the after that you have the negated loop condition and the invariant. Does that answer your question?
Yeah, it does.
Yeah. So now I'm actually going to make the theorem that proves this. So we're going to put this here. So our goal for this theorem is to prove this. so now that I've set this goal, what I can do is if I come back here, it says, oh, could not be justified. What did I mess up? So if it says could not justify this step, that means there's something wrong with your theorem.
Hmm.
It,
You forget to like. No, wait, hang on. No, this makes.
oh, it still could not justify this step. Okay, so there's something wrong with one of these things here. So we have invariant, negated loop condition, and invariant. Oh wait, maybe.
Wait, this is.
While
This seems
it's
because this is. It's just a while loop. Wait, what? I can't. What?
it's just the while loop. I have my
Oh, my
invariant, then negated loop condition, and invariant. And so then for this, oh wait, I'm stupid. This shouldn't have the while here.
Oh, right. Okay, yeah. You just right. Okay, yeah. This is where you should have the like. You want to show them the little like the while where the actual while theorem is in the theorem list.
Yes.
Because I usually when setting up while or conditional, I always reference that to make sure I'm not being stupid.
Okay, I'm still messing something up.
Oh, interesting. Wait, oh yeah, because it wants different stuff at the top and bottom now, right? Now you need loop condition at the
Oh,
top.
right.
And yeah. So can you
Yeah.
before you start this, just show the theorem list, like show
Yeah.
that part of the theorem list?
Yeah. Oh, yeah. I totally messed this up by copying it.
Mm-hmm.
Yeah. No, that's.
Surely now.
There we go.
Yeah. Okay.
Yeah. Okay. So you do have the theorem list, so you can say, if you spell it right, you can find while. So you have this is the one. Yeah, it's just an inference rule. So you have primitive inference rule while, which says when you have, if you have the proof that B, which is the condition, and the invariant with these commands implies, like through these commands, you can get back to the invariant. That proves that the invariant through the while loop implies not the loop condition, the negation of the loop condition, and the invariant.
Yeah.
So
this the existence of this theorem is why we have to structure our proof the way that we do, because this is just the only theorem we have to work with a while loop.
yes. So what that means is whenever you use the while theorem, you're going to have the inside the like program, the commands brackets, you'll have something from while to odd. So make sure you don't include any of the steps before or after
Yeah,
the
before
while
or
loop
after.
in
Yeah.
here. And if you get cannot justify, and then your subproof here. So you can either do a lemma or with subproof. The goal for that is, well, you're going to have these commands. So you see I have those commands here, and then you have loop condition and invariant going up through those commands goes to the environment. So
Yeah,
when
and
you
the way you
start,
know how to structure this is because this lemma that we're trying to prove right now exactly matches what's on the top of that while
it exactly
while
matches
rule.
what's on the top of here. Yeah.
We're just building this. Yeah, we're building a proof for
We're,
this because then it'll let us go from Q to not be in Q through a while loop on the bottom, and that's what we do in our actual inline proof.
yeah. So then once again, so we see we have assignments command, we have assignments at the bottom. So we're always going to work bottom up. And I mentioned this earlier, but I didn't mention this now yet, is I would say it is worthwhile actually looking at these programs just as code and understanding what they do before.
Cat. You wanna?
Sorry.
I don't know what you said. Okay.
It's worth looking at these just as code and trying to understand what they do first,
Yeah,
because
100%
that
agree.
that can slightly motivate your proof direction. So it's called lm because that's what the Haskell function is called, but it's just a contains function. Like we looked at this in 2CO3. So it's linear search. And not even optimized linear search. Actually, this notebook has a later question where it's optimized linear search. So basically, if the head of the list is what you're looking for, then you set like found to true. Otherwise, you don't do anything. And then x's becomes the tail of x's, and then the ghost variable here is the part of the list you've already searched through. So I explained this earlier. Was it in here? I hope I still have that cell. Yes. So if we were looking at it like this, in 2CO3 we would write the invariant like this: B is true if and only if X is in the sublist of L from 0 up to the index we've searched. But because like we don't really do, because lists here aren't, they're like more like, they're like not, you don't look at them in terms of index, you look at terms of head and tail. We have the invariant that it's X is in use, where use is the prefix that we've already searched. Yeah. So that's why, so this is just like the bookkeeping step. So use, we add the head, we've searched the head, so we add it to the end of use, and then we remove the head from x's. So x's becomes the tail of x's.
You had a good way to describe use. That use is just the list of everything we've searched through so far.
Yes.
And then it's helpful because then we can actually rationalize about it in our invariant as a real variable.
Yes. And in 10.3, that rationalization is even more important because you kind of have to do a little bit of a rabbit with your exists introduction. I know if you've not done the proof, that probably doesn't mean anything. But you basically, in this exists introduction, you kind of have to pull out this rabbit here.
You have to know what it is. You have to like
you have
look
to know
you
have to know what to do, what wise is, that you can prove it to be true. So it's pattern matching won't get you all the way.
Yeah, it's a tricky thing you wouldn't be able to do without the update rule provided if you don't understand what the loop is doing.
Yeah. So we've done our 2 assignment commands. So now we just have the conditional command. So for these, you copy the whole thing. And then I'll just leave that blank for now.
Mm-hmm.
And then how I do them is I don't touch the input at all. It's the very first rule. So there's no assignments before it. So I'm just going to do it like that. And so now we just have one thing left to prove. Do you like to split it? Do you like to split it off into lemmas for the true and false branch, or do you just do the subproofs?
I make the if statement itself like a new lemma, and then I just do like a subproof or 2 subproofs in there.
Okay. Since this part's so short, I'll just do it in here.
Okay, that seems fine.
So for the if statement, because for while you can just do while with subproof, but the if statement has 2 subproofs. So what you have to say is subproof, and then using conditional, and then we're going to have if I can spell
Subproof.
suburb. And so right now it says cannot justify this using because it has no clue what these subproofs are. So you can do subproof 4, but I honestly just fill in the first. I like to fill in the first and last step, and then so first we're going to do the truce case. So we have this, which is what comes before the if statement, and then we have the if it's true, this is true.
Can you show the theorem list again?
Yes,
Show where
I
the
will
conditional comes
pop that
from.
up.
Perfect.
So the rule is called conditional.
I
So
usually
another,
I don't even control F4 because they're all right at the top.
oh right, they're all right at the top.
Yeah.
So it says if So we have if B, then C1, else C2. So to prove this, we need to prove that when B is true, when B is true and the precondition is true, then it will the code C1 will always only terminate in states satisfying Q, and when B is not true, then and the precondition is true, then the code through C2 will only terminate in states satisfying Q. So basically, you split up the code. You split up C1, which is the then branch, and C2, which is the else branch, which makes sense, and you prove them separately. So we have we're going to have the two subproofs are going to start very similar. This one's just the negation, and then you remember you have to put the or then they're going to both end the exact same way, but then they have different commands in the middle. So in the false branch, we just have skip, and then the rule for skip is just skip, and it just doesn't do anything. But then for the true branch in here, so I'm looking at the code here. So in the else branch, we just skip. In the true branch, there's one assignment in the end. So that becomes true. And so if I've done this right, I no longer have cannot justify this using. It's just steps are not justified, which means if I can fill in these gaps, then it's proven. Actually, and I learned something new. If you go here and you hit X, you can clear the output.
Interesting. We
I did not
just
know
X. We just no.
you have you have to exit edit mode, so hit escape or click on the bar here and just X.
Huh. Interesting.
So that was interesting. So okay, someone asked if we have a strategy to find invariant. I think we can talk about that later.
Yeah, we can talk about that after this for sure. Yeah.
And maybe you can talk about that because I mean I have a couple things to say, but we'll go through this proof first. So
Yeah.
So these proofs are very similar, but they are slightly different. As in this case, we have this is true, and then this is true here. In this case, B is unchanged, and this is false. It doesn't really matter which one you start with. So I'm gonna do one piece of simplification. I'm just gonna get rid of this true here. So just identity of equivalence. Oh my god. Okay. So we have that. So I guess okay, yeah, this one also requires the lemma. Yeah.
If you just want to make that a lemma for now, I might actually prove it after, and maybe that'll be a good chance for me to
Okay.
go more in
Okay.
depth about sequences. Yeah, but yeah, just for now,
Yeah,
write
yeah.
exercise for the reader, and I'll prove it once you're done this.
Yes. So what you have to recognize is we have so this here looks a lot like this, but it's in a slightly different shape and x's has been decomposed. But if you actually look at this, it is the same thing. So we know x's is not empty, so we know head x's is defined and tail x's is defined. So this is used, then we add the head x's and concatenate with the tail x's, which is the exact same as use concatenated with head x's, cons, tail x's. Oops. So what I was saying there is concatenate that with. So you can look at the theorem list, but there's not we're not actually given a theorem for something that takes this and turns into this. But Anyone know if Calcare is where we make our lemmas? I heard he doesn't want them. You can put them wherever you want. You can put them in new cells. You can put them in the same cell. It does not matter. At least as far as I know. But it shouldn't matter.
Yeah, I haven't heard him say anything about.
I know for a fact you can even add new entirely unrelated theorems and prove those, and the grader doesn't care. So if you're bored and you want to prove a double nested while loop or something like that,
Yeah, but you're unbelievable.
I know.
Uh,
What is the rule for this brackets for the subproofs and while loop? I keep getting syntax errors. This is what he told me. This is what I always do. You line up the closing hint bracket directly
with
above
the
the
next
start
line.
of the next line and make sure everything inside is indented, and you shouldn't have any problems.
Yeah. Always line up the last bracket of the subproof with the previous line.
Instead of writing subproof in the subproof, can I make a separate lemma above and then the theorem and then prove each? Yes. Like I forget what he says. Where I think he says where a proof is valid, any proof is valid. So you could say by some lemma or any kind of proof by cases, assuming the antecedent, whatever. Where any proof can where a proof can go, any proof can go.
Mm-hmm.
So if you did do lemmas, instead of saying using conditional, like subproof using conditional, you can just say or conditional with, assuming those are what your lemmas are called. Or lm.then.
Yeah. So if you make a lemma for each of these subproofs, call them lm then, lm else, then you'd be able to just write it like that, and you wouldn't need to make a subproof at all.
Yeah. So
Typically, the
that
way I
is,
do it is I usually make a separate theorem for my if statements, just like how we made a separate one for this while loop.
yeah,
And
that's
then
like
I
you.
start that theorem immediately with using conditional and just give it two subproofs.
Oh, okay, I see. Yeah, that's I guess that, and that cuts down a little bit of indentation, I guess.
Yeah, I think so.
Yeah, it's not a big deal here. But yes, this is yeah. All right.
Yeah, I think ultimately just make sure you practice this question and have a syntax that works for you. I
Yes,
think as
if
long
it
as you have a
doesn't,
rule for how to
as
handle
long
it.
as you have, if you have a way to, a way you can write the structure and you can understand the structure and deal with any mistakes you might make while doing it, that's what matters the most.
Yeah.
So, anyways, there's a theorem here that needs to be proven. So I will leave this as a exercise for the reader. Um, and you can have fun with your theorem names on the exam, but try
I
and
always
make
name it
them.
after Pokemon.
Yeah, you can name them after Pokemon. You can name them after after the emotions that you are feeling at the current time. Um, so that's exercise for the reader. And in case anyone is sort of following along, I'll just give you at least one possible shape for it. So what we're trying to prove is
This
this,
head and tail can be literally anything as
but
well.
the head and tail can be anything.
Just make that
So you
X and
can,
X's. Or don't make it Y's though, it's a single element. Just make it Y for head.
oh yeah, shit.
Yeah. Yeah, I think that works perfectly. Yep.
Um, I forgot. I think I might have misled some people earlier then. Oops. I
Oh,
guess they're
okay.
probably here. Sorry about that. Um, yeah.
Just typically as shorthand, we use like the S's to being like plural, like it's X's, it's a list of X's is kind of why
Yes.
we write that.
Yeah.
And then for single
Yes.
items, we just write X, like a
Yes.
single letter.
And this, I mean, this is obviously an induction proof. So yeah, this is. I think I don't recall it being too bad, but it's kind of
It's not very difficult, I don't
it
think.
depends what variable you induct on to start with. I think. I don't think it's nested induction though. I don't recall.
No,
There's a
I did it with just
yeah.
one.
Okay. So this is the exercise for the reader. Um, and just to double check that I've stated this the right way, if I check it, it says found it and okay, but it's in orange, which means it's not proven.
That looks orange to you?
It's a slightly different red, or it's more of a burgundy, whatever.
Is it a different color? Crazy. It
It
looks
is a
the
different.
same.
It is a slightly
Oh, it's
different
yeah,
color.
it's a darker. I see what you're saying. Yeah, it's a darker red.
Um, so that is the sort of thing we might have to identify and prove on the exam.
Yeah, and
If
again, I
it's if
think
it,
you would still get a large chunk of the marks if you can do all of this and you just leave that
yes,
one out, you know?
if
So,
you
like, this is the kind of thing that, like, honestly, for this property, if I'm struggling to see how I would prove it, but I'm pretty sure it's true, I would just leave it as a theorem, maybe prove
yeah,
it later if I have time, but otherwise,
yeah.
I would just leave it at that.
Um, I'm not entirely sure how his grader works. Um, I would suggest instead of just leaving it as a question mark, I would suggest separating it out as a lemma and leaving it unproven.
Yeah.
But I'm not actually sure how is or it. I guess it makes it easier for you to come back to it. Is how
And
I
I
would
think
put it.
this at least is a bit more marks than leaving a full question mark because you've now shown that you recognize that it's just a single
Yes,
theorem that you would be able to
I was
prove.
going to say you've shown you recognize how it can be generalized,
Exactly, yeah. And
and if
you've
you
generalized it to
started
specific variables instead of
and
phase now.
if you could do the base case, that's probably even more marks.
True, yeah.
So like if you can do the base
But
case of
my bigger
equation.
point is that you should leave that and come back to it later. Like, get the rest of this to make sure you're even proving a property that actually helps you, and then
Yes,
it's the sort of thing you come back to at the end.
yes. So now we have um, oh right now oh yeah because this time in this case
Do
we
you
don't
do a
have the
subproof for this, or
assumptions.
how do you get these? I did like a
Um,
subproof assuming.
I think we have indirect replacement, right? Or is it? Oh, right. Oh no, do we have conditional replacement, or is he trolling?
Well, because I just thought that using the like x not equal like epsilon, like I wasn't even sure how to use that properly without assuming it for
Um,
for non-empty
well,
sequence decomposition.
I think I might just do a subproof here.
Yeah,
Um,
I think the easiest way when you've got like a lot of things you want to use, like I honestly I just feel like like immediately defaulting to subproof assuming never goes wrong.
yeah.
So whenever you have a
So
whole bunch of stuff ANDed together, you can make an implication subproof, and you can assume as many or as few of them as you want. Is
as
the
long as your
implementation.
calculation operator
Exactly.
is an assuming.
Yeah, you make sure you put an implication on your subproof. Um, and we can do that here because when we're doing one of these conditional, like when we're doing one of these correctness proofs, you're just allowed to have implication basically wherever the fuck you want. I don't think you assume the rest. I only assumed the first two and just used the other two as my proof and modified them.
How does that work? Like, can you
Do you get
just
what I'm saying?
start?
Like you just put just copy that, like just prove
Oh,
that, and then go like
you can actually
yeah,
do
I just did
this.
this.
Oh,
Yeah, that's what I mean. So you can assume as much or as little as of the top line
I
as you want.
I didn't even know that, but okay, that does
Yeah.
work.
So this is
That's
my favorite way to do these questions
okay.
is to
That's actually yeah.
assume the useful information. Because typically when
That's
you're doing these, you kind of have you have some useful info and then like the stuff you actually want to modify, and then you have the important properties that you need for assumptions or
okay.
to work with different
So
theorems.
um yes yeah okay that's fair. This one you could also do easily with abbreviated replacement because you're just
Yeah, yeah.
replacing the x over here. Or yes or sorry or let's just get to it then. Um, so I'm actually going to keep working bottom up here because I immediately see that I can contract this.
Yeah, it's
This does
usually
not
easier to reduce your larger side than to start like expanding out your top one in some arbitrary direction, right? Like
yeah.
it's usually easier to simplify this for the
Uh,
theorems you have.
why? Oh, assumption two.
True.
There we go. So now we're quite close, but this has this be equivalent to something. So it's actually pretty much entirely different. Um, and so I'm just going to keep working bottom up. So we have this, and we know we can break that down with membership and SNOC. So that becomes X is a member of U's, or X equals head X's. And oh, look at that. That's one of our assumptions. So now we have assumption one, and then this is an or, so I can immediately just say 0 of or identity of and. You don't have to do it all at one step, but I
Oh.
immediately recognize that this is true, which makes this is true, which makes this whole thing true, which and then that's the identity of and. So we get to just this, and then we're already all in the right form. We can just weaken away that. And so now we can see we've got green on the first subproof here, or well, it's gold because we're missing because we haven't proved exercise for the reader. So that's the first subproof. The second subproof is almost the same with just a couple things different. Let's see. I guess, yeah, we start with exercise for the reader. Feel free to ask any questions you have about any of this. Oh, wait, what am I doing here? And be careful when you're copy pasting between these, because some things are the same and some things are subtly different. So don't introduce any copy paste mistakes like I did earlier.
Yeah, I would say minimize copy pasting as much as possible.
Yeah, try and minimize copy pasting, especially unless it's like from the line directly before.
Yeah, unless it's and even then I use Control V. Control V is like
Okay.
honestly gold most of the time for me. I'm not
Yeah.
allowed to use it. I've made too many copy paste mistakes.
So this is the same thing. Oh wait, I need to do the assuming part.
We got to do our subproof like before, yeah. But yeah, I think this is a super useful structure. I only learned it this semester, like being able to just assume part of it and leave out the
Yes.
rest. But it's super helpful for doing these, I think.
I
I think I like saw him explain it. Like in one of these notebooks, he just like he said
Yes, he does
do
just
that.
explain it in one of these notebooks.
Because I used to just like every time I needed to do one of these, I would just I got told Mac users can't do Control V, but luckily they will not be using Macs on the exam, so you know they'll be provided superior technology.
I don't know if Windows Azure Cloud VMs with Dell thin clients from by UTS are that much superior, considering they were broken for the week before the midterm, and UTS only bothered to tell them the day before the midterm.
No, they're superior. They're superior. Yeah, you can also option B. It's only like it's like Alt I and Alt backspace that Mac users don't get. Desmi, did you not know that you can option B? Oh my god. Yeah, you just the one you don't get is like Alt I and Alt B.
This is some crazy stuff going on here.
So true.
Yeah, I did actually not know that you could only assume part. I think I kind of knew that. This is probably gonna be nicer than my actual solution to this. But ultimately, it doesn't matter how nice your proof is as long as it works.
Yeah, dummy, it's Alt backspace. To indent, you do Alt backspace to indent, yeah.
All right. So now I have that assumption, so I can do non-empty sequence composition with assumption 2.
No, don't listen to Tasmia, guys. You're never free from calc check. All right, it sticks with you forever. Look at me, I'm still here.
Yeah, I expect to see all of you being TAs next year.
Exactly.
They're gonna have a 1-to-1 TA ratio.
True. Everyone needs one-on-one help in this course. Anyone know I've never TA'd this course? Because I sure don't.
Why have you not TA'd this course?
No, I got no idea. It's a good question.
Then just apply next year. When I apply, I'll send you.
I'm graduating next year.
Oh, well, okay. Come back as a grad. TA.
It's okay. I'll come. True. I'll come back as a grad to TA still. Fuck it. Bro, why is Gnev here? That's crazy.
Okay. Back. Maybe we should actually do the proof.
That's a good idea. Yeah.
Okay. So these.
Or?
Yeah. These actually look super. These actually look even more similar than the other case because we have the B equivalent to on both of these. So we're just going to do non-empty, or sorry, not non-empty sequence composition. Membership in SNOT again.
Yep.
Does everyone know the other keyboard shortcuts? We're doing.
Wait. Wait. What did you just cook? Wait. What?
You can do Alt equals to get equivalents, then
Okay.
Alt Shift period and comma or like less than and greater than to do those, and then Alt Shift 9 and 0 like the regular brackets to get the
What the fuck? I've been doing slash
relation
less
brackets.
than the I've been doing slash less than and slash greater than the entire time.
Well, you suck. I think he added these this year.
Oh, okay.
There's also
That's
in the
good.
2LC3 channel, there's a screenshot of the slide pinned with all of them. It's just 5 of them. I wish he added more. I love some good macros.
True.
So there's that.
So membership and SNOC is going to split it up into X is equal to head X's, or yeah, X is equal or X is in use.
Oh, what did I parse error? Oh, extra bracket.
Yeah. Cool.
Yeah. So and then we know this is false. Here's another little trick. Is sometimes it'll deal with knots automatically. So this will just replace it
You can
with
just replace, yeah, if you have an assumption something's not, then you can just set it equal to false. That's kind of what I was actually trying to say earlier when we were talking about the precondition. There's something similar for, like, I think the theorem, if you have that it's equal to false, it's the same as just saying it's like not, like,
yeah.
you
Right.
had like something equals false, you can just turn that directly into true.
So now we have so now the whole thing is gold, which means it's proven, but the proof is conditional on a not yet proven theorem, which is the exercise to the reader. So now
have everything aside from that now, I think. Did we do the post condition? Yeah. Okay.
Yeah. Oh, whoops. Cool. I'm just going to zoom out a little bit so I can actually see. So that just leaves the exercise for the reader to be proven. Do you want to do that?
Yeah, I'm down. I'm down to do exercise for the reader. Yeah, do you want to pass me exercise for the reader? Should be a quick, fun one.
Sure.
Okay, so I'm gonna stop watching the stream. I'll get COMPSCI open.
Okay, and then I need to start resharing your screen, I
Yeah,
guess.
okay. This is so crazy. Can someone post the notebook down here? I actually don't have the notebook open.
Sure, I will send it.
Thank you.
15,092 is the port.
All right, I don't know if I'm streaming the right thing. Let me make sure I'm still streaming the right thing.
You need to start
because I'm just gonna stream my entire screen now.
I need to what's better if I pop it out and just stream that window?
I had it popped out, yeah. I just had it popped out big.
And you streamed that window, or
yeah, I just streamed specifically that window.
Okay, so I'm going to stop streaming and then share window.
Wait, I still have the window popped out. Oh, this is so cursed. Hi, I want the window to come back now. Okay, there we go.
So everyone can see. Yeah, that's your screen through my screen.
Okay. Wait, this is the help. Oh no, I'm in the wrong chat, guys. I need the notebook. Thank you, Daniel. There it is.
Okay. I can't have the chat open, and if I have the chat open,
you're
then
good.
everybody sees the chat.
We're good. I got the notebook. Okay. I got the lemma. Oh my god, my stream has a bug sometimes. Okay.
Oh yeah, and then I guess once you prove the lemma, I can paste it back into mine, and then we can
exactly. Okay, so I think for this one we want to do induction on use, right? I think that's what I did when I did this one, at least.
Yes.
Have you actually proven this?
I have proven this, yes.
Okay. Use sequence A.
By induction, not using induction.
So true. Okay, I mean, normally if it's been a while, you would just open the syntax help and go grab your induction on sequences right here and copy this. My hubris was going to punish me. Okay, I don't usually write like I don't usually do the backticks for base case. I just start writing it in line.
I only ever bother for nested induction when it gets really confusing.
Yeah, exactly. When it gets really messy, you want to be explicit to be safe, but otherwise, I think it's fine to just toss it in here. So this is just going to be the empty sequence, and then our inductive step, our induction
it's crazy.
step.
How many people are in this channel?
It's nuts, right?
It's like this is like a third of the class, or like a third of the year.
Okay, and then now this is going to be. I think you actually have to put a for any here. Maybe you don't. It might not even make you, or we'll call it you, I guess.
If if you want the higher quality stream, switch to Jacob's screen because there's only 35 people watching that.
Oh wait, it's cons goes this way, so true. Yeah, I was actually having a nightmare just trying to remember how cons and snock work and how you're supposed to deal with them. At first, I was losing my mind saying like there's not enough theorems for them, but then I realized like, well, I mean, it is kind of annoying that most of the theorems we have for like cons you just don't have for snock.
Yeah, but it gives him stuff to make us prove on the exam.
Yeah, so true, right? Like, okay, I'm duplicating. I always do this. I always have the theorem list just in a separate tab. I have all my
Yeah, I mean,
stuff. Oh, yeah.
I've heard people do that. I don't really bother.
Yeah. Okay. Okay, so I think this is. Let me double check. Okay, because we only have mutual associativity for this, which is fun. We don't have it for
Yeah.
snock.
What I call this theorem instead of exercise freedom, my actual name is shifting snock to cons over concatenation. Like you're shifting it over the concatenation and it flips.
Yeah, yeah.
Like I think that would be one possible name.
Yeah, I had a super scuff setup for this because like half of it isn't a subproof and half of it I just like did twice. Like my theorem was a bit different, the one I actually did induction on. So I'm actually just quickly pulling up my solution so I don't waste too much time on this.
Okay. I can pull up mine as well.
Perfect. Okay, yeah, I remember this now. Okay, so
Yeah,
I
yeah.
did.
No,
I think I did like. Was it right in here? I think this whole thing. Hang on, no. I'm looking at the wrong side actually.
because you have EPS, definition of EPS of cons for EPS just flips it around.
True. Yeah. For starters, we can just. Oh, okay. So I was gonna say for start. So I thought you were talking about down here. I was gonna say for starters,
I
I
was
could just be doing this. Or wait, right left identity. Sorry, I just sorry. Yeah, whatever you're saying, I'll deal with in a sec. I just realized I can at least simplify this for starters.
Yes.
Okay.
And then the step above that,
Yeah.
like if the very first step.
Oh, okay. Yeah. You do
Definition
do
of
your
cons.
definition of
cons for EMPS.
Yeah. We'll just snock now. Yeah. So or no, wait, that was already snock. Okay. Okay, so we swapped it around now. Yeah. Okay. And then now we can do the mutual associativity, I think, and just get rid of it, right? So now I can turn this into it's just const with all of this. Wait, I do this all the time where I fucking start changing the wrong side.
I know, I do it so much.
There we go. Okay. And then now we can do left identity again. And that should be good. Okay, yeah, so that one's not too bad.
And then the induction step is actually just as long. It's all or wait.
We're just trying to get it. We have our induction hypothesis, so we just want it into this form. This is snock, so it sucks, but we can change this because we can do. It's just I think it's just definition of
snock for cons,
right? Yeah, this one. I should reference the actual theorems I'm using. Definition of snock for cons just lets you basically it's just associativity, like you just change the brackets. So I'm just gonna put the brackets here instead. And now I have an actual term, cons with concatenation, so I can use our mutual associativity again to change the brackets on that.
Do you need the for any u in the inductive step? I think there's actually like implicit for any logic in some places, but just
yeah, you don't need it here. So you can get rid of it if you want to. I copied it because it's technically in his like syntax help.
I recommend it, but it doesn't. Like you can leave it out and it's still.
Oh, he doesn't. Never mind. He does not have it in his. Oh no, wait.
Oh wow, that's interesting.
Oh no, so I did natural numbers. I'm trolling.
Yeah.
Wait.
Oh no.
Wait,
oh, see, but look, he says proof for.
Yeah, he says it's a proof for or for all. So you would start by doing this
for any.
Yeah. Okay. Anyways, we're gonna shift the brackets around so this becomes this now, and now we have this term, right? Remember, don't get distracted in induction proofs. You're not trying to directly prove it without any help.
Wait, so sorry to everyone. Sorry to everyone who's watching my stream. I can't actually see this text channel without affecting the stream, which is annoying. But it's fine.
Okay. Oh yeah, let me open the text channel. If you can't see it, I should have the text channel open at least.
Well, I have it open on the side, but I made it larger. But I guess everyone
Oh,
can see
okay,
that.
okay.
Is
Got
the
it.
problem. You can't separate the text channel from viewing the screen share, which is like a weird
Yeah.
limitation. Or actually, wait, I can actually no, I can. I can just open Discord in another tab in the browser.
True. Anyways, now I can use our induction hypothesis to get that. There we go. And then I think we're just about there. It's just, I think this is just mutual associativity again, and we are done. No. Wait, cannot match. Wait, did I troll? I had it trolled from the beginning. Wait,
What did
what?
you do?
I don't know. Did it? Oh, is it because
Um,
I didn't put the for any? Do I actually? I think I do need the for any. Wait, because it was definitely working before. Wait, hello, alt I work. Okay. Oh yeah,
Oh,
you do need the for any. Okay, that's funny. Yeah. Yeah, there we go. Okay, so that's exercise for the reader. Fun time. I was trying to figure out if these properties were even true, and I actually had like I think in my actual proof, I just have a whole bunch of garbage at the bottom of me doing like test sequences, trying to
yeah.
like make sure the property was actually true, like basically visualizing like this, and then trying to remember what sequences how sequences even work, like taking this and then going like, okay, if I've got a sequence like this, and then I like, I like snock a 9 onto the end, like what happens? And the answer is basically any const sequence is just a whole bunch of numbers in an order from left to right, and then you just have a epsilon at the far right. Like it's just a whole bunch of these, like adding one as you go to the left each time. And so when you have snock like this, you're just taking this 9 and slotting it in like right here, or const. You're just wait, I can't type. There we go. You're just doing that. So these are equivalent. And that's all. That just I don't know why this took me so long to remember, but I was like struggling with understanding this concept until I realized that this is how snock and cons relate.
Yes.
Yeah.
The
I
other
also
way.
I just want to make sure I see this mistake a bit, so I just want to make sure we've reiterated on it one more time. When you have like, oops, when you have this is a single, typically a number, but it's like a specific element, like just one thing, and this is a whole other sequence. So this would be expanded into, y const something else, like const, like, z const, like it just keeps
If
expanding
you
like this.
if
So
if you remember
oops, so like, and like eventually you reach an epsilon.
Yeah. If you remember 1JC3, this is how lists work in Haskell. Except in Haskell, there's not really snock because it's not
Yeah.
efficient.
I don't even know why we have it in this, to be honest.
Well, it's useful for stuff like
I
that.
guess, yeah, it is actually useful for this because this would be kind of
Because
annoying.
otherwise, well, it'd be very annoying to define the ghost variable without snock.
Because I guess I guess yeah, snock would you'd have to do it with concatenation instead, right? You would just concatenate it. It wouldn't be that bad. So I think my theorem was actually interesting. My theorem was basically just like using a concat instead of snock. It was just it was removing the snock immediately.
Oh,
My theorem
right,
did.
because
You can define if you have x snock x, like x is snock
that's the
x, this
same
is the
as
same
concat
as
x
x's catenate just x's const like
cons
x. Like it's
x.
just this. Right, so this is just like this. I think I called it like concatenation with singleton or something, but it's basically just getting rid of snock. Like you can just anytime you have snock, you can turn it into this, and then
I
this is
wonder if that's
completely
actually an
readable.
easier way to prove
I
this.
think it was. I had an easier time doing this because I just did this immediately, and then
I
I
think
didn't
if you
need the
prove,
rest of this. I didn't have to do this in induction. Instead of induction, I just did almost
I
all the
think
rest of this as one line.
yes, if you
I think it's
prove that, then that makes a lot of the proofs easier.
yeah. So this is a nice theorem to have. So that's why I'm saying like I don't even know how necessary snock is because most of the time you can just do this and you need to do something like this. So snock may just suck. It's possible.
Yeah, now that I think about it, because I don't think, yeah, at least if he gave us that theorem that let us turn snock into cons in any situation, that would be a lot more useful.
But we just don't. Yeah, we don't have like this one or anything. So like I feel like I was surprised to see there wasn't this or this, that there wasn't either of these. Like
Yes,
you'd think
and
one of
then
them would.
sometimes, like with like the natural number orders, he has like every single theorem in there.
Yeah, for the
Like
natural numbers, he has everything, right? Like
you can prove like there's a theorem for anything.
Except, you know, there's one that still pisses me off. I feel like there's still one we don't have that's just like dealing with like that. I don't know if you had to prove like x less than, what do I want to do for a real number? I don't know. Like if you wanted to prove that this is equivalent to like that, how do you, or sorry, how would you prove this?
For natural numbers or
For integers,
integers?
for integers.
I think there's a theorem for that.
I like have tried to do this multiple times and never been able to find it. I
There's
swear. I
definitely a
swear it
theorem.
doesn't.
There's definitely a theorem for that.
I get so pissed
Integer.
off because I swear it doesn't
Go
exist.
to integer.order.
The order, yeah.
It's at the very bottom.
Very
I'm
bottom.
pretty sure.
No, very bottom is all the split off nonsense.
No, no, just not the very bottom, but it's no, stop scrolling around. Go to the, let me see the bottom of the list. Um, complement.
This is that
Or
it's
that's
not.
not
This is
equals.
not equal.
Um, I think there's another one called complement. That's just Control F for
Oh yeah, I think I
complement.
sorry. For starters, this is not true. I trolled it, but sorry, it should be like. Is it? Hang on. Or no, I think that's correct. That is the one I wanted. Sorry, because I literally made this not true, but I wanted that you would have this. Yeah. Okay, so
Yes,
it's
so it's
just called
complement.
complement. Okay, I don't know why I've just never been. Oh, you know what? Because the notebook that I've been looking at least stops here. Like I remember the notebook for these stops at trichotomy, the one that I had seen.
Yes,
So
yes,
I
but
think this
there's
came in
more.
like way. This definitely came in way later.
It just shows up at some point.
Yeah, at some point this shows up, but the notebooks I was looking at didn't have this, and it made me so mad. So I'm glad to know he's actually made it now. That's good. I used to have to prove it with this nonsense. It always pissed me off.
Yes. Trichotomy is evil.
Yeah, no, I do not. I never want to use trichotomy more than I have to. Okay, well, anyways, I'll quickly pass you this, and then we have a perfect proof. Oh yeah.
Oh yes. Well, yeah, I'll iron it. Thank you. I guess. Oh, I guess you'll have to open up my stream again.
Yeah, I can open. Yeah, I'll open up yours again. I might just keep it like this for now. I mean, I can
Okay.
do
I
that.
guess we can keep having each other's streams open. Then I just have to
This is just the
change.
worst
Oh,
setup ever.
I just have to. Oh wait. Oh. Wait. Change stream. Oh. Why? Why is it not? Oh, when it's popped out, it doesn't work. This is there's some serious. This is seriously scuffed. It also doesn't help that I'm on Linux and like screen sharing doesn't work on Linux basically.
Ah, very cool.
All right, but everyone can see my screen again. I'm hoping people can see my screen.
I can see your screen, yeah, and I got it
Okay, yeah.
open. So it should
So
be fine.
we have exercise for the reader, which we've successfully proven, and now we can scroll down and get that
Pablos is
beautiful
properly swapping between
green.
the streams on the recording.
That must be fun.
Pablos, you're still here, right? You're swapping. We're good. Cool. Okay. Did poor Pablos take goes on like quick snack break and then we just missed like 5 minutes.
Yeah. Well, ideally not. It would just be lower quality.
That's true.
Yeah, so we've proven this. Any questions at all about this? Oh, why?
Oh, someone's asked you if you could send them, like send the solutions.
Can I send the solutions? I suppose I can do that. I don't like sending solutions because you don't learn anything, but
That's true. I mean, realistically, yeah, like we're gonna have the recording, but I just think it's a matter of how quickly we'll get the recording up.
um
Um,
but I will, okay, I'll send
post them, but spoiler them. You know, like
uh
you guys really should try to practice setting up the structure on your own, like without referencing these. Like it would be literally be better to quickly drop like your current setup and ask what's wrong with it than to just reference this and just copy a working solution. Like you want to make sure that on the exam tomorrow you can set this up on your own.
okay, this has I uploaded a file in here which has the invariant and partial correctness, and then you can copy the exercise for the
Mhm.
reader above. Though, because it's an exercise for the reader, I strongly suggest that you do it.
Yeah, you are the reader. It's an exercise for you. It's good practice working with sequences for sure. Like
It's good practice working with
there's really
sequences.
only so many concepts he does a while loop
Um,
on. Like typically it's on working with some property of sequences, doing something with natural numbers like adding or maybe multiplication, or it's going to be some clean star bullshit and have fun.
what?
Our assignment 3 was like a clean star while loop, and it was the worst thing ever.
He better not put that on here.
He'd be so evil of him. The clean star while loop was actually horrific. We had like the smartest people in my program going like, dude, this assignment's impossible for like a week. We did like a deep dive one weekend and finally understood what clean star actually meant. Or what the while loop was doing.
We'll take a little break and we'll look at the 36 methods of mathematical proof. I love this page.
This sounds hilarious. I've seen like a similar meme. Hang on, I'm finding a meme while you're going through this.
It might be a screenshot of this page. So we have
No. I think it's a little bit different because it's got some pictures, but it's pretty funny.
The proof by obviousness. The proof is so clear it need not be mentioned.
Proof by convenience. It'd be very nice if it were true.
Proof by imagination. We all will pretend it's true. Proof by convenience. It would be very nice if it were true. So, proof by necessity. It had better be true or the entire structure of mathematics would crumble to the ground. Proof by plausibility. It sounds good, so it must be true. Proof by intimidation. Don't be stupid. Of course it's true. Proof by lack of sufficient time. Because of time constraint, I'll leave the proof to you. Proof by postponement. The proof is long and arduous, so it's given in the appendix. Proof by accident. Hey, what have we here? Proof by insignificance. Who really cares? Anyways, proof by mumbo jumbo. This is.
Dude, I fucking misclicked on my phone. I was trying to put the. Oh my god, I misclicked on just like the help session channel as I was trying to type in the chat.
Oh, so we lost your stream.
Yeah, it's okay. It's back up.
Okay. Did some people leave? Are we under 50 now? Or no? Because there's only 36 watching mine.
Oh, how many people are watching mine? I don't know if I can see if I. Hang on. I don't even see that. I have to.
Can someone count how many people are actually in the channel here?
Yeah, can someone check how many are?
It says there's exactly 50.
It's exactly 50 in the channel. Interesting.
That's what it says. Anyways, proof by
We'll keep the setup for now in case more people join. You never know.
Proof by profanity. Proof by definition. Proof by tautology. Proof by plagiarism.
Oh, dude, I found my meme. Here we go.
All right.
It's similar. Like it's got some similar ones, but I like the proof by cumbersome notation is one of my favorites.
Wait, what am I even doing? Oh, here we go. I'll pull up one more thing after this. Proof by inaccessible literature.
Proof by ghost reference. Circular argument's a pretty good one too.
This is a really good one. Proof by calculus. This proof requires calculus, so we'll skip it. Physics 1A03 moment.
Proof by lack of interest.
Proof by illegibility. Scribble QED. 1DM3 reference. How many people were doing that in 1DM3? Proof by logic. If it's on the problem sheet, then it must be true. This is true. At least he doesn't give us unprovable theorems.
It's true. Proof by clever variable choice. Let A be the number such that this proof works.
There exists
proof by divine word.
Proof by stubbornness. Proof by simplification. Proof by hasty generalization. Proof by deception. Proof by supplication. Proof by poor analogy. Proof by avoidance. Proof by design. Proof by authority. Proof by intuition.
Proof. So some of these seem like the same name as from this meme I posted because proof by avoidance is in there too.
Yeah. I think they're inspired. And then there's one more. What is? Let me.
Proof by authority. My good colleague Andrew said he thought he might have come up with a proof for this a few years ago.
Did anyone solve 10.1?
No.
I think I put it in chat. No one solved
10.1? Hang on.
It was sorting 0. It was the wire.
Oh, that fucker. Oh, hell no. I got really close. I got really close.
Oh, is it like impossible?
No, I don't think it's obviously not impossible. There's like one last bit that I thought I was really close, and then I realized I needed a whole other side proof for it, and then I gave up, you know? But I was like I was at the final part of the invariant. Like the invariant was like proving two pretty massive statements, and I was finally in the middle of doing one more lemma for one of them, and then I realized I needed to go even deeper.
Wait, can I see how you guys like what you guys had so far so I can get some.
You post the notebook. I can't access the notebook, but if you can quickly
download in the 2LCD channel, there's a pinned HTML file with all the notebooks.
Okay. I'm gonna stop watching your stream for a second. Or I clicked stop streaming. I'm not smart. Okay, we're gonna stop streaming or stop watching
Okay,
the stream.
there's another joke I'm looking for, but I cannot find it. Let me see if it's in my browser history.
Okay. Okay, so you're saying there's a pin message with all the notebooks, or what? Is this all of them? Oh,
Oh,
that's
here,
pretty convenient.
okay, I found it. All right. So this is every Springer math textbook ever. The following text, blah 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 blah. The essential idea: consider the sum 2 + 3 = 5. An integer 2 added to another integer 5
Okay,
clearly gives the
hang on.
result
I
5.
actually,
Now,
sorry guys, I have to stop streaming while I quickly open my super private channel and pull up my solutions.
now intuitively, this follows. Moreover, this follows. This is like when you open the textbook for a course. Like, you know, it's like the week before class, you just downloaded the textbook, or sorry, you just bought the textbook, and you open it, and then this is what you see.
Wait, where did I post my solution? I can't. I thought. Oh, I saved it as like a text file. Okay, here we go. Okay, let me download.
Have people discovered Soundboard?
Oh hell no. Okay, I'm gonna have to mute the soundboards here. Oh god, I have so many subproofs for this. Oh god. Oh wait, no, I have a bunch of different updated versions of it. This is terrible. Okay.
Yeah. So
This is horrendous that because I'm not in the course, I can't actually save my solutions. So I have to save them as freaking
this
text
is why you
files.
should have become a TA. Then you would be added to Avenue, and then you could save solutions.
I should just ask him. He probably would just let me in, right? Like
He
if
would totally just add you to the course.
yeah, if I just asked him to let me have save data, like surely. Well, I told him I was trying to prove a race swap, he would understand.
Oh yeah, right. And oh wait, did I?
Wait,
do,
no, I don't
yeah,
want to. Yeah, I don't want to open this here. I'm trying to open it open this up here instead. Okay. Oh yeah. Oh yeah. Okay, wait. This is just for the first part.
All right. Okay there. I'm resharing your stream now.
I don't even know if we need like a race swap for this loop. So I don't even know why I'm putting this back in. But whatever. Okay, there's a race swap. Probably completely unnecessary. And then here, okay, let's get where's my proof for sorting 0? So it's one of these messages. I think it's message 3. Yeah, this is sorting 0.
Oh my god.
Wait, no, it's not done. Oh wait, did I not save a final version of this? Why not? Why did No, come on. I had it. I totally had it. Oh, it's down here. Never mind. It's just down here. Okay, here we go.
Oh my god.
All right.
Oh my god.
Wonderful. I cut it out all in one cell so it was easier to copy paste. Okay. So, here we go. Except no, hang on. I had a more updated one than this. So it's this one. This
Oh
one's
my
my
god. Oh my god.
Yeah. Okay. All right. All right. So let's make sure that.
So how about he makes the exam one question, sorting 0.
Okay. Here we go. Yeah. So and then this while step doesn't work because this is not. Oh wait, hang on. Why does it say cannot justify? That implies I did something very wrong. I was probably in the middle of fixing this. I don't know. It works though. Like this bottom part works for sure.
See, when I was young and naive this morning, I said I would prove this today, but I don't
No.
think I'm proving this
You do
today.
not understand this scope of this question.
How can I have 100% completion then?
But look how much half my notebook right now is just being taken up with the like empty space done by the proof checking for this. Like,
Okay, I think we've seen enough of this. Unless
yeah,
you want
I
to
think
do a
we've seen
full,
enough personally.
unless you want to do a full proof for
This is literally like okay. Here's the like invariant here, right? That means all of this is the post condition.
Oh, okay. Yeah, now I see why I struggled with the post condition.
Yeah. So first of all, it just took forever to get it into like what do you have to do? Because first you have to get it into where's the form?
Like a function.
You have to get it into this form, right? First you need to like get it to like this. Because your goal is just to prove oh my god, I don't even remember what this is anymore. It's like
The sorting
prove that
theorem
X
is
is
really
in this
stupid.
range, or prove that I really don't even remember. Because you already have this, but you need to. Oh, yeah, you need to prove that it satisfies sorted, right? That's the entire issue.
The sorted theorem. It's quadruple quantification.
Yeah, you have to prove it satisfies this, and to prove this statement, basically the reason this works is I'm trying to remember. You're proving that it's less than equal for any statement like this.
You weaken it down to just m equals n because it's actually
because you're doing this. You see what I proved first. I just proved that it equals n. It's because m equals n for any possible.
Like I knew this is what
42. They all equal 42. And then I think to do that, I like needed to show all this nonsense. I
Yeah,
needed this. I needed this as an assumption. See, I assume this property, and then now I can
I
create
think,
this.
yeah. Like I knew this is what I had to do. I just did not know how to do it.
Yeah, no. So I knew this is what I had to do so early on, and it took like 5 hours to actually get it to this state.
Yeah. I just have not put in the 5 hours.
Yeah, no, it's not worth it.
He is.
This time
I
I'll do
just
that.
like don't worry about this. He is not going to put a question
This
like
is not.
this.
This will not be on the exam.
Like
Well, the only thing
maybe.
left I have to do is this question mark. I just need like this, but to do this, I need a whole other sub. Like it looks so close, but I do need a whole other like subproof for this and like a mutual implication and some nonsense. But all of this I did to prove parts of the invariant.
We haven't talked about invariant tips yet. Do we want to talk
That is
about that, or do we want to talk about something else?
I don't know exactly what I'd say for invariant tips either. I feel like I always give the same like yap each time, but I don't even know if that yap applies anymore because people always ask in the context of like those number questions. But for like the more complicated loops, I feel like it depends.
I mean, what I'll say is it's a generalization of the post condition.
I think yeah, I agree with that much. I think typically looking at the post condition as your start. A generalization of the post condition. Yeah.
And also, and to be even more specific, it is a stronger statement than the post condition.
I think your biggest hint for sure is the fact that the like loop invariant, or sorry, the loop condition like negated, along with along with your invariant has to be able to prove the post condition, which really limits your options for what you're allowed to use. You know.
Yes, and then your invariant involves something that's changing in the loop. Like your invariant will involve the variables that are changing or that could
Yeah.
change.
Yeah, that makes sense. Yeah, you want to look at how the loop, like what happens each step of the loop, and just see if there's any equality or anything you can say holds.
So like
for each step.
if it's over a sequence, the invariant is going to talk about the
Items,
elements you've
right?
searched, the prefix.
Yeah, it's gonna be somehow like those elements are not just being discarded fully. Like there's typically like if he's taking stuff from one sequence, putting it into another, or like taking it from one variable, putting it into another, like you can combine those in a way to keep the same list the whole time, which is often the trick. In fact, we kind of do that here, right? Like our initial items are always equal to the items we've searched so far that use, and our X is what we're looking at right now that we still have to search. And we can also say at any point that the Boolean is equal to whether X is in only the items we've searched so far. And then, at the end of the loop, once we know that this becomes empty because of our loop condition, now we'll be able to say for sure that our Boolean is equal to whether X is in the entire sequence. But yeah, so I think the big thing is look at your post condition because you know your invariant has to imply the post condition, and look at the loop and just try to figure what you can say stays constant throughout as it runs. Just be creative and think about what mathematical properties and equalities stay true. With if you're working with numbers, there's hopefully some sum that stays constant, some addition of variables. Like if for like the adding questions, if you're working with sequence, hopefully some combination of the variables always gives you the same list of elements. If you're working with clean stars and cry, and yeah. Should check the actual chat.
What the hell's going on?
Dude, everyone keeps talking about this fake invariant strat. This is trolling.
Yeah, do not like.
Oh, is 11.6 still the same? Oh, wait, can we go over making your own lemmas, thought process, or intuition behind knowing to make a good side proof for lemma? Can you give an example of a time? Like, are you talking about when we made that lemma earlier, or? Because for me, I feel like I mostly just use lemmas when I'm working with something that seems annoying to prove inline. Like one of my big reasons for making it, one of the big reasons to use a lemma or a subproof is that you need an assuming or a particular structure, right? Like if you've got, this is not an actual proof for this, but if you've got like some useful thing and proof over here, and you want to be able to assume this, right? That's a big reason to do a subproof. Being able to do this, subproof, and then assuming useful thing. Right, like this can be a subproof, or you can use a lemma for this. So that's one of the reasons you might want to use a subproof or like to use a separate lemma. But also sometimes you want to do a subproof and just use a using. Like maybe this isn't a specific structure, so you want to use a using. Like maybe you're trying to prove some kind of set theory thing that this set is equal to, or like I don't know, you're trying to prove that some set's equal to some other set, so you want to be able to suddenly use using relation extensionality like mid proof. Then you can go pop it into a different lemma. Those are typically the main reasons. Or like the one we did earlier was because we needed to use induction, right? We made it a separate theorem because we needed to use induction for it. Maybe one other case is where you've got some complicated expression. Like here, let's do this.
The server
And it's
icon
basically
is
any
pretty
case where you would use a subproof, this could be a separate theorem as well. So I'm just assuming like I'm kind of using the two interchangeably. But let's say I've got like a complicated expression up here. You know what? Let's copy something hilarious from 10.1. Oh yeah, we're gonna copy all this. Oh yeah, oh hell yeah. Okay. Let's say I've got this gross street on the top, and then down here I've got like this, okay? And so I've decided that I actually just want to prove that these two are the same because I've determined that they are. Then you could do a subproof just for this. You see what I mean? Like, and instead of having to prove it within the whole line, it might be easier to do a separate theorem just to prove this inner part, just to show this inner part is true. And then the subproof will just let you make this swap because you've given it a proof for why this equals this. I find most of the time when I make these subproofs, it's kind of annoying, but you actually have to specify what your goal is up top here. It doesn't usually validate if you don't specify that you're trying to prove these two are the
It
same.
should. It should. Unless sometimes unless it's something like assuming is like kind of polymorphic, because assuming it's either a and chain or an implication chain. So with assuming you sometimes need specific goals. But if it's just like a straight calculation, you shouldn't need an explicit
Okay,
goal.
I don't know because that's what I thought too, but I've definitely had a bug like this before. I can't really validate this one because I chose kind of a goofy ass example with the setup.
It might be if it's inside a using, then you need explicit goals. If you're like nesting
Yeah,
usings.
right. It's this. No, I think it was literally just a setup like this. Like I've tried to just do this before, just doing a subproof for two items being the same. And when I didn't specify the goal up here, it like hated it. It just didn't like it just didn't.
Oh yes, you're right. You're right. Yes.
Yeah, that's what I'm
Sorry,
saying.
you're
Yeah.
right.
So sometimes when you're doing just this proof for the smaller part and the smaller
Yes,
part,
when you're doing yeah, sorry, you're right.
when
Doing
you
a
start a
subgroup,
subgroup, it kind of assumes that you're trying to prove top equals bottom.
yes,
You have to
yes,
specify if you're trying to prove only a small portion.
yes, you're correct there.
Yeah. Okay. Yeah.
Yeah.
Okay. Sorry. Let me see what was said here. So.
Uh,
Again, in regards to structure, but here's an example in the pic. Eulogy scenario is to prove something in 12.1. Which one's I don't even know 12.1.
that is the man semantics clean algebra one.
So is this just like a lemma that he provides? Like he says you guys should prove
He
this, or why do you
no,
have
you
this?
just have to figure it out. Like to understand this, you need to understand what's actually going on, and you need to understand that it's something you can prove. But with
Okay.
that being said, another time you need lemmas is kind of like when you're like context switching. So if you're doing like a while loop proof, but you see some fact, but you see something that's purely sequence manipulation, that's a good candidate for a lemma.
Yeah, sometimes you just have like a general fact that you realize because you understand the material like is true. And
Uh,
it's just easier to pop it out into a separate theorem. Is that like what you're talking about, Daniel?
yes, and then
Yeah.
or also like it is something that would make sense as a theorem. Like the sequence ones you were saying, he could have made those all theorems we had to prove in like week 4,
Mm-hmm.
but he chose not to for whatever reason.
Yeah.
12.2. I don't know how important 12.2
Now,
was.
like again, technically you could do all of that in line, with the exception of having to make a
Yes.
subproof for the one tiny induction part. My induction like theorem or my induction hypothesis. Sorry, what am I trying to say? The small amount of induction I did was literally 2 lines for each one. Like I only did induction on the tiniest part of it. And you could just do that, like so you could do that whole thing in line. It's just I think
Yes.
it's more efficient once you recognize a general property that's
Yes.
true to
Yes.
quickly pop out make a theorem for it. Um,
That you just use assuming the antecedent for that one, Aaron.
Yeah, you would assume this, and then these are very helpful assumptions. Remember,
Those are
all assumptions are super powerful because this S can be
it's
really
it's
anything.
super powerful. Is week 13 important? No.
Yeah, agreed. What even is week 13? But I
They're
just
just they're not even his notebooks. They're Musa's notebooks.
Who the heck is Musa?
I don't know.
Oh, okay, sure. Can I make notebooks?
Maybe if you become one of his if you become one of his grad students.
I want to make a lambda calculus notebook. I'm sad there's no lambda calculus notebook.
There's a reference notebook.
No, it doesn't work. Wait, is there a new one? He didn't as of last year. He hadn't finished coding it yet.
No, there is a lambda calculus reference notebook.
Yo, because last year, okay, for my true equals false bug, I was trying to use lambda calculus, but he just hadn't programmed it. It just didn't fucking work. Unless there was like maybe it was specifically wasn't implemented in the notebook, but it was like the final assignment notebook that was supposed to have everything, and it had theorems for the lambda calculus listed, but they didn't work if you tried to use them.
Okay, no, there is a lambda calculus reference notebook. He talked
Let's
about it for like
go.
5 minutes.
Is it in here? Wait, I got.
It should
I'm
be
not checking it out now, but I'm gonna check it out later. Wait, hang on. Where did
I mean, honestly, just opened it up now. I love lambda calculus. And actually, next year everyone will be set because
yes.
one of the
We have beta reduction. He finished it. Let's go. This is so
one
exciting,
of
guys.
the
You don't get it.
one of the 1JC3 assignments this year was actually on lambda calculus.
Yeah, I'd heard about that. It was all like implementing stuff I didn't even learn about until 3MI3.
Yeah.
This is massive. I'll look at it later. Okay.
I mean, to realize
that's something just has to do with really understanding the material and being able to ration it out. I think one thing that helps me with these is just testing it on a simple example. For relations, I typically like try to imagine. I mean, especially where you're working with partial functions, that you can just treat them as a function. Like you can just assume you have some function of x. Like I think visualizing that makes it a bit easier than relations are maybe just a little bit more of an abstract concept and kind of a little hard to think about sometimes. Like, I don't know, Daniel, I don't know if you've had this. Like, I just almost always try to imagine relations as just being something that takes in an input and provides an output, and then it's annoying when I have to remember that. Like sometimes you have specific properties that only don't hold because they're not actually functions, and they can map to multiple things.
Specifically for that notebook, it's a lot with relational image, and you just have to remember relational image. You to restrict the domain and then take the range.
Yeah.
So if you're doing a relational image and then you're restricting the domain, you can prove that that's the same as the relational image of the intersection, or the relational image under the intersection. That's a different theorem there.
Yeah, I was going after this, and this is fucking. I love Clean Star. Woo.
That one, but it makes sense. Like if you look at it. It makes sense.
I guess this much makes sense because this is a subset of this. Is that all it is? Like, or is it more complicated than that?
Actually, I've not actually done this one. I have not gotten this far in that notebook.
Okay.
But I think
because my first thought would just be that R is obviously a subset of R star, so hopefully that makes it simple. Otherwise, you have to work with actual R star like theorems and have fun. I just hate Clean Star. I did a whole assignment on it, and I still despise Clean Star. I feel like clean algebra was not explained to me in the slightest in 2AC3. Like I already understood it. I already understood that the star meant like take zero, take one, or like take as many as you want of it. But like,
you shall
it's still a gross concept to think about for functions. To compose it as many fucking times as you want. I think it's a good plan. Yeah, exactly. Appeal to his humanity. I think Gabe should stop talking. Yeah, I'm sure you were so sad it was not on the exam. Just so disappointed.
Oh yeah. Just spam the box at the top and keep asking him questions.
You guys ask him how much the curve will be in the box.
I'm sure he loves that. You can also ask him if you'll lose points for doing axiom false.
True. Can't believe we haven't found a new way to prove it yet. I can't believe we haven't found a new true equals false exploit. In fact, I'm also laughing at how easy the old one was.
That one was really funny because he
That one
missed
was hilarious, and you could literally prove anything in 3 lines.
yeah, because it was just yeah, because it was like substitution was just broken.
Yeah, substitution was so broken. Just start a subproof and it was instantly broken.
You know what's even better than talking to him through the chat? When he's in your lab and you can just call him over.
That's true. I called him over during my exam to have him help me set up the while loop structure because I forgot.
That's insane.
Like literally, he walked me through setting up the whole structure. Because my year was all like we didn't have anyone in upper years to talk to. The previous year above us didn't actually have Kyle for LC3, so we just like had to basically guess what was going to be on the exam. We had no info, so everyone was like, "Nah, surely he'll give us the structure. There's no way he'll make us make the structure for the while loop." And then he, in fact, did make us make the structure for the while loop. Yeah, 3 notebooks last year, 3 notebooks in my year as well. One of them has been a while loop both years. One of them has been mostly abstract relational algebra both years. I don't remember what my other notebook was. Last year they had some stuff on like explicit induction, like the expression V stuff. I think both groups had that. That's all I know.
Okay, that's my best guess. While loop probably sequences, maybe like the integers with like the weird sum stuff. Then abstract relation algebra, probably just some stuff straight from the reference notebooks.
He's been doing more explicit induction with you guys this semester for sure.
Okay,
Like
so
between all the quizzes and the new like the whatever the RB lists, like that sort of thing. He's just been doing more. Like they did, I don't think they had that last year. And my year had even less. Like my year didn't have expression V.
okay, I think. Oh yeah, definitely something with expression.
So I would expect some kind of structural induction. I wouldn't be surprised if he brings back like RB lists or makes something new even. Like
I wonder. I'm trying to think if you could do a general tree structure, like because he did like binary trees before, but if you could do like a tree with arbitrary nodes, but that would be quite complicated.
yeah, I don't think he wouldn't be too evil and make it a completely new concept. Like if he's gonna make something new, it would just be something very straightforward and simple. But again, the purpose of making something new might be to test that you understand the idea of explicit induction and what
Yes,
structural
yes.
induction is.
That's the thing is I wonder, or he'll just use expression V.
Yeah.
But he does like introducing new stuff to test what you already know.
Yeah, I didn't even realize that like Max and Min were on like a previous like exercise. Like, as I said, I didn't do the exercises, right? So I would like roll up to the midterms and there'd just be new stuff on there. Like I would have just never seen the Max and Min theorems before, but
Oh
also
my
like, they're
God.
just Max and Min. You know, they're not that difficult. Like,
Well, but they are kind of annoying because you have to know about the indirect equality to do stuff with them.
I don't even
Well,
remember what that is. I just remember that like
um,
it was my first time seeing the theorems and the question still went fine because there were only 2 theorems to work with Max and Min. So it's just like, you know, the best part about new concepts is you only have 1 or 2 theorems to actually work with on those concepts.
yeah, that's like it's like the abstract relation algebra in like the first notebook. There's only like 2 theorems.
Yeah. And aside from like when it gets to be gross for all shit, the temporal logic stuff is secretly really free because you just immediately translate it into equals like other operators you can actually work with
Yes,
and then
yes.
solve it and then translate it back.
12.2. What is 12.2?
That's not temporal logic, is it?
It is temporal logic. I'm pretty sure.
No. I mean, okay, realistically, okay. This stuff is easy until you get to like specifically cell 85 when it becomes like nightmare.
I couldn't do 82. Was I being
You know what?
stupid?
No, I could do 82. I got this.
How about no? I'm gonna pull it up, but
You
whatever.
got it? Okay. It's all
Okay,
you.
well, you walk me through it because
I
okay.
haven't fucking done it.
What do you mean you haven't done it?
I haven't. I don't do exercises. I didn't do this.
So wait,
I just skipped
why?
right to 85 last year because someone told me 85 was
Wait.
hard. And
Oh, did I do it? Oh, I did it.
oh, you
Oh,
did
I
do it.
sorry.
Okay.
I did do it. Oops. Um.
I should
Oh,
do it.
so,
I'm
I
gonna
added
go
some.
through
Oh,
it.
right. I added some cells. That's why the numbers are slightly off.
Okay.
How
okay.
did I do this? Oh, it's bad. It's really bad.
No, this looks fine. This looks fine.
Not when you
You
have
know
a
what,
hidden
literally,
spot.
I got this. I'm gonna try it. I'm gonna try it. I got this. I'm not okay. No more spoilers for me. Oh, I still click stop streaming again. Fuck. Yeah.
How do you keep doing that?
I don't know. I keep trying to leave your stream and I click stop streaming instead because I
Oh,
prefer
that's
the
fair.
green
That's
button.
fair.
Okay, so what's our actual definition for G? I need to find that for starters. Okay. So the first gross thing about these questions is you're basically just copying a whole bunch of like whatever theorems you need from higher up in the notebook, and the worst part is that there's so many of them, so there's so much to scroll through. I've gotten tired of searching already, so I'm gonna just search for specifically G of phi. Oops. Yeah, okay, there we go. Here's our theorem for it. Wonderful. I'm gonna copy this down to our question we're working on. Where is it? Wait, which one was I doing?
82. Item
82.
potency of G.
Yeah, okay. Cool. So we will start with this. I think you just hang on. Because you need to LTL equals. Is there a better structure for it, or do you do like a using LTL equals?
You can do using, yes.
Okay. I just realized last time I did this, I was like keeping them all like together, but yeah, the best way to do it is LTL equals. So let me quickly grab LTL. Is it? Oh no, I need the triple equal symbol. Wonderful. I lost it. Okay. Unlucky. There's equals. Where is it? There it is. Okay, let's grab this too.
But you don't. Oh, you're just gonna put it in a comment because you don't really need it.
I mean, I don't even half the time. I don't even do comments. I just leave the stuff at the bottom.
Oh, that's true.
Oh wait, I've just redefined the axioms. I guess that's fine. Yeah. Okay. No, I just wanted to make sure I had it so I could set up this structure properly. Yeah. So we're gonna do a little using.
It's like LTL extensionality basically.
That makes sense. Yeah. So you just need to have. Oh, hang on. And then I need to do a for any immediately. Yeah, I see. For any t. Now I can do that. This is for is equal to this. And I just need to make sure I'm putting the right things in here. So it should be that, and then that. Wonderful. Okay, no using error at the bottom, so we're good. Also, can I use single equals in this? I don't know what I just did. There we go. Yeah, I can use single equals. Wonderful. Okay, very cool. Okay, now we're going to need to use our definition of G. For starters, if we do it in this direction, right, we're just going to immediately end up with word for word what we were given. Yeah. Semantics of G. And if I do the same thing in this direction, we will instead get G this here. And then what, you just break it up again?
Yes.
Wonderful. Okay.
And
Then
then
we
you
get
have
another
nest.
for all. We get another beautiful for all. This time we have T prime. So I need like a T double prime. Wait, how do you make T prime? Is it slash tick? Okay.
Yeah. The double prime you actually do backslash quote then 2.
Oh,
Get
wait,
the
no,
double prime.
wait, I did that and then I got
No, backslash quote 2.
quote.
Like and
two.
no, not quote. Sorry. Like apostrophe.
Oh, okay, yeah, that's
no,
great.
not.
Okay.
Oh, yeah, that's the one. Yes.
Yeah, tick and then 2. Okay, so it's slash tick number 2. Okay. It keeps autocorrecting, but I'm doing like that combination. Yeah. Okay.
Yeah.
So it's the second one is this. Yeah. And then this should be 2. Okay,
Yes,
is that good?
good.
Okay,
Yes.
cool. Okay.
And
See,
now
so
you
for
have
the
to deal
starters, it's just subbing in theorems, and then from there, it's quantifier work. Like at this point, you're basically like, I think there's no more real like temporal time logic to do, right? Is this
No,
just quantifier work from here?
Yeah, it's just quantifier work.
Wonderful. Okay.
I'm
So I
really
assume we have 2 for all stacked, and I believe you're just allowed to combine these ranges. So let me quickly duplicate this notebook. And let's see what we can do with their ranges then. Okay, so I'm looking for what happens when I have 2 nested quantifiers. I just want to join their ranges a bit because I would like to. Ideally, what I like to do right now is combine these 2 into one thing. Because the actual setup that I'm going for, this is kind of funny. Here's the basic plan. This for all t prime is actually not going to be this t prime. We know that we're allowed to just rename these whenever. Their name doesn't matter. So, in fact, I'm actually aiming for this. I'm gonna change this a bit. Or let me hang on. Because I noticed that this statement has t double prime on it, right? So I'm gonna be trying to work towards getting that instead down here. Because you'll see this step still worked, right? Like that didn't cause any issues down here. I just renamed my variable to a new label. That's totally fine. It's a for all, right? Like, you can rename it whatever you want. What I'm noticing is that if I can combine this, then this range can give me from this range. I know that because t is less than this and t double prime is more than this, right? Then t has to be less than equal to t double prime. So I should be able to get this, and I would just get the statement at the end. Now that would be implication, I think. And I think I saw that you had a subproof done. I actually don't know how you would prove the opposite direction immediately. I mean, I guess you can just let there be some t. I don't know. I'm curious if you can do this without a mutual implication. But also, I forget which for all rules we have, because right now we need to join these for alls. Because I can do a nesting, and this lets me put their range together. Is this the best way to put their range together? Do you know, or is there a theorem that will just let me just put their ranges together without actually nesting them? Do you get what I'm saying? Is there a reason to try to avoid doing that?
Sorry, I was on mute. I had an absolutely awful way of doing it. So if you know a better way, but
Okay,
if
okay.
there-
Because I'm
if
just
there's
trying to
no
think, right now, obviously, I want to combine their ranges,
yes,
and I
it's
would
like
love to do it
this
without
is
nesting
this
them.
is one of those situations where it's so obviously true, you just don't know how to
Yeah,
prove it.
right?
Because like if you have two nested for alls, then it's obviously true. But
I think I'm just
you
gonna
don't know how to-
nest them. I guess for now, I'm just gonna nest them. This is fine. Okay. So I want nesting where I join. Yeah, I want their ranges ANDed together like this. So we'll do nesting for all. I don't need the 1 and 2, right? Yeah, this is. Oh, I see what that is. Okay. So first of all, honestly, at this point, when I start working with these, I just start deleting these types because they're annoying. Don't need them. CalcCheck can figure out the types automatically. All right, very cool. Okay, so we're gonna bring this over here. Or sorry, no, we're nesting it, so it's gonna be like that.
comma.
Yeah, and then we're gonna join the range together, and that it should just be that.
Yes.
Yeah. Okay. Cool. And this can be rewritten as this, but I always hate doing that.
Yeah, don't do that.
Yeah, no, I don't know why that syntax. I actually didn't know about that syntax on the exam, so it really confused me. Or sorry, on the
Yes,
midterm, on one of the midterms, I didn't know about this syntax,
Yes,
so I just had something like this and didn't know you could split it.
the conjunctional syntax is the possibly the worst is the conjunctional because in like the set include like the set
Yeah, no, that's what it was. It
operator
was
is
like
also
y. It
conjunctional.
was like x equals y in something, like it was this.
Yes.
And I was like,
Yes.
oh, okay, so the boolean x equals y is in this set. Like, I thought this was a set of
No.
booleans.
No.
Like, why is it like that? Okay. So now I want to just be able to say this is equal to this, but that's not quite. Hang on. Okay, so we're gonna do one more thing. We're gonna do another nesting to split this again. Or hang on. First, we're gonna do. Hang on. I think this is about to be like a fresh for all or some cookery. I have plans. I have big plans for this question. It's not quite a 1-point rule. Where's fresh for all again? Am I thinking of the right theorem? Because I could do this if this variable doesn't occur in P. No. I don't think I can do that. Because I'll still have this here. What do we?
I will
Okay.
say I was not able to do this without mutual implication.
I'm actually, it's more than I'm curious. Like, if I can't do this with mutual implication, I actually don't know immediately how I would imply it from here to here, you know?
Even with mutual implication,
Yeah, like, obviously implying downward seems easy, but I don't know how I would imply the opposite.
it's actually implying upward. Or both directions aren't too tricky.
Okay. Because I'm like,
Remember that
because I don't have a vision for this, that I'm not seeing why they're immediately equal.
Remember the range is antitonic.
Yeah, because it's left side of implication. Yeah.
And what theorem do you have that operates on A less than B and B less than C? What is
I need
that?
some kind of. I need a transitivity one. What I was gonna check right now was just seeing what my theorems were to work with this because I don't remember what they are right
Yes,
now.
so that's transitivity.
Yeah. I assume it'd be in natural orders. Uh,
It's on the screen right
yeah, we
now.
have. Well, hang on. This is with implication. Do I have one for just? Okay, we have. No, I don't quite want this. Am I just using this?
Or wait, is that the transitivity you want?
Wait.
Or
I want like an and, but technically with shunting, these are the same. Like, because obviously what I can do right now, like I'm well aware that I can immediately say this is true. Like I don't the theorem for this might be a little complicated, but I know that I can prove this, right?
yes, you can.
And then at this point,
But
this is now
but
fresh for all.
watch out. Remember, it's antitonic in the range.
Oh, right, that's what you're saying. Yeah, okay. So it would be so the upway is easy. Oh, okay.
Well, actually, the downway is even easier.
Okay. Uh Wait.
I think because if you just say antitonicity with monotonicity with transitivity or whatever, that should work.
Honestly, okay, everything. I was not prepared to memorize what you just said there, but I'm leaving this as a blank because I know it's possible. But I'm trying to visualize how would you do the other direction then? What would you?
Oh, this I what I have here. It's very interesting. Um, what what is the implication operation you can do when you have a for all? What is the main thing that a for all
You
implies?
just instantiation. Okay, I
Yes,
see. Oh, so you okay? So
you instantiate
you
T
do kind of
prime
want to
to be
mutual
T.
implication this. Okay.
You instantiate T prime to be T,
Yeah. Okay.
and then that gets rid of one of the implications. Or sorry, one
Yeah.
of the for
Then you
alls.
just make that true, and now you just have and yeah, and you just have T, and it's just a one. Okay. Yeah. That makes sense. Okay. Yeah, mutual implication. It is. That's like very gross though.
Yeah, no, it took me a long time. This is gross, and the one below this is the one he says is difficult.
Yeah, no, I have like I probably have a proof for the like part of a proof for this one, but I was not able to actually solve it. But I think I have like a one almost as large as sorting 0.
What?
Okay, it's maybe not that big, but it's massive. It was definitely like taking up like a large chunk of this notebook. Like this, I spent days on this trying to solve it. I was dedicated. It was literally end of exam season when I was like last year, and I was so dedicated
Oh,
to
last
all
year.
this.
Okay,
Yeah,
I thought you
not
meant
this year,
like
but
this year.
last year I poured like a few days in a row during exam season trying to solve this instead of studying for any of my exams. But also third year first semester was very very light, so it was not a problem. Okay, so yeah, you would do subproof using. Technically, you could do like a cyclic implication proof if you really wanted to, but I don't. Maybe I do. Maybe I do want to. You know what? Maybe I do want to. Let's do a cyclic proof. Oh yeah.
Honestly, yeah, the cyclic proof is kind of chill here.
Yeah, this makes sense actually. So I'm trying to do something
Oh,
to
are you
imply
doing
like
a
I'm doing
cyclic?
that. Like I would just do it in a subproof still, just so I don't have to prove as much. You know what I mean?
Oh,
Like,
I see.
and then just get back down to here.
Oh, that's a little bit
Or
different
sorry,
from
I
how
think I want to prove directly to this. I want to prove straight to this.
that's a
Oops.
little bit different from how I did it, but it should work.
Yeah, because I'm thinking I would do that. I just want to make sure like I didn't fuck up. Yeah, it doesn't mind the syntax for this. Yeah, it seems fine. Okay, so then this way,
Instantiation.
I think this yeah. So immediate. Okay, let's break the nesting for starters. Oops. Yeah, so that nesting's fine, and then we can just instantiate this one. Oops. spell instantiating, right? So spell instantiation correctly challenge. Okay. So this should just become this with t prime or equal t. Is that right?
Yep.
Yeah. Okay.
Yeah.
Now we can do
But then-
substitution, which is going to
Oh.
make this a lot easier.
Oh, I see what you've done here.
Yeah.
And then
And
you
then
can use
now
the
I can do, reflexivity of less than equal, identity of, and just get rid of that. Okay. And yeah, cycle of length 1 begins. Yeah, because that's just what I need to get to. Cool. And then now I just need to do the other direction. So first of all, let's make this look a little nicer. So I'm going to want to do this again, I think. So which means I probably should have just done it up there, but it is what it is. Okay. So now I need to do that step I was talking about. So there's going to be some disgusting ass step here. I'm just going to keep this to... Okay, we're going to have some disgusting ass step to go from this to that.
And then it's just fresh for all there.
And then, yeah, this is just fresh for all. Okay, stop telling me a cycle begins.
Step actually isn't that bad. It's just applying monotonicity rules. You just have to.
Well, okay, so because I think I need the transitivity with shunting as well, which makes this a little bit unintuitive. It's goofy that I need to use shunting.
Yeah, but it's just, I think it's just, if you just say anti-tonicity, you need to say, right, because it's.
I think I don't remember whether he might have fixed monotonicity this year to include anti-tonicity rules. It didn't.
No, there's two separate keywords. There's monotonicity and anti-tonicity, and they're two separate keywords.
Oh, what the? Oh, okay, that's crazy.
So monotonicity with, just say with,
But I think the thing is the one anti-tonicity rule we're trying to use right now is also like left, or I thought it has a monotonicity name too, so I don't know if it gets included.
It's under universal quantification, so just check there.
I didn't even realize. I was just thinking of the regular one. I was thinking, okay, I don't know why I was thinking it was going to get turned into implication implicitly. Yeah, I guess we are just using this one.
It's range. No, it's called range anti-tonicity. No, range anti. Yeah.
So if you have this, then you have that implies that. Yeah. Okay. You know what? The keywords are lame. You know what I mean? Like, let's use some real range anti-tonicity.
You need body monotonicity first, because it's inside the first.
Oh yeah, it is inside of that one. Yeah. All right, body monotonicity with range anti-tonicity with transitivity of
with shunting. Yeah.
With shunting. Oh yeah.
There you go.
Easy. Why is it telling me a fucking cycle begins? Shut up. It's supposed to begin. I'm being trolled. Okay, well there we go then.
Hopefully we haven't scared. Hopefully we haven't scared anyone too much.
It's not supposed to do this during cyclic proofs. I actually don't know why it's doing that. Well, whatever. But yeah, okay. So yeah, that's a little gross, but not the worst thing in the world, I suppose. Yeah, it's kind of bad. Definitely thinking through this and remembering about the anti-tonicity and the range definitely got me. And then also remembering that I can do the instantiation the other direction took a sec, but yeah, okay. So the worst LTL questions are just because they're tough quantifier logic. The simplest ones are the ones where you stick almost strictly in the realm of just doing these labels. Like this is a super free one. Like let me just show how easy this is. We're gonna quickly grab. It should just be like, just be that. Quickly grab this guy's definition. Oops. Okay, we'll hop down here. Yeah, where is it? Oh my god, here we go. Okay. So we'll grab this, and then we also need this thing. Where is its first definition? Oh my god, take these bits off. Okay. So we have these now. I'm just gonna redefine them, doesn't matter. And then we'll just do the same thing we did before. So using LTL equals, and let me go grab our LTL equals theorem. So yeah, for these questions, I recommend just grabbing all the different theorems you need and tossing them down here instead. Okay, so yeah, we have this form. We're turning it into this form. So I'm going to have to do. I'm going to start with doing a for any t. I guess last time I forgot to do a for any a, and it didn't really mind, huh? So technically, you don't have to do the for any's then. I forgot, and that's the same for all the using.
Are you just doing the easy ones now?
I'm just doing this one, specifically this one, just to show how easy they normally are for anyone who hasn't done this before. And then that's it. Because this will be a very quick speed run. Yeah, so we would just get this in here, this in here. Let's make sure it likes that. Yeah, and I don't get any using errors, so we're good. Okay. So this would just be, for starters, make sure you understand the brackets of this. Like if you look here, right, it's the brackets are on that. Here, the brackets are on this, right? So this is, the operator X applied to this. This is the L naught applied to this, which changes which of these rules you use right off the bat, right? If you have X applied to something, you can use this rule right away. If you have L naught applied to something, you can use the L naught rule right away. So up here, I got to use the semantics of LTL naught. So we're going to get this basically, I mean, you can see it just takes the naught. It takes the naught up front and makes it into an actual naught. There we go. And then for this one, instead, we're going to apply the X rule, so semantics of X. And then it's just we take off the X, and T becomes successor of T. There we go. And then now we apply the semantics of X rule. So once again, we take off the X, and this becomes successor of T. And if we apply the L naught rule, the semantics of LTL naught, then we would get bring the naught at front, which is just what we have up here. So semantics of LTL naught. And that's it. So most of these questions, at the easiest level at least, are just like using the very basic semantics theorems to expand it out until they're equivalent. It just gets more annoying when you get to the ones where their theorem gives you a for all, and you kind of have to do some weird quantifier logic with like joining their ranges and stuff. And then I don't know, that's prop logic, or that's LTL, that's LTL logic, PLTL. Okay. Oh, I still haven't looked really at this NES map or this NE sequence map notebook. Or this any, I think it's just any sequence, right? What does any stand for? What is it?
Non-empty. So instead of having
Oh.
you have singleton, and that's the only difference.
Ah, okay, that's nice. Okay, we're just spamming memes now. I see.
Yes.
Yep. Okay, whose stream are you on right now? Do you just want to stay on my stream? Okay, yeah, sure, yeah. If you just want to leave it running then, and then we can always trim the last bit at the end. Yeah, because I'm down to keep answering some more questions if people still have questions. Okay, sounds good. Yeah, so Daniel, we'll just stick to mine from now on then.
Sure, sounds good.
Yeah, I mean, even then, if you have to do anything, yeah, I guess I just watch yours, so it's still fine.
And honestly, I need to go eat something again.
Oh, that's totally chill. Yeah.
Or at the very least, get some
You've been hanging
water.
out the whole time and helping us with this.
I think I was the one who started this call 7 hours ago.
That is true. Yeah, I mean, we were like, ooh, if a formal help session at 4 to 6, but it's basically just been a continuation of what you were doing.
Yeah.
Any other problems you want me to go through then? I can take a look at specific stuff from the non-empty sequence notebook if we want.
Does someone want to order me dinner on Uber Eats?
Guys, I think you owe him that much.
Or if you just all e-transfer me like
Oh, just like the
$2.
format of NES. Sure. If you can send the notebook, and just give me a specific question to do. I
We
mean, I
have
could go over the
just
format as I set it up. We have to
yeah.
do X. Oh, hang on. Let me see. Someone had a specific one. We do the non-empty one where we have XSS as the quantifier, where the induction only has X's. What does that mean? Is there wait? Oh, this thing. Yeah, you want me to try this one? Cell 12. How do we feel about that? So cell 9. I have not done the 10.3 invariant, and only Daniel has. I'm not touching that. I've decided.
I have, and a couple other people have done it because I explained
Yeah.
them earlier
I
today.
don't know if it's entirely worth doing. I mean, obviously, like doing hard questions is worth doing because it furthers your understanding. But I think if you can just do 10.4, that's probably enough for the exam. And I think 10.4 on
Yeah.
its own is enough of a challenge. If it's your first time setting up a while loop and if statement stuff. Okay, is this? Oh, this is one of the assignments. I see. Okay, and then 11 point. What was 11.6? I don't remember. I feel like that number sounds familiar. I feel like I've looked at it at least.
11.6 is expression V.
Oh, okay. Anything for 11.6? I think I have a video on that might be helpful. Yeah, I've got this video for it that you can try to go through. And if you still have a question after going through that, let me know. But I think I go through basically the entire notebook as long as it's the same.
It is the same notebook.
Okay, fire.
Did he do this? Did he do the same thing back then, where he actually posted Haskell code for it on Avenue?
I think I went through Haskell code for it. Yeah.
Yeah, because he posted Haskell code again this year, and like
That's
check
nice. I
problem.
didn't know if he went through it. I mean, I've never seen the lecture notes for this course, so like I don't know what he talks about.
You've never seen the slides?
I've like seen them because I looked at them for specifically the clean star unit when I was stuck, you know. But other than that, I would just read the like cell in the homework, and that was
See,
enough to explain the concept.
I have gone to every single lecture.
Yeah, no,
Sounds-
we're like the opposite ends of the spectrum of this course. Like you're just super studious going to the lecture and actually asking Kyle when things are unclear and like getting all the info
well,
and stuff
I've never had
connected
anything
it.
to ask him because nothing's ever been unclear. But you know,
Oh, I just thought yeah, I guess that's well, I feel like sometimes you mentioned that he said this, but I guess you're
that's
just
just
talking
because
about
that's just because I would go talk to him.
Okay. Yeah, so it's not about things being but like a lot of the stuff that you know is just because you've asked him out of curiosity. Like,
Yes.
meanwhile, I have just been fucking around and all like I'm like infinite monkey theorem. Like I've just tried every possible way to solve one of these questions. So like I just know all this bullshit because I just spend way too much time just actually this like solving shit in calc check for fun. Spending like weeks on one question. Dude, I haven't even told you about the assignment 4 bonus question we had. There was like an assignment 4 bonus question that I literally spent a full week on in my year and I could not solve it.
All right. For any, I mean, from my understanding, for any, it's just a proof structure, and you're just, since you know it's a universal quantification, you basically just turn it into like kind of a free variable, and then you could just treat it like that. Like, do you have a better explanation than that, Jacob?
Oh, but why we have to do it? I
Like,
think the intuitive
actually,
understanding for it is when you're doing a normal proof, right? Like imagine this was just a regular theorem, right? You're just trying to prove this for like the way you would think about this is that you're just proving this is true for some arbitrary x's and y's, right? Like for some arbitrary values of this, you're proving it. That's really what proving a for all statement means. It's just kind of the same thing. Like the fact that these for alls are here on the outside just doesn't really matter. So he just has like a statement you can write to pop them off. Like I don't know if that made sense, but that's kind of the idea. Is that you like this like proving this and proving this logically are the same thing. You're proving this for some arbitrary values. This thing it's explicitly stating, yeah, for any value of x's, for any value of y's, you're proving the statement. It's just the same.
okay. Yeah, I'm looking at the textbook to see if it's actually in there. It's not actually in the textbook. This is just something he came up with. Because like the rest of it, like case analysis and contrapositive are based on the textbook. and assuming the antecedent. But for any is not in the textbook because I think they do it less formally. And that's I also read the book. I have the book here.
Oh, crazy.
It was like they have one copy though. It was like October,
okay.
and no one had checked it
Yeah.
out. So
What I'll do instead of copying this is I'm just gonna set it up myself so you can see the way I set it up, and I'll try to explain it. Okay. That's crazy. You have the actual book. I read the book once. I was stuck on one thing, so I downloaded the book and tried to go through it.
no, I have the book here.
That's crazy. Okay, we're gonna
I need to
copy
read it.
this.
Maybe that's what I'll do tonight. I'll stay up all night
You're,
reading the book.
you're insane. Okay. So we want to do a proof for this. First of all, identify your P. So in this case, our P is this whole statement here. Okay. So anytime you see P, know that you're working with this. If it helps, literally go right at the bottom down here, do a comment, and write for yourself that P is this. Okay. Making sure you've set it up the same way that you just want to see something. Yeah, because you end up doing that too. Yeah. Okay. So now we're gonna set up our cases, right? So we'll do our using induction over non-empty sequence. Let's start with a subproof. Or hang on, I don't need two spaces. So we'll start with a subproof for this line here. You don't need brackets on it. Okay. And then we're gonna do another subproof for this whole line. So you should start by just writing this out. I do the same thing in the expression V notebook. Start by just writing these out, right? And now do your substitution. So let me grab P, right? P is this whole statement down here. And that's going to go off the line there, which is nice. I'm going to validate this all at the end. For now, I'm going to give myself a lot of room to work with. Now I'm going to replace every X's with singleton A. Oftentimes, this is going to be an expression, especially using constructors for a term. If you've got some weird term going on here, like we've got, or like some weird data type here, we've got our non-empty sequence is kind of an interesting data type that uses constructors like Haskell. Just where I'm going with this is when you're replacing X's, make sure to put brackets around it so that you don't get any errors with it trying to find the type of length singleton. You don't want it trying to figure out what the type of this is. You're going to get a big type error if you do that. So make sure you bracket around whatever you're replacing X's with. So I'm just going to do the same here. Oops, I did not mean to control B that. Okay, so that one should be good. Now I can delete the substitution, put a question mark there, cool. And then now let's try this one at the bottom. So this is going to get pretty gross pretty fast. Again, make sure you remember what P is. So I'm not including the for all X's because I'm pattern matching on this, right? This statement at the bottom is what you're trying to prove. So typically you're going to have a for all on this. So you basically ignore the first for all in your actual statement. Everything after that for all is P, because this way, like this is my statement, right? My statement is for all X's this. This whole thing is my statement, right? So this only works if I replace if just this part is my P. So make sure I'm checking the chat to make sure that makes sense. Okay. So now we're going to replace P. So we'll do this. This gets pretty long, so I'm going to enter this down to this level. You can just enter this. This is totally fine. Okay. So now, oh, hang on. I just realized this is interesting. So this is actually two things. This is a for all. Oh, this is weird. They only put a type signature on X. Oh, sorry. Okay, this is from the actual subproof I'm doing here. Okay. Yeah, I would just, once you start this, you can like delete the type signatures technically to clean it up a little bit. I'm actually gonna do that, I think. Yeah. Yeah, I'm just gonna do that everywhere because CalcCheck will figure out what the types are. As soon as you put A in a singleton like this, like it understands what its type is. It knows that it's a that it's just some item. As soon as you put it in like the cat, it understands that it's a sequence, a non-empty sequence. So to help you clean it up, you can just delete the colon, like the type signatures. Okay. So yeah, I'm going to, I think this expression is going to end up being our main expression. So I'm going to enter this down here. I'm going to do that. And then I'll keep this up here for now because I'm going to have to copy P into that as well. In fact, I'll do that as well. So now remember P includes the for all y's. I can't forget that, right? So that's P's. Again, if what I'm saying doesn't make sense, just or like you want to ask more questions, please feel free to interrupt whenever. Like I appreciate questions. It means like I can explain this a bit better. I don't always know what's confusing about these, so
Sorry, I just have one question
of course.
about why not the first for all? Like in
Why don't we include this as part of
Yeah.
P? So
Yeah.
because this here, we need our structure. We need our statement to match this form down here. Okay.
For all, okay.
So we need our statement has to be of this form, right?
Yeah.
So if you look at our statement is of this form. It's for all x's and then some expression P.
Empty. Oh, okay.
And when you match that, that's how you know what this P is. It's everything
Okay.
after this for all listed here. So typically any of these custom induction principles have a theorem looking like this where the final statement has a for all on it. That's why it gets kind of confusing, but you basically just think of it like you're popping off the first for all because
Yeah,
then
that's
this P ends up being this whole thing here.
that makes sense. Okay, thank you.
And
Perfect.
just to add a little thing there, there's possible he'll try and trick us with a question where he'll give us one where there's no for all, and in that case, to use the induction over whatever theorem, your final statement has to be a for all. So you have to do like an exists introduction, or sorry,
Oh, so you're
instantiation, and then
saying
a
he might
proof
give
for
you a
this.
statement that's like you're saying he might give you that until you use
Well,
induction.
not this because it has two variables, but
You get the
like,
idea, though. Like you basically
yeah,
you
yeah.
have a statement that wouldn't have the for all any for all on
If
it.
you open up homework 18, I believe, where this was first introduced, or
Wouldn't you still be
150,
able to do this no problem? If he gave you this, wouldn't you just be able to like
you can't. You just open up port 150 15072.
1072?
No, 072
Oh,
15072.
072.
Yeah. And just scroll down, and he has an example here. You scroll down too far.
My bad.
One more up, a little bit more. Here.
Yeah, because that's what I was thinking. Yeah, so you'd have to do instantiation. Now, there's no reason you couldn't do this twice, right? Like even if I chopped off both these variables, you could just do this twice.
Oh,
right?
yes, sorry, you're right.
Yeah. Not
Yes.
that you don't even, I don't think you even would need this. Like you could just get rid of this if you really wanted to
Yes,
immediately.
because unless you're doing nested induction, you don't need the
Oh,
for
you know
all.
what? Hang on, I'm cooking. I'm actually cooking. Wait. You know what? Wait, can
You
I
have to
do
do it
this?
outside. If you do for any x's outside, you can just throw away x's and
Oh, I wanted
induct
to do
over
for any
y's.
Ys. I was just wondering if in here I can do for any Ys, but I guess I can't.
You can just you have to do trading, or sorry,
Yeah, you'd have to do like
or what's it not called?
You do nesting and then dummy list permutation and then nesting again or something, or like exchange of dummies.
there's another theorem for it.
Oh, okay.
There is a theorem for it. Interchange of dummies.
Oh, I was gonna say exchange of dummies. Okay. Yeah, there's like yeah, you could there's like ways to exploit this if you really want to get into it, but he's probably gonna be like nice with the structure he sets up, I would imagine. But yeah, I don't know. It is good
I'm
to
just preparing you for the worst.
Yeah, no, I agree. It's a good thing to point out. Okay, so back to this. I put my P into the range here. I also have prepared this statement adequately. Oh, right, I still need to make my substitution. So my x's needs to become this. Once again, I'm going to put brackets around it. There we go. And now I can delete this. So that should be good as well. Okay, and my using error is gone now. That's the important thing. See, my using error is gone. So if I just prove both these were good, the last tricky thing is just how to get the induction hypothesis. Remember, you need the induction hypothesis. You should remember if we're doing induction, like if there's a P in the range here, then you need to be able to assume it properly. Like typically, just to be able to do the proof, you're going to need to assume it. You're going to need to have this. So the way we assume this is you can always go hop into the syntax help. All right. See this for all introduction. This is just basic syntax for how if you have some for all statement, you can do a for any. But the second one is kind of useful. I usually reference this to make sure I'm doing it right. Whenever you have a for all, I don't know how Daniel does the thing where he moves this, but whatever.
Bottom right. Not that
Like,
bottom right. Above the OK button at the bottom of the scroll bar.
oh, that is nice. Okay. Cool. But you
Except
can
when
you
you
can't
click
you can only
outside of it,
resize it. You can't move it around, right?
and when you click outside of it, it closes.
Lovely. Okay.
So it's
Can I
not that
scroll up?
useful.
Oh, I can scroll. Okay, here we go. Here we go. I just wanted to have this. I just wanted to show how some of these were similar. So, right here we have a for all statement with a range, right? We have a for all. Is this gonna? Yeah, it does go away. Dang. Okay, that's so sad.
You can just copy paste the parts you care about into a
You know
line
what?
by
That's a good
yourself.
point. Yeah, I'm just gonna copy paste this down here. That is a very, very good point. Okay.
And just do Shift A to insert a cell above. You can put a markdown cell.
This works fine for now. I just need this just for now. I'm gonna get rid of it after. But you'll notice that this, if I just delete this T here, and we don't even need this. This matches the structure that I have here, right? I have for all x instead of for all x's, but that's fine. And then I have this as my property in, sorry, yeah, this here. Let me actually put this in brackets just to make it clear what I'm working with. So then this is my property in the range. This is my R, right? And then I have some expression P, which is this thing that I'm actually going to have to prove. So down here, I'm only going to do a proof for this part, and I'm going to start my proof by doing for any x's satisfying this property here. So I'm just going to copy this line, right? So I'm going to have for any x's, right? Make sure to use this variable satisfying this property. And you give it a name, so I usually just call it 1. He always calls it like in hype, but I'm not going to do that.
I like to do brackets IH.
Sure, I'm down. Induction hypothesis. Okay. Now we should be good to start doing our proof for P. Right now we're proving this part, which is here. So I'm going to just copy this statement, or no, not quite, because first we've got our for alls. So again, I'm just going to do for any x, y, or x. I don't know. I don't remember if the other way is allowed. And then I'll enter this down. Always work top to bottom. Okay. I don't really have any errors besides it losing its mind over this, which I can get rid of now. And we're looking good. So no, I don't see any using errors, no nothing like that. So it looks like as long as I prove both these goals, then we should be good. I still have up here want to do a for any a y's. We can start proving this. Seems good. And now it's time to prove. So I have not looked at this notebook, so I have no idea what the theorems are. Length doesn't work on map. What is cat? What do we have for cat? So I probably have to cat first. Yeah, I think I have to do cat first. Cat takes 2 parameters. It's concatenate, I assume. Yeah, okay. And cat with a singleton will just const x and y's. Okay, so I guess we're just doing NES cat. I just keep reading it as NES, so I'm just gonna keep calling it NES. I'm a Nintendo fan. All right, so this should just be const that. Yep. And then this is length of const now, which we can work with. Length of const is successor of length of this. That makes sense. Okay. Probably just NES length, right? So that becomes. I think it was this successor length wise. Yeah, because it's just 1 plus the length of this popping off the first item. And then I want to show that that's equal. Oh yeah, okay. And then is this just definition of successor that this is equal to? I don't know what this is. I don't know what I'm trying to do exactly. Because I wanted to show that this is equal to 1 plus this. I don't think this is the theorem I'm looking for, but I didn't want to have to
Theorem's
look
literally
for it.
called successor.
Oh,
It's literally
crazy.
called
Thank you.
successor.
Okay, I'm a bit rusty. All good. And now we can just do NES sequence length again. Cool. Okay. And then for this part, again, remember you're typically trying to get it into the form of your induction hypothesis. And also, again, keep in mind that for all y's is a very powerful. I don't know if it's going to be important, but keep in mind that having a for all as an assumption is very powerful because this y's can be anything. So I don't need it to be y's necessarily. I can have it be anything. Looking at the form that I'm getting down here, it probably is just actually going to be the same y's, but it's just helpful to keep in mind that this y's could be the whole other expression like const y's with something else, and that's fine. Okay, so once again, we have cat with const now. Is that defined? Yes, it becomes const this item. Okay, yeah, okay. So cat with a const and a y's just becomes catenate these two, bring the const out. Okay. So yes, cat is going to become const this, and then cat these two. Oops. Oh my god, please. Okay, so that worked. Now we have length of const. So let's do, and that was just equal to length of this successor. Perfect. And now we already have this form. So I'm probably now just going to use our induction hypothesis to turn this into that. Or wait, oops, this is just assumption IH. Yeah, looking good so far. Now, normally this would be a bit of a weird step, but because I just remember that like success, like we can turn successor again into length of const something. So we'll just bring that right back. So it's successor is equal to const. Hang on. Oh wait, hang on. This is different though. Oh no. This is this fine? Hang on, wait. This is weird actually. Maybe I think I want to separate this a bit. I think I want to change this a bit. I actually want to bring out the y's. I want the y's over here on its own, and then I want to bring a const onto x's. So what I really want to do here is I want it in this form. I want it to be successor of this, and I just want this guy out of here. I don't immediately know what that theorem is, so I'm actually going to quickly duplicate this and skim
Definition
the.
of successor for plus. Or
I was
definition
gonna
of
say, or I
plus.
was gonna say, or I'm going to wait for Daniel to give me the theorem. Wonderful. Okay. All right.
And then just any seek length. Like
Yeah, and then it's just gonna be NES sequence length because, like we
You don't
said,
even
up
need-
here, right,
you
we
don't-
know that successor just puts it back into length, and now we can make this. Is it just immediately this?
it's immediately that.
Yeah, that makes sense. Yeah. Okay. Cool. Yeah, because this just means the length of this is the same as length of it, const something else, and then we're good. Okay, so that was 9. Okay, anything
Yes,
else from this notebook you want me to go over, or do you guys have any other topics we should try? I saw characterization of transitivity. Yeah, the syntax help was crazy useful. I reference it a lot. That along with I referenced like when you're doing the while loops and stuff. I don't think it's in this notebook. I don't even know why I'm pulling it up.
No,
But
it's
like
not
the
on
yeah, the while loop stuff and the conditional stuff that we showed up here is another useful one that I don't think it's mentioned enough. Just knowing those exist.
You mean you don't just remember all that stuff?
No, I literally don't. I check those all. I mean, okay, honestly, if I had to do it from memory, I would, but I just check them all the time out of habit, and I think it's a good habit to have until you actually fully just memorize it.
I guess I can't complain too much because you're not in the course, so I can't.
Yeah.
You're not having all the theorems memorized.
Very notably, have 5 other courses this semester, so like. Also, we barely touched while loops when I took the course.
That's crazy.
Well, I mean, I barely touched while loops because I didn't do the like
Oh, right.
exercises.
I mean,
that makes it a bit tougher.
it does make sense to emphasize them because one of the main applications of this course is formal correctness proofs, which is using whatever it's called, Horde logic or
Yeah.
or dynamic logic or whatever you
No,
want to
literally,
call
it
it.
was crazy. My first while loop was like we didn't have a while loop on our midterm, like on our second midterm. So my first while loop was literally assignment 3.
Interesting.
Yeah, I had not touched while loops until then. Now it was a pretty tough assignment, like pretty tough while loop. So like it taught me what I needed to know about while loops. But then that had been my only experience. I had done one single while loop question rolling up to this exam
Yeah,
with a
because
while loop on
he
it.
totally changed up the assignments this year. Because this year the assignments are basically the same difficulty as the exercises.
Yeah, no, ours. So
like-
in our year, like the first assignment was pretty challenging. The second assignment was like also very pretty challenging. And then assignment 3 was like just a massive jump in difficulty to the point that like the smartest people in our program were like, guys, what do we do? Like, this is not possible. Like, we had people spending days on it, getting nowhere. It took me like literally, I spent my entire 48 hours of my weekend grinding this assignment to finally make progress.
Okay, yeah, because
And
ours
then
are
our
like
assignment 4, genuinely, I think 5 people completed it.
nothing like that. Like he just posts the assignments whenever he feels like it. And actually, technically, assignment 3 was actually due like 2 days after it was posted because even though it's
Yeah,
not worth, even though it's not worth anything, if he makes the due date for something not worth anything after the end of classes, someone's going to complain.
yeah, he has to make it due by
And especially when
the.
he's the undergraduate chair, the complaints go right to him.
Yep, he's not dealing with those. Okay, so I saw. Can we do? I mean, okay, if you want me to do a question, please link the notebook.
I think
Oh
we
no, I
should
have the
do
notebooks now. I forgot I have the notebooks now.
I
Never
think we
mind.
should do some abstract relation algebra because
I'm down. Is that what this? That's what this transitivity question probably is, right?
yeah, 11.1 through 11.5 are all ARA.
Okay, okay.
And then
Downloads, please. Okay. And yeah, I'm like bookmarking.
yeah, this is for the people in the class. This is on Avenue. This list.
Oh, okay, okay. All right. So actually, I mean, I should just be right-clicking these instead of doing what I've been doing. But here we go.
You realize you can do control click to open a new tab.
Shut up. No, I realize it, but I just choose not to. Not the same. Okay, so 11.15. Wait, 11.5 transitivity characterization. Wait, characterization of transitivity. Where is that? This one. Okay.
Oh, characterization of. Oh yes. Oh, clean star. Haha.
You know what? I'm in a clean star mood. I got this. I'm locking in. I'm harnessing my like highest brain
Watch out.
power.
For this one, the theorem list is not overly helpful, and the previously loaded theorems are very helpful.
Okay, I was just trying to find like, do we not have a? Is the definition for? I still need the definition for transitive here, right? Like, yeah, I need this.
Yes.
This seems like the best one to use.
Yes. So you're going to say using definition of transitive.
Oh, okay. I was just about to do it in one step. Oh, I see. Yeah.
And then you just prove R composed or R star composed with R star is just yeah.
What is this actual theorem called?
Definition of transitivity.
Okay. I'm doing it again. Okay. So I'm just gonna bring this down. I have not tabbed this enough. 1, 2. Okay. So we're just gonna be showing this basically, except this is our star. Oh my god, how exciting! Wahoo!
Yeah.
Okay, no using error, so we're good. Wonderful. Okay, yeah.
And
let me get this. I'm just getting the chat open. Oh no, my phone is dying. I will not be getting the chat open on my phone. I'm at 12%. No.
Okay. Actually, wait. I'm just going to also open this notebook. That's the smart thing for me to do instead of asking you to scroll around. I have 2 monitors, though really it's not enough. I need to upgrade to 3.
I have 1 monitor and not enough disk space. Okay. So, how to clean star? Once again, that is the question, isn't it? Are we supposed to be doing this? This doesn't feel very abstract relation to algebra.
Oh, it's not, or it is abstract relation algebra, but it's not abstract clean algebra.
Yeah, okay. I was gonna say this doesn't feel very abstract of us to use this.
Yes, you do use that definition, and this one sucks.
Oh, how exciting! Okay.
This one sucks.
All right.
That's all I'm gonna say.
Definition of.
This is another one of those ones that is trivially true, or like trivially obvious to be true, and incredibly annoying to prove.
Wait, the book. Wait, why do I just not? Oh, it's there. I'm blind. Okay. Yeah, that sounds like fun. Okay. I'm
looking at this.
Okay, so trivially, we're trying to show that unioning these two Oh, wait, sorry, no,
Or
but
that
we're composing it. But
composing.
okay, because each of these is a massive composition.
Yeah.
Yeah, okay, yeah, makes
So
sense.
with a couple steps, you can like the first thing you want to do is get it to make a nested form. So you have the union, or the union for all I, the union for all j, r to the power of I plus j.
Wait.
Like nest them.
Okay, so you're saying like
Um,
do something like this, and then, or hang on, I should be up here. Like, and then do something like this,
and then
and
you want
then
to
join them
nest
basically. Yeah.
you want to nest them so you get like for all the union of for all I and j are to the power of I plus j. Because
Because
you have
I
this.
almost want to use like this
Yes,
sort
no,
of.
you do use that theorem.
Yeah. Okay. I don't think we have a distributivity of
Yes, there is
for all
actually
of the.
actually a theorem. Is a
Oh,
theorem for that.
crazy.
It's
Distribute. We
it's
have
no, it's
like,
not. No, it's not one of these. Look under the section for union quantification.
okay, because the
Yeah,
composition one would be very useful. Wait.
it's literally right
Oh,
there.
hang on. Yeah. Okay. Distributive. Yeah, that is very necessary for this. Okay.
And just what's fun is there's two theorems that look exactly the same. Just one of them has a slightly bigger union sign
What the fuck? Oh, yeah. Okay. I guess that makes
because
sense.
it's big union, not little
Yeah, it's big
union.
U, not little u. Okay, sure.
Except they're only different by a pixel.
Of course. Wait, hang on. I should be copying this too. Whatever. Okay. So we're gonna get this whole thing union or intersect with this. Yeah. Okay. And then do I have one for the other side too? Yeah, and I have one for the other direction. I'll do it in 2 steps just to be explicit. But yeah, these are both the same theorem, but I need this one from the other side now to now just specifically take this and bring that inside of this composition, and then we end up with this. There we go. That's not too bad. And now we can use that magical theorem we had before. We can use this addition in double star, I think.
Yep.
Addition in
Also,
this.
get rid of the types at some point.
Oh, yeah. You're right. Yeah.
Do not care that they are natural numbers.
So true. Oops. Where's the other one? There we go. Okay. Wonderful.
And now all you need is a diabolical subproof.
Wait. Hang on. No. What the fuck?
And remember
Oh.
that this is an inclusion, not an equivalence chain.
So
So
true.
it's I have a single subproof using inclusion, but actually it's a subproof with a 2-line with one theorem and then a proof for this. So it's
'Cause
fun.
these are equivalent as well, aren't they?
Yes, like it's like one of these things that's like painfully obvious. Like you know what I mean?
Yeah,
It's one of
because
these.
this is just
It's
I to infinity, and this is just like all possible combinations of numbers.
of I
Like,
and J, which is
yeah.
like they're. It's like one of these things that's painfully obvious that they're equivalent. I'll give you.
What are our what do we have for this like concept?
Oh,
I'm wondering if this can be
I'll
done
give
as
you.
like.
I'll give you.
No, you
Look
can't
at
do that.
look at the theorem list for big union again.
Yeah, because that's what I was gonna do. I was trying to look through this because like
Um,
maybe there is a helpful thing
There
here.
is at the very bottom, I think.
Oh yeah.
Yes, the third last theorem.
Oh, okay. Wait, hang on. If I have, because I'm trying to show that this. I want to show. Oh wait, hang on.
You see now.
Oh, wait. Because
Just
that lets
copy
me
the
take
theorem.
literally this and show this is just a subset of this.
Well, the whole thing. Or maybe you can do the inner part as well.
Because that's
No,
what
I
I'm
think
thinking. Yeah, because I'm trying to. If I have this, right? Like if I have this, this is kind of like if I can show. I don't actually immediately know how I would do this, but if I could show this, oops. If I could just show this specifically,
But
right?
the thing is, that doesn't work because you have J in there. You don't have
That's
to,
what I'm wondering. Like, can I? Well, I guess. Like, can I
just
show this is
but
true for any J? You know what I mean? Like,
just apply the characterization to the whole thing. Like apply it twice.
okay, wait. What do you?
Just copy that whole theorem, so you don't have to keep going back and forth.
That's
Like,
true. For starters, yeah. Let's copy all this.
So the shape of that theorem matches the shape of the calculation we're trying to do. Like the RHS of this of the theorem, of the right-hand side, that matches the shape of the calculation we're currently trying to do.
Yeah, because I'm looking at like this being Q, this being R, right?
Yeah, but that.
But the problem is that this is not like an immediately like provable thing.
I think in the interest of time, I will give some guiding help.
Yeah, that sounds good. Yeah.
So start as subproof.
Okay, so right in here, yeah.
Yeah. And then copy the line above. And then on the, as an expression, say that's a subset of so say on the same line.
Oh, got it.
Not as a calculation, as subset equal. You realize you can do bracket equal, like / open bracket equal.
Oh, that's crazy. No, that's an awkward. I'd literally rather type on my keyboard than have to. I'd rather
Okay.
fail it 3 times and type it than have to
Okay.
do the fucking bracket equal.
Okay. So then copy the line below. And now apply the characterization twice. Well, you can do it as one step.
So you're saying turn it from this into.
Oh, you're going to need some brackets around that, because right now you're going to need more brackets around that left-hand side, because otherwise the quantification extends too far.
I don't understand. Are we not saying we're doing this way? We're not turning it. Oh, sorry. You're saying this. You're saying this.
Yes,
needs
you need another set of brackets right there. Yes.
On the top. Okay. Oops.
Oh, why is it vehemently unhappy? Oh, because your RHS is wrong. Because it's the line right there. Change the those to for alls.
Oh, crazy. Oh, that's a for all. Oh. Wait, is it that? Okay. I didn't even notice that was a for all. Okay.
And then you can apply it again. You can apply the characterization again. And so now you just all you do is remove the brackets and change it to a for all. Because you're moving the subset inside the quantification.
So I'm looking at this now where
You're
this here is a subset of this here.
So then you move the subset inside the quantification and change it to a for all.
So this gets moved in here.
And then it becomes a for all.
This becomes a for all. Okay.
And then you can remove the redundant.
And then I can remove this pair of brackets. What the fuck is this? Okay.
And now wait. And now you want to go back, and now you have for all, so you want to use for any. So I went to proof for this, or you can do another subproof.
Yeah, I'm doing subproof.
What's wrong with proof for this?
I don't even remember how to do that, to be honest.
I've never indent it, and then you say proof for this.
I'm doing subproof.
Nested subproof.
Yep.
So now you can say for any ji.
What am I even trying to? I forgot what the goal was, to be honest.
This is just true.
Wait, no. Oh, we're just getting. Yeah, we're just working towards true. Okay.
So then you want to say for any ji.
Yeah.
For any j, then I.
This is the worst ever. Okay.
And now you have a very short expression, and prove it step by step, using subset as the calculation operator.
Oh, okay.
Yeah, you see what I mean? Yeah. Oh, except this is fucking awful. Bottom up is.
Goal is not a universal calculation. What the fuck are you talking about? Like hell, it's not.
It's because you need to do subproof It's because you need to do subproof 4, and then just copy the expression on the left, because it thinks you're trying to prove that the one on the left is equivalent to the one on the right, but you just need to do subproof 4, and then just just that, and then it'll be happy.
Wait, I don't
No,
know.
like
Just
like that whole expression, yeah. And that should make it happy.
oh, interesting.
Because
Okay.
before it was
Normally,
import.
I thought the subproof first assumes that it's trying to do this to this. I
No,
guess I should have
well,
looked. I
it
didn't
is.
actually look
No,
at
no,
what
no.
it's
But
doing.
what's it if you like put your what it thinks you're trying to prove is that that expression above is equivalent to the one below, which is not a universal
Oh, I see.
representation.
And the problem is, wait, hang on. So is it because this for all is bound to just
No,
this?
no. It's
Oh,
go into the subproof. Go into the subproof 4. At the end of this, like in your code. Like yeah, like at the end, like the very end. Then say equivalent to true. Like that's what it thinks you're trying to prove, but you can't do for any on that. That's the default what it assumes.
Oh, because it's an equality. Okay,
Yes.
okay. So if I had done like, no, wait, this still doesn't work. This is not.
No, it doesn't. It doesn't work.
Yeah.
This is why proof for this is superior.
No. Subproofs all the way. I'm a subproof main.
All right. This okay. Now this part requires knowledge of the above. If you scroll up, I don't know if he provide. I think he might provide an example for one of these proofs. No, he doesn't. So scroll
This
down
still
a little
sucks.
bit. Or wait, scroll down a little bit more. Oh
Wait, one sec.
no, you're on your own. Okay, I'm just gonna have to give this to you because it's like this is like there's like rabbits in this whole proof.
No. You know what? You know what? I got this.
All right,
You know what? I'm gonna cook. Okay.
work bottom up at least.
Does this make any sense? Is this allowed?
You're very close to the. You're very close. Except
That's not what. That's not how
that's
this.
not that's the wrong identity.
Wait, that's also not. That's the wrong symbol.
Then there you go.
Okay, I was cooking. Okay.
And now you are very much cooking.
Why are there 21 range split theorems?
Because this has all the quantifications loaded.
Okay. Now
How
we
are there,
range
how are there
split.
still like 40 people watching this? This is
No, this is actually
probably not.
crazy.
This is not even
insane.
helpful.
Literally not. Wait, no. It's union. Yeah. Okay.
This is like, yeah, this is insane.
No, we are very far gone at this point.
Yeah, if he puts this on the exam, like I might be the only one who gets it.
Yep, I'd get it too. Don't worry.
Well, you can come right. BSB 241.
I'll be there. Wait, well, that's great.
That's gonna fail because you have an equals, or sorry, because you have a subset for the 1 point
So true.
rule.
So true.
And it's still gonna fail because it's wrong. I equals I.
I think this expression is not allowed to have I in it, which is really sad.
Oh yeah, you're doing something wrong. But you're very much on the right track.
Could not agree more. Okay, new plan.
Oh wait. Just wait. Oh, I do use a K. Yes. Oh yeah. Is that all you need? I think that should be good now.
Easy.
Yeah.
Okay. Remember the OP trick of renaming your variables, all right? Last year on the midterm, everyone fucked up, or on the exam, everyone fucked up the expression V question because it was so similar to the previous one, but you just had to like know this trick of like you had a variable name like
There was
the theorem
Oh.
given had the same variable name that was used in the actual question in different quantifiers, so you had to know to just rename it and know what he did.
Yeah. There's also I forget which notebook it is, but he explicitly like does like it's a it's a while loop correctness one, and he has a step that like introduces a variable just to fuck with your just to fuck with the quantifiers
Yeah.
in the
Just
invariant.
remember that this I it's talking about here is a totally different I from this, you know, like this is just unioning all for like some letter. Like you could change this to K and there's no problem. It's just
In
straight up
fact,
like it's not the same I as this one in the for all.
yeah.
Just different variables. So just watch that. Try to have a good understanding for like when these letters are the same and when they're not. Like this one's scoped to this union instead.
Should we prioritize 11.5 or 11.6? 11.5, I would say. But don't worry about getting every single proof. Understand what the clean star means. Understand what the reflexive transitive closure means. Okay, is that the proof? Did you get it?
Yeah, I think so.
Yeah, you're just missing the theorem you didn't prove at the start.
Yeah, so that's fine. I'm just gonna drop.
So yes, this is like a diabolical tier proof.
Yeah, I was looking at if I can simplify it at all by just.
I think I did not figure this out. I think I stole this from someone.
Mm-hmm. I'm just thinking about, is there no way to make this a bit better by like doing the range split sooner?
Because the issue is like you have to do that characterization and then you have to do that for any to make it.
I just want to look at what this looks like. I just want to see like if I just do 0 of Oregon.
Like I spent a good while on this. Fuck, it's almost 7 p.m. I'm definitely not making myself dinner.
Definitely not. Like if I just get something like, because I could do something like, I don't know, I'm just fucking around at this point. I've already done this, so I'm just gonna delete all this now. Because I pasted it. I just want to.
I mean, you can also just duplicate the cell.
It doesn't matter. If I need it, I'll go copy it from the Discord again. Because I just wanted to shorten this over here.
How are there still? How are there still so many people here? Because there's still like 20 people or something.
Pretty crazy.
31 people.
You know, because this just gives me strictly like.
If you each sent me $1, I could go buy dinner.
Yeah, I see. So you need to do the characterization to get this into for all form. Okay, yeah, that's gross. Wow.
You guys don't actually need to send me money. I'll get paid for this next year, so it's okay.
I guess this makes sense in a way. Okay. Fun question. I made custom induction 100 times easier. Let's go. All right. Anything else you guys want me to go over? What are we thinking? There were kind of some questions about 11.5 or the one we just did, I think. What's the reason we didn't need the brackets? Or was this about a different question? I think it was about
I think this was the one we were working on.
Yeah, what's the reason we didn't need the brackets next to the for all J?
Because the whole point of that characterization theorem is you're moving the exists inside the for all, which means you don't need the brackets around it anymore. Or sorry, not the exists, the inclusion inside the for all. Which means you don't need the brackets anymore because it's actually inside the quantification.
Yeah, we were trying to turn it into this theorem, into just this left side here, where like the for all extends to the whole statement, this whole subset relation.
Okay. 10.3, I have 10.3, so I'll pull that out. So if you're not watching my stream, switch to my stream.
Okay. Good solution for
10.3.
the false true branches of the conditional.
Okay, so
Oh yeah, this reminded me. You know what was a fun one? The post condition for the ghost, like the faster LM was kind of fun.
oh yeah, that one was kind of fun. I'm just gonna grab 1 second. I just need exercise for the reader
Exercise for the reader.
because I didn't prove it earlier. I left it as an exercise for the reader earlier. So if I put that in here, okay, yeah. So here's 10.3. You guys can see my screen, right?
Also, I'm not scrolling up, so if anyone had notebook requests earlier that I didn't get to, just feel free to post them again.
So what specifically? Any questions regards to 10.3? Witness, sure. Maybe I'll just give a high-level overview of this quickly. The reader is this lemma here. Just it's a thing about lists that we just don't have a theorem. If assignment to a ghost variable, do we treat it? No. When you're doing assignment commands, you treat the ghost variable the exact same way. It's just you treat it like a regular variable. It's just the ghost variable does not execute the code. The false is this. It should be proven now. Yes. So the true and false are very similar. Let me just Control X. Then they should. Okay, they're kind of small now, but they're both on the screen now. So they're very similar. So people were asking about witness. It's in the syntax help. So once again, take advantage of this. So it's saying, so in this case, we're using this second form. But what you're saying, there's two things that witness is. There's the theorem, which is occasionally useful, which literally says if exists implies something, then that's actually the same as for all with the implies on the inside. So it's almost like a distributivity of exists over implication, but it's just called witness. Do you have anything to add there, Jacob?
No, not about that. I don't honestly. I'm not very familiar with witness. I avoid it when
Okay,
possible. I had to use it for one assignment, and I've forgotten it since. I didn't use it all last year.
Wait, I did use it earlier today. What did I use
I
it
used
on?
it in one question this semester. I've used it in like one question just to simplify
Oh,
something. I don't
it's
think I've done I have
useful.
not done an assuming the witness except for when someone specifically asked me to show how the
It's
search report works.
it's useful in
There was a specific notebook where he said to do assuming the witness, and I did it for that notebook, and that's the only time I've touched it.
yes. But the structure assuming the witness is you say assuming witness y, so that's the quantification variable, satisfying p, so that's what you're quantifying over, and then if you're proving exists implies q, then that's all you need. If you just have q and you have this assumption, then you can say by assumption and that. So I'm saying by assumption 4.
The top one is kind of pointless, right? The top one can just be done by doing the second version by assuming it, right?
Yes, you can do it. It's because this is the top one. In this case, you could write assuming exists whatever, and then assuming
And then
witness by
yeah, exactly.
assumption.
I'm now assuming witness y. So basically, these are just ways to work with having exists as an assumption. So if you have an
Yes.
exist implying something, this is kind of the best way to work with it typically.
The key thing here is I rename y's to u's to not conflict with the other y's I have in the other quantification. Yes, I use witness. I use witness because there's no ghost variable.
Yeah, if anything, I think it'd be best to think of our witness is our ghost variable, really. Like our witness is
yes.
what the ghost variable was
In
before.
fact, because that's what he says. He says that. He even says that here. And no, he says that here. To some degree, the ghost variable integrates as part of the proof structure into the program structure. Assignments to the ghost variable give it the values you would have witnessed using your exists introduction steps in. He says 7.3.
Yeah, in 10.4, there's no reason to use witness because there's no exist statement.
There's no exist. There is no exists quantification here.
More likely you'll get 10.4. I'd be
More,
surprised if he makes you come up with an
yeah, I
invariant
think
for the
much
witness.
much more likely 10.4, and he'll test our quantifiers elsewhere.
Yeah, I think purely 10.3 exists to show you how helpful the ghost variable is, and I doubt he would show you that and then just like give you a proof without one
Yeah,
when it would be
10.
useful.
I think this is like because like one of the applications of this course is formal software verification, and ghost variables are a real technique used by software verification tools to
Yeah.
make verification easier.
Like you said, efficient languages will like compile it out when you run it. They'll recognize the variable's not useful and compile it out. But but then at the same time, if you've got programs that are checking your code and verifying its correctness, then
Yeah.
you can put having the ghost variable there is helpful to
In
prove
fact,
that.
let's see.
Because there's a lot of software where you can like state an intended invariant for your function, and you can have like the program automatically check that it's always that invariant is always maintained
Yeah. So
as you modify the code.
this is ACSL. I forget what it stands for. The ANSI C specification language, which is for like formally verifying C. So this is CalcCheck, but for C basically, and it has special syntax for ghost variables. I think he showed us this. So like ghost code cannot modify non-ghost code. It's like ghost variables can't do anything that can actually affect the code because they're not real.
Yeah.
So like he gives. Okay, this is not worth looking into. But like this is like if you complain this course has no real world applications, then you're being disingenuous because it does.
That's true.
It's more likely you'll end up writing React web apps than doing formal software verification. Uh, 3.1, sure. Let me pull it up.
What was indirect flow? Oh, I haven't even seen this. What is indirect
Indirect
replacement?
replacement is the same thing as conditional replacement.
Oh yeah. No, I have seen it.
He
Yeah.
he
Okay.
renamed it. Actually, I won't load my proofs. So indirect replacement is fairly simple. If you have a theorem that proves something is equal, and you have that something, and you have P implies. Oh right, yeah. So this is you have this theorem, and then you have P. You can do the replacement. So actually, I'm honestly just gonna load my solution here. Did I even use indirect replacement? Yes. Oh, I got a little bit. This one. Yeah, sure. So it was a little bit. Oh my god. Oh right. I had issues using it without a subproof. I'm not sure if there's a better way, but because you have other garbage, like you only care about the x's not equal to eps, you don't care about this stuff. So because you have the other garbage, in order to make sure CalcCheck doesn't get confused, you do a subproof where you're just talking about what you want, but then you just say by indirect replacement with non-empty sequence decomposition. And it also requires explicit substitution steps. So this is bookended by substitutions. I'm not sure if there's a better way. The other way to do this is the assuming strategy. Like that's the Jacob method, is where you just use the assuming thing. Subproof.
Yeah. I've been avoiding using indirect replacement recently. I just assume whatever I want to start a subgroup.
Because I
Assume
think
it.
the issue I had here was when I just this theorem should work. Like this is a valid step to me. I think it's just a limitation in CalcCheck. It says could not
Yeah,
justify.
I had a few people actually asking me about this. I remember now that they could buy
But
this
what you have to
program.
do is you have to tell CalcCheck to ignore the garbage and for some reason, like the Leibniz isn't working properly because it's supposed to check, like look for different sub-expressions, but I think the search space is too large or too complicated, so it just gives up.
Mm,
But it's interesting that it says cannot justify instead of timed out.
yeah, I don't.
I may actually ask him about this because this is new, so he may not have realized these limitations.
Yeah, yeah. Conditional placement is I think new to this semester.
Yes. Yeah, and he renamed it to indirect replacement here. But yeah, you can just if you that's always a strategy is if applying a theorem isn't working, you can do subproof 4 and then just exactly what you want to replace and then do by, and that eliminates a lot of like work for calc check basically. Because you're telling it this is equal to this via these theorems, and it has a lot less to try and it has a lot less to guess, so it succeeds. Yeah. Yeah, so that's kind of great, because I had to cloned it. Assuming we kind of you mean yeah, sure, I can do that. So the other way to do this, so is instead of doing this, I'm going to get rid of my substitution steps. So we're going to say, so the one thing is the indirect replacement gives you an equivalence. The assuming method gives you an implication, but in program correctness, it doesn't matter because you get to use implications. Otherwise, it would become a little bit more complicated. So I can just say, so this is just going to be 1. That's the stuff I don't care about. And that, or actually, I'm just going to try the, or no, actually, I don't remember.
Oh, you're trying to make it all one assumption and just see if you can have it implicitly like separated.
Yeah, I'll try that later. I know
Sure.
this will work first.
You don't need an explicit subproof 4 in this case, no. You can just write
No.
subproof, assume the stuff you want, and then just toss everything else as part of your actual proof. Yeah.
So,
So
wait.
this is by far like the laziest method as well. It's just super easy to set up quickly. Like as long as you just know how to do the indenting for subproof, that's all you need.
This is and I've realized I have a redundant R's here because like
Oh, nice.
Whatever.
Yeah, it's fine.
And then X's. Oh right. Actually, this actually the only thing I need the only thing I need to assume actually is this. I don't actually need to assume anything else because this will work fine in context. So I can take this expression.
And just make sure you include anything you don't assume you still have to include. You can't just start getting rid of stuff. Make sure you include everything.
Well, you can get rid of stuff, but that's weakening.
Well, yeah, but I mean, like in this step, like when you're setting up your subproof like
I
this,
know.
yeah. But yeah, if you want to get rid of stuff, then put it at the top and then weakening it out.
Or even just assume it and do nothing with it.
Yeah, you could also just exactly. Yeah, you could assume it and just never use that assumption.
And then I just need to bring. I have this here, so I just need to bring it back.
Yeah.
I just need to bring it back from the DAD.
Yeah.
So that's the assuming method. Yeah, so that's one way of doing it. You can do it a whole bunch of different ways. You could assume everything and then bring back individual assumptions separately.
But that's
Or so this is a very flexible method. I will say that because this results in a lot cleaner proofs in 10.3 with the witness. So this is a very flexible method. It's almost less annoying than the indirect replacement because I think it might be an issue. Maybe I'll talk to him about it, although I don't know when I'll have a chance.
Yeah, and I wonder what he does because I'd be surprised if he just doesn't like like test these theorems with a solution?
Well, I don't know how much testing he does.
I guess I'd be surprised if he just makes a theorem and looks at it and goes, "Yeah, that's provable." Like, just doesn't test these notebooks.
Oh,
You
I
know?
think he definitely does test them.
That's what I mean. Like, surely he has. Like, I'm not saying he does a lot of extensive testing, but surely he has a solution for this. So I wonder what his solution is if he's not using this theorem, or like how he uses this theorem to make it work.
Could I see the while loop for this assignment? Yes. It's not overly helpful because I just reference all my other theorems. So you're gonna have to tell me what specific part.
I'm going to guess you want to see the invariant part, but also isn't that what we were looking at? I don't know.
Okay. So I break it down a lot.
Yeah, because first you reach the
Or-
if statement, then you
or
break it down
sorry.
into two cases.
While with invariant. Oh, and then so first I have this. Oh, okay. This proof says nothing. There's not even any assignments in here. So this just delegates to the two conditional proofs. So then I have a true and a false proof. And they're both kind of straightforward. You just apply abbreviated replacement and then non-empty sequence decomposition. And then some manipulations. Yeah, I don't most of this is the indirect replacement part. Oh my god.
It's going all the way to the right. That's crazy.
Yeah, so I say true and false. I mean like then and else. Like so I have a lemma for this branch and a lemma for this branch.
I think calling it true and false makes sense.
True, I guess.
Yeah, just when the loop condition or when the
Yeah.
conditional condition is true or false. Yeah.
Yeah. It doesn't really matter what you call them.
Mhm.
And then this invariant one is almost useless because all it does is just calls conditional because there's no statements outside of the if. So almost this one I could just inline here.
Yeah, but
It does
it's a
make
fine
things.
habit. It's fine to do this as a habit and then set it
Yeah.
up. Yeah, what I would have done and when I do these is typically once I have the if statement, I just make a whole other theorem. Instead of doing conditional with these two statements, I just make one statement. Like I would have just had conditional with only a single subproof. Actually, no, hang on. Would I have done that? No. Sorry. I think I would have delegated instead of the whole conditional with line. That would have all been one like lemon name. Like that would have just been like if statements.
Oh yes.
Like that whole like all of that, including conditional, would have just been a delegated to a theorem or to a lemma as well. And then my lemma would just be like using conditional and have two subproofs. That's usually how I set it up.
I like how I just completely took over your help session.
Oh, no worries.
Like I don't know if was it just you who was planning on doing stuff? Like I assume there wasn't any
I
slides
don't
or
even know.
anything.
Okay, honestly, I'm not even on the team running the sessions this time around. I just volunteered to show up whenever. So like both of us basically just took over this one.
Okay, we just took over.
Yeah, I don't know. It's exam season. Everyone's busy. No one's complaining about free
Okay,
help.
that's fair, honestly.
Yeah.
Yeah, no. Okay, what is this? They are not in the voice channel, so I will answer that later.
Salsa, I just saw your DM. Did what I say like explain? Like, did that answer your question or? I ended up like I think almost answering your question without even seeing your DM until just now.
Yes, I did also
Yeah, okay,
separate the
he
post.
said yeah, okay.
I did also separate the post condition. Oh yeah, this is one of the fun post conditions where you have to do
Yeah, the proof by
cases.
cases. Oh, you did this differently. Okay, interesting.
It actually doesn't matter. You can do it either on R or on this. It doesn't matter.
Yeah.
You just
Oh,
have
okay.
to
Yeah.
hand
Yeah.
over the
I did a.
cases.
I did a subproof and then assuming that, and then did a by cases with completeness by that assumption.
So this is how yeah. So these ones, this style, when you end up with this, you apply the De Morgan and then you end up with an or. So you basically have to do it by cases. So in one of the cases, you can substitute x's for e, and so that or for f, sorry, and that makes it easy. in the other case, there's this theorem, abbreviated replaced by false. So
What
this
the? I'd
basically
not use this. What the hell?
this basically says when you have not R and something, whenever you have R in here, you can replace it with false.
What the heck is this? Hang on, I did this differently. Okay, wait. Let me find my solution.
There's a ton of different there's a ton of different approaches to this, which makes it hard to give suggestions. But yeah, these abbreviated replaced by true and abbreviated replaced by false, because you have it in an and, it's basically saying we know this is false because it must be false for this whole thing to be true. So any other time it appears in this expression, we can replace it with false. Yes, 10.4 is easier than this because it doesn't have, or sorry, 10.4 has a second while loop that is the same difficulty as this.
Why do you have an R variable, by the way? I don't have an R variable. Mine is B. I was just wondering.
Here in post condition?
Yeah, is this faster Elm or is this something else?
No, this is assignment 3.1.
Oh, this is totally different. Oh, wait, I was thinking of the wrong thing. Okay, never mind.
But
That's
it's
why I was
they're
okay. I was totally thinking. I was thinking of faster Elm this whole time. Like,
but
I don't
they're
even
the,
know why. I just totally
they're,
used
they're
B
the
because
the thing is they're the exact same thing.
yeah, it was like, well, it was a similar setup, but I also just remember the variable being true, so it was like because I just wanted to
Yes.
replace it with true and it would make this
So
easier. I
yeah,
immediately just went
so
to using that.
Alicia, to answer your question, 10.4, the first while loop is easier. The second one I would say is equal in difficulty, at least in terms of the post condition.
To me, the second one, it just has a slightly harder post condition, right? That's
Yeah,
just it.
that's all.
Otherwise, it's identical. Otherwise,
The videos, this entire thing is being recorded.
Pavlos is
and-
recording this entire thing, but I'm unsure when he's going to be able to get the video up because it is like a 3-hour video at this point that's going to have to get uploaded.
Oh my god!
So and then that means it's not really going to be up by any usable time.
I've been in this call for 8 hours, and I think I left for a total of like 30 minutes.
Insane. I look these are for abstract clean algebra to show up. I don't know if I can put a number on that, but it's not impossible. It's a scale of 1 to 10 for how evil you think he's going to be. It's the probability. What is 3.1 difficulty? What's 3.1?
Oh, like
Assignment
assignment
3.1?
3.1.
Oh, I was thinking like notebook 3.1.
3.1 or 10.4. It's hard to say.
Which do you think is harder? I haven't done 3.1.
They're pretty similar. This one, wait, he gives us the invariant.
Yeah, because it's just going to take time to upload, right? It's a 3-hour upload. It'll probably take time. Like, we'll try to get it up as soon as we can. But
Yeah, because it might need some editing, and then it'll need to be uploaded.
Yeah, but it doesn't need any. I doubt we're going to edit it, but I think we'll just dump the raw recording for now at least. But yeah, it'll just take time to go up.
Yeah. I think both these would be fair game. Yeah, 10.4 first loop is easier than the second one. I would guess he's going to give us a trickier post condition, but remember, you could like prove the rest of the loop without the post condition first. Like that's the thing with the while loops is there's like four separate key things: the structure, precondition, loop invariant proof, and then the post condition. And they're all like entirely separate, basically. Like, well, they are entirely separate because I do them each as a separate lemma.
Yeah, you do them all separately. So if you can't do one of them, like you can still get all the marks in the other section.
And if you show you understand what you need to do, you just weren't able to get to the goal, that's also all right.
Yeah, I think just remember you don't fully need every part to be green. Like if there's some part you conceptually understand is right, but you just can't figure out that one part, like just like maybe make a helper theorem for it and don't prove it, just to show you understand. Oh yeah, this should be a theorem, but I just don't know how to do this one part, and move on.
Yeah.
It's also fine to leave it as a question mark just so you can keep working on it, but try to fill it in with a lemma
Yeah.
later, just to show it's a real property.
Yeah. Hopefully the while loop is heavily weighted because we spent a lot of time talking about that and not much time talking about the other stuff.
This is true. Yeah. If there's any other
So,
concepts, I mean, we also went over structural induction now, and
oh
apparently
yeah,
my
sorry.
explanation helped a lot for that. So that's
Okay,
good.
yeah, that's true. And because I think if you're honestly, if you're solid on the while loop and the structural induction, you should do.
You should be able
these
to get
good.
a good chunk of the marks. I just don't know. I don't know what else he would give that would be tough aside from like a really niche like bags. You know, like it'd be something super random. Like he would just pick bags and decide to give a really tough question. That's the only
Structural
way this.
induction, yeah, structural induction. 11.6 is the hardest instance of structural induction, but it's also homeworks 18, 19. Let me just pull up my thing here. So structural induction
And there's
is
also that
homework.
quiz for the RB lists as well.
Yes.
I don't know if RB lists were ever an actual exercise after that, but
No, but the non-empty sequences, like the 3.2 is supposed to be similar to the quiz material.
okay, okay.
So they were homeworks 18. 18 was the initial introduction of explicit induction. 19 was binary trees. Nothing on assignment 2 for them. Then it was exercises 9.1, 9.2. And I think, was it also 9. Oh, there's a typo there. I was like, server crash. Was it also 9? No, this is just regular sequences. I'm trying to remember. There was one more. There was one more. You got a 90 and you didn't finish a single one of the 4 subproofs. The quiz had a 20% attendance curve. So that's a 70 is still pretty good for not proving anything.
That's crazy. Is that the RB list quiz or which quiz?
Yeah. I don't know what the other variants were. I don't know if they were. I think they were all RB lists and you were just proving different properties. Oh wait, I never actually downloaded it. Actually, let's not show my downloads folder.
Yeah, I
Is there
haven't
any-
really seen the quiz material. I think I saw the RB list quiz, but also there's not really a notebook for it, so I couldn't actually try it myself.
Yeah, he never returned quiz 2. I think he forgot.
Unlucky.
Yeah, so my version was proving this. I don't know if the other quizzes were
Wait,
slightly.
isn't this looks almost identical to that thing I had to prove earlier?
It is. The only difference is there's more cases because an RB list it contains things of 2 types. So
Oh,
it
it
can
can be
either be
red or
empty,
black. Okay.
red A, or black B.
Yeah, and this is like where I had like singleton or like just the cons.
Pawns.
That's it. Yeah.
Yeah.
I
Yeah.
see.
So it just had 3 subproofs.
Yeah. Jacob got me feeling like I can prove any induction question. Let's go.
That's good.
That's good.
Just
That's good.
make
Look, the
if
thing that's how you should be feeling because they're all the same. They're all the same.
that
And
is
once
yes.
you know the single
And
flow chart you need to have for it, they're all easy.
and as Cole says, induction is easy.
It literally is.
Like
It's just knowing you just have to know the flow
the
chart, you know? Once you know the algorithm,
yeah.
you're good.
If you want a challenge for induction, make sure you can do 11.6 and all of assignment. Wait, which one is it? The induction one, 3.2, the non-empty list.
What was the one people were asking about? And there was it 11.6 or was it 3.2? There's one people were
Three-
talking about
The
for one of these
length
that
of
had, like
zip.
some X's. Yeah, what's this like? Why what's this X's? Why we got multiple
Oh,
X's?
it's a list. It's a sequence of sequences.
Oh, it's a sequence of sequences. Oh,
It's corresponding to concat in Haskell, which takes like a list of lists and concatenates them together.
ah, okay. This is terrorism. I see.
It's not that bad. See, that's I think I also have a serious edge here by being a 1JC3 TA while taking this.
Yeah, that probably helps. Yeah, that's a good
Because
point.
then I remember all the Haskell stuff.
Yeah, is this any different or not? Like, do you think this? Have you done this question?
Which one? The
The
flatten?
X's. Yeah, the flatten.
Yes. No, that one's not. It's not any different. You just have to recognize that it's a list of lists and use the appropriate theorems. The only one that's slightly interesting is 18, the very last cell. The
Yeah.
zip, because there are, you'll notice the axiom, instead of having two cases, go back down.
Oh, sorry.
The axiom defining zip, instead of having 2 cases, it has 4 cases, which means you need nested induction. But you don't actually need nested induction because the theorem you proved directly above is a decomposition theorem.
Oh, crazy. Heroic. I
Um,
was about to just do nested induction.
but yeah. So if you are confident with induction, try this last one. And if you can do this, then you can do anything he'll put on the exam.
I'm kind of curious about it. So, okay, let's do some classic using induction.
Don't show them this.
Off the stream.
Let them figure it out.
Lame. I want to do the fun questions. Okay, guys, what else do you want to see?
But also, if you ever stop your stream, then the recording will never.
Oh yeah, then the recording's just cooked. Yeah, good point.
The recording's cooked if you ever stop your stream. 3.2 is the hardest. Or sorry, 3.2 and 11.6. 11.6 has a lot of details. So if you get confused by that, 3.2 is better. But yeah, 3.2 and 11.6 are the hardest induction. If you haven't done it, also the binary trees one is good. It's just kind of fun. The syntax is really fun.
Oh, this book. Oh, this. Oh, yeah. It's the expression Boolean.
Yeah. There's you have the famous video.
I got the video. We're good. We can just watch the video. I wonder how many views this video has now. It's unlisted video.
It's probably like 10,000 or something.
Surely not. That'd be a ridiculous amount.
Oh wait, can you view the statistics?
No, it's 400.
Too?
It's 400.
Okay. You can view the statistics though, surely, or do you not get them because it's a unlisted?
Analytics.
Analytics.
I guess we can just keep the analytics for my channel. Let's go. Dude, my views are up huge. Yeah, I got +1 subscriber. Oh
like if it's just a spike.
They're fucking unlisted. Okay, hang on. Should we go to actual videos? Like, where do I even? Oh, this is the video. Oh, this is specifically this video. Okay.
Specifically this video.
Watch time 7 hours. It's like, I mean, I guess
over the 999% more than the previous 28 days.
That's crazy.
That means that 7 people have watched the whole video.
True. Total combined. Wait, hang on, guys. Why have only why we got 73 views and you guys watched? Each person on average watches like a tenth of it. What's going on here?
Well, scroll down. It shows you the retention. It says average view duration 5 minutes.
Guys, come on, man. You're gonna need to do better than that.
And if you scroll down, it'll even show you. Scroll down. So this is not a good retention graph. You got to work on your Mr. Beast thumbnails and.
No, it's an unlisted video. You're clicking on it knowing what you're watching, guys. It's not something you found in the YouTube recommended. Are we TAs or we're doing this for love of the game? Daniel is literally taking this course with you guys. I am not
a TA.
Yeah, no, Daniel is literally taking this exam tomorrow.
Unfortunately, I actually have to take this one.
Unlucky. Oh my god, I heard you got a free pass that it was a GA for you?
Yes.
What, you 100% did both midterms? So she just, you just didn't have to... That's crazy.
Yeah.
That is absolutely hilarious. Simply a difference in skill.
Yeah.
So true. PhD under Cal.
Well, that's what I said. Is I can't let Kalchik die. Just when the students think they're getting free, he retires, and then I can take over.
True. I'll be your TA when you take over.
10.3 or 10.1 while loop. I don't remember what 10.1 is.
We went over 10.3 a bunch. I don't know what 10.1 is.
Oh, 10.1. Oh, 10.1 is
sorting zero. Kill KMS. Valid. We did actually briefly. I showed almost a full solution for sorting zero. But It's
But
hard, though.
the silly thing with 10.1 is there is a useful proof in there to look at, which is the very last one, which is the partial correctness thing. Because if the
Hey
loop
guys, here's
runs
10.1,
infinitely,
guy. Here's 10.1. You wanna go through 10.1, guys? Here's 10.1. Oh yeah. Oh yeah. Oh yeah, there it is. And it's not even done yet. Yeah, it's fun. Yeah, I'm good gang. Yeah, agreed. I actually don't know why I spent a full day doing that.
but the very last proof, the one he says is much easier,
This one
that is
is
an understatement.
significantly easier, yeah.
Because wait, do I have my proof in here? Yeah, this is my whole proof.
Honestly, my first thought when I saw X also quad the bet is that you just used the like true equals false nonsense. But no, this is a
I
legitimate proof.
This is a legitimate proof. And then in what fucking notebook is it? 12.1, you actually prove that in general, for any loop that is always true, it will terminate in any state.
Yeah, true. If it doesn't terminate, then you know.
Yeah, if it doesn't terminate, then it can't. Well, it will only terminate in these states. But yeah. So these are interesting, but I'm not entirely sure how applicable they are.
Or mildly amusing, I would say.
Yeah, and you definitely have to come up with your own. Definitely have to prove your own theorems or lemmas for these ones.
Hmm. And this like line thing always confuses people. Like I don't know what to call it even, but when you've got
Which
like
one?
the things on top of the line, and then instead of
Oh,
this
but
consequent like, yeah, you just
if
assume the things on the top. If the things on top are
if they
separated by commas,
if
just assume each of them and then write something on the
if
bottom.
they if they went to the lectures, but it's
Yeah.
just an inference rule. Like this is actually what we did in 1DM3. We talked about these. Like
Yep. Yeah.
yeah.
Also, there is a previous years have each had an assignment built around this concept. I guess you guys didn't. I don't know if
Oh, I
you did.
see. Like where you actually use this syntax. Like I don't know how the syntax works. For example, this must be insanely annoying to parse. Like how is this parser written, or does it actually not care about the spacing at all? Does it just look for like
I
a
honestly have no idea. So I don't mean that. So I don't mean that you have to write this. Like you don't have to like. It's just similar to this setup where it's just questions written like this, and you just use the assuming, like just the same way he's done the structure here.
okay?
Like, so
So
you
you
just
just
everything on top of the like of the inference rule, you just assume. That's it. Also, you see how it's written on the right? Look at how it's written on the right. I'm pretty sure the
yeah.
line is decorational. Like I think just delete the line up until that. Yeah.
Oh, that's so true.
And
That's
then
so
bring it to the same line and it'll still work. Like if you bring it all into one line, then this will just work, you know?
Oh, I see.
Yeah. So
That makes
it's
a
the
lot more
line the other dashes are just decorational.
that makes a lot more sense as a from a parsing point of view.
Yeah. So it's the same, it's the exact same syntax used for like the while and conditional those rules, right? Like it's literally
It's
what we're doing right
just
now. Because this is literally defining those rules.
like because it's just like I don't remember what are some of the ones like if you have and P and Q.
Yeah, like these DM3, yeah, the way they were written in DM3, exactly. Yeah, it's just this syntax, right? Like,
It's the same idea as
it's
that.
just, by the way, this is just implication. This just represents implication. This is just
Yes.
P and Q implies Q. That's all. That's how you read this.
Yeah.
Yeah. That's probably enough of this. Yeah. So we had there, but I more mean I wasn't even talking about the like the inference rule syntax. I just mean there was a whole notebook built around this like command syntax, like
The
doing,
like
doing stuff with
the relational
yeah,
semantics
yeah, exactly.
like
There was
around
two full assignments built around this SAT stuff and like the range restriction, all this, and they've been horrible.
fun
Both assignments were horrific. It's our assignment four. That was our
fun.
assignment four, and it was the worst ever. Like
Oh,
literally only four
actually,
people
wait.
solved it.
I think I can see last year's notebooks.
Last year's assignment was also terrible. Like one of the TAs who was basically like me and just doing all these calls and stuff all the time and helping everyone, like was completely stuck on one question. I couldn't even solve that question. He was the only one who was able to come up with a solution for it. I don't think anyone in the course came up with a solution for that question.
Oh, here. Oh,
Ridiculous question.
assignment 3, relational semantics.
So look
Uh,
at there's one I can tell you exactly which question was this impossible one that no one. Oh, see this inclusion of SAT?
yeah.
It's this one, I think.
It's a corollary. Is like, what has he cooked up?
I don't know. No one could do this. No one could do. I think that was the one that no one could do. Oh no, sorry, no, it's distinguishing. It's distinguishing expression B. I remember now. It's the one too. It's this one. This one, no, yeah. This one, like only this TA could do it. I spent a while on this. I couldn't figure it out. This one was just a nightmare.
That's interesting. 'Cause this notebook looks so innocent. It's just 31 cells. And
It is disgusting.
is this the multiple choice question you had to go to the tutorial for?
No. This was not my assignment. This was last year.
Oh, right.
In my year, no. It was. You would probably be able to. I don't know. It was like the question talked about a loop variant, and I like did not know what that was.
Oh, the variant is the bound function.
But it was a loop variant, and it was like on like the loop condition breaking itself, or like, but all of them were like expressions of like the clean star, and I just didn't know how to interpret it properly. Like,
Oh, I see. Yeah.
it was just I think it was just you really had to like deeply understand the clean star and
Yeah, I'm
composition.
gonna be honest. I don't actually know what these brackets mean. Oh, is he just
Is
using
that just partial correctness or what? Or is that like or the other one?
I think
Not.
is he just using a different? Oh, this is semantic consequence. He uses slightly different stuff.
Total correctness. Sorry, yeah, it's not partial correctness. That symbol is total correctness instead of partial correctness.
Oh, see, he talked about this, but never gave us any exercises on it.
Mm-hmm. Yeah, no. So we had like look at this. This 20 is like just terrorism.
Right, and this is yeah. We never did total correctness, right?
Yeah.
Because for total correctness, it has to be partially correct and guaranteed to terminate.
I haven't even read, but yeah, the variable use is interchangeable.
This is
It's actually really important to know that you can interchange that variable freely, because sometimes you'll have imagine the like the theorem itself has x, right? Like the induction axiom has x in it, and then imagine your question also has x, right? You can't just keep both. One of them has to get renamed. So you would rename the one in the axiom. You would rename the one in the for all to something else, to like a in this case. I hope that made sense. That tripped a lot of people up on the exam last year. There was a question where you needed to know to do that, and a lot of people didn't and just couldn't do any of the subproofs.
I see this now. So this is partial correctness, because this is saying
I think the video actually talks about this, by the way. The expression B like video talks about that.
Okay. Because this is partial correctness. Like, I recognize this from our assignment. Then this is total correctness. So this is saying the set of states satisfying P is a subset of the domain of the semantics
of the command. Okay.
of the command. So this somehow says it always terminates. I don't actually understand how it says.
Well, because I think we say that it does. The domain is the states where it terminates, right? Like,
right. Yes. I see that now. Because it's like a state graph. Like, it takes you from states to states, and so the domain of that is the set of
the states where it terminates. Yeah.
Well, I'm not going to do this. Maybe over Christmas break or next term when I'm bored.
I'm going to teacher's ed at Brock after I graduate. To
become a high school teacher.
I am going to become a high school teacher. Why did my thing just got like stuck highlighting this message?
Are you going to teach them calc check?
Exactly. You already know it. They're gonna learn. They have to learn. It's okay. They'll thank me when they go to McMaster and then take 2LC3.
What courses did you
take?
Yeah,
better start young. Exactly.
What courses did you take for your like second teachable then?
Math.
Oh, so it's.
So I took a bunch of lineage courses because they're helpful for just a lot of things. If you want to take like ML stuff.
So then, then what are your two teachables then?
COMPSCI and math.
Oh, I see. Okay.
No, okay, so here's the annoying thing. I would have loved to do like normal teachers ed, which is I think what you're talking about, but basically York is the only university in Canada that does COMPSCI as a teachable.
Yes,
like,
I've seen that.
So instead, my plan is I'm just gonna do I'm just gonna get certified for like primary junior at Brock first, and then you can just take like online courses to get qualified to teach high school subjects, and I have enough courses for those, so I can just do math and comp sci that way at different
I
schools.
see. Okay.
Yeah,
Yeah.
I haven't sorted out
Right.
exactly where I'm doing those, but it's definitely an option. So
Right. Yes.
is the
That's
plan.
yeah. Because that's I know it's a little bit difficult depending what degree you're in to actually take enough classes to have to
Yeah, but
teach
you only
those.
to take the math like high school certification at least you only need 6 math credits. So I'm taking my 6th one next semester.
Oh,
Technically,
right.
I have
That's
5 actual math courses and then like a stats like the stats course you're required to take
right.
for comp sci, which I like should count, but I'm taking one
It
more
should
math.
count. Yeah. So what math have you taken then?
Just differential equations seems easy enough.
Oh, right. Because because in first year you take 3
Yeah, in first
for
year you
comp
get 3 out
sci,
of the way. I took 2 Lineage courses the next 2 the next semester. In second year,
which
my elective both semesters was just like I took 2 LA3 and then 2 RO3.
oh, you took both.
Yeah, I just took both for
That's
fun.
aren't they like anti-requisites?
Nope, nope, they're not.
Oh, I guess one right. One is applications. Oh, this is not the
In fact, it
Spanish
was actually
one.
nice to take both of them. Like LA3 reminded me of all the shit that I'd forgotten from 1BO3 in first year because first year
Right.
was just a mess.
Um,
And then the next one was like, or honestly, RO3, really nice course to take right after LC3 because it's all about proofs. It's just you just do like a lot of rigorous proofs of different
um,
Lineage concepts, and it was great to like immediately after this course reinforce that knowledge by having to write real proofs on paper, like not in calc check,
yeah,
like math concepts.
that's interesting. Well, I'm not taking it. I don't think I'm taking it
Mhm.
next
For
term.
anyone who's looking for a random elective, I don't know.
Yeah,
I think
yeah.
Lineage
I might.
courses are a great thing. You should try to squeeze in at least one extra Lineage course when you have the time, if just for different tech electives. So many different comp sci tech electives require like some Lineage knowledge. Like if you're taking computer graphics or if you're taking like the machine learning courses.
Does
Um,
does the computer graphics actually like as a prerequisite, or is it just like because
it's
it's
not a
computer
prerequisite.
graphics?
It's just very helpful to like
Yes,
have
yes, yeah,
better like Lineage
yeah.
knowledge than just what
No,
you maybe
yeah,
remember from first year.
yeah, yeah. Is
Yeah.
it is it Dr. Wang that teaches that one?
Yes, I believe so. Yeah.
Yes. Oh,
I don't know if she's
that
still
is
teaching it, but I believe she taught.
well I know because I had her for 1XC3 and I did not enjoy
Yeah, I
it.
think we or wait, did we have her for that? We had her for something. I don't think it was 1XE3 though. I don't remember. I think we had her for 2 ME3 actually.
This did, oh that would be even worse than 1XC3.
Yeah, no, it was bad. 2 ME3 was bad.
Um, because oh my, it was just so bad. That was like on like the slides tier list. Hers were at the bottom. Google Slides, default template, screenshots from the textbook.
You guys have a fucking tier list for slideshows?
No, like I have an internal tier list.
Oh, okay. I thought
But we can honestly
dude,
make one. And then
my year would have had stuff like that. My year had like crazy like rankings and tier lists and like
I
just
mean,
memes
and then
from every
like
prof.
definitely Helling's slides at the top. Those slides are impeccable.
Okay, I mean the only complaint people have is that half the information is hidden in animations. So if you're like
Oh,
scrolling the slides, like you just have duplicates of every single slide.
that is true. But like I could like each slideshow must be like a 10,000 line LaTeX file. Like
Yeah, but
genuinely.
I didn't mind it that much. It was still fine to scroll through.
Um, yeah, no, Helling's slides are up
Riley's
there.
slides are good. I would learn a lot from going through his slides. It was the one course where I would just miss most of his lectures, like not pay that much attention, but like I would get every like
I
all the
mean,
information
because
needed from the
we
slides.
have him for 2 CO3 and then again for 2 DB3.
Having him for 2 CO3s gotta be nice actually. I feel like he would have good
It
information
is
for his
nice.
slide
Other than
for
the
the
fact,
algorithms.
we wrote the exam last night. We have only gotten 3 of our 9 assignments back.
That is yeah, that's always annoying. That's the one issue with that course, right? Is the or like with Hellings is just his grading scheme. I don't
Except
know what it is.
the exam was so I don't know if everyone here agrees with me, but that was like an easy exam. Like
I think that seemed to be the collective opinion when I looked at the channel.
yeah, like almost everyone I talked to, other than the fact that someone decided to pull the fire alarm at 7:29.
Bit confused about the second subproof for 3.2. Don't understand the implication portion. Okay, I talked about this before. I'm gonna go over one more time. Let's do. Okay, which question is this? Or do you don't have a specific one?
Oh,
It's. I think I'm just gonna reiterate the same thing I did before. I don't think Fa was here when I talked about that. Okay, which question did I do for this actually? Which one of these was it length that I did? I mean, I could do a different one this time. I want to do one with a similar structure. Maybe I'll just do length because I did this one before then. Okay, so when you're setting this up, you're going to copy... Wait, oh, I had it in this one. Here we go. Oh, I have my solution here. I still have this one. Yeah. Okay. But I'll set this up again. I'm just going to delete this whole subproof and set it up again. So we have our axiom down here, right? I'm assuming you know how to set up this first one, so I'm just going to talk about our second subproof. So you go down here and make a new subproof and just copy this whole thing in, right? There we go. And now we have to sub in P. So I talked about this before, but make sure you recognize that this statement here should match this at the bottom of our axiom, which means this for all x's is this for all x's. That means that the P represented here includes all of this. So we don't include this for all x's when we're talking about P, but we do include this for all y's, right? We're only really popping off this first for all so that our statement here matches this form. So this is just our P. So I'm going to copy just this part. And first of all, I'm going to delete these types because I don't care about the types here. I'm going to enter this whole thing down to the next line just to give me a bit more room. I'm going to paste this in place of P. So this is the actual expression I'm going to have to prove. And then I also, in this P up here, I need to replace this P as well. Okay, let me shovel this over to the side. Right? So I set that up, and now I'm going to go do my substitution. So I take my consts, I'm going to replace all my x's with consts. Okay, and I'll delete this. So this is now our state. You can our subproof we're trying to prove. You could read this as for all x's where this is true, we need to show this. Right? We need to show this is true for all x's that satisfy this. Because that's what the range means, right? When you're looking at a for all, right? And you've got for all x with some range, like if this range is, for all x less than 30, you're saying this, show that this property is true for all x less than 30, right? In this case, we're saying show it's true for all x that satisfy this. So really what this is the same as saying, though, is you'll actually see there's a theorem for this. This is trading for all, right? Is that you can say these are the same thing. Having the range or making it an implication, right? You're just saying that as long as x is less than 30, that should imply that P is true. Which really means that if you've got something in your range, right? We know we could assume this normally. If you've got an implication, you could assume this. What that really means is when you've got something in your range, you should be able to actually just assume this property is true, start proving this. So that's what we do. And there's actually a specific theorem from the syntax help for this. If you go up here and go to syntax help and go to the for any, this one up here is just your regular for any, right? You're proving some statement that's a for all. So you pop it off, like you pop off the for all with a for any and start proving P. But there's also this useful one that I'm going to quickly copy out. So if you take a look at this, I'm just going to delete this T again and this T. Notice that this matches my pattern, right? I've got a for all x with a range. Here I've got for all x's, doesn't matter, it's just a variable. For all x's with a certain range. And then this is my P over here, the thing I'm actually trying to prove. But see, I've got this range, and you can actually write this. You can write, let's do it down here. So for any x satisfying, it's not a keyword, okay. And then you write R. So if I say for any x satisfying this. And just like an assumption, you can give this a label. And now you actually have an assumption here. Right now you've assumed this and you've popped off this for all. And now you just do a proof for P, you just do a proof for this statement. So now you just prove this statement down here. Right? And then to do this, before you actually prove this, you would do, for any x, y's, right? Pop off these, and now you just do length. And this can be a top to bottom proof, so just go, and there you go, right? And so if I delete this, let me delete at least this. Bad choice of local variable. What is it yelling at me for? Oh, right. I chose X because that's what was listed here, but it should be X's. I should choose this label here. I should choose this to match. And there we go. That's my mistake. Yeah, you should choose the variable listed here. In that syntax help thing I was looking at, right? They chose X because that's what the variable was. Right? It was for all X, so they chose X, but I've got for all X's, I should choose X's. I hope that explains that a bit better. Let me know if you still have questions about that, though. Gosh, I can pull the chat up on my phone now, luckily. My phone has enough battery. Wait, I forgot. Hang on, I'm trolling. I can't even find this Discord on my phone. I found it. There we go. Yeah, assuming all the questions 3.2 use similar structure with it's all the same like initial structure. Just setting this up. You always just have on every single one of these questions, right? You have a for all that you pop off, so that's totally fine. This one is actually a list of like sequences instead of just being a sequence of A's, but that shouldn't change much. Yeah, you know what? I'll at least set up the structure for this because I know that Daniel said it's the same, but I'm just gonna like at least see if anything changes at all. Oh, okay. I was gonna say, did Daniel leave? But he's just here. Oh, you're getting a type error. Okay, yeah. Let me see what's going on with this then. So we'll just do our usual using induction over sequence. Let's do 2 subproofs. So our first subproof for this first case, right? So we'll pop that in. So this is our P, right? So we pop off this for all X's, right? In this case, that's this. Again, doesn't matter that the variable is a different name, right? There's just a variable name. The type, who cares? You can just implicitly get rid of the type. So everything after this bullet here is my P. So replace P. And now shovel this to the side. Let's go swap out. Now this should be X's like that instead. You're swapping out. So we'll replace these again. Put brackets around your singleton. So that should be 1 subproof. And then we'll go do our second one. Oops. So, oh, you made a silly mistake? Yeah, I think it's literally, I don't know. I think it's just the same process. Do I even want to do all this again? Not really, but I'll do it. You don't need that either. And you don't need that. Okay. So once again, this is our P. Put that in. Enter this down. Put P up here as well. Do our replacement. So X's becomes this. And again, just try not to get tripped up by this variable being different. It's X's because that's what was here. If you have a different variable, each of these substitutions should be replacing the variable of P that's not X, like that was X. That's what X's is in place of. So yeah. And then just remember that you can always rename these. This is just A is just this A. Like as long as these are the same, this can be whatever name you want to not conflict with your other variables. That part is very important. Okay, so I mean that should already like be valid. Oh, I cannot justify this using application. Okay, did I mess something up? We'll take a look in a sec. Oh, I actually did mess something up. That's pretty rare. Okay, what did I do? Oh, this is const X's. I don't know if this needs to be different necessarily. Oh no, wait, yeah, as long as this matches this, it should be fine. Oh, that actually did matter. Oh, interesting. Okay, I'm kind of surprised. Why? Yeah, why would that be the case? That's interesting. Oh, you know what it is? You know what it is? It's because this for all x's is supposed to be the same variable this has. So if I made it x's here instead, then it would be fine. See? But in this case, the variable of this and the variable used here have to match. So keep that in mind. Okay. So that's an interesting point. Yeah. Because again, remember, it's for any x's satisfying this hypothesis, right? But it doesn't make sense if this is using a different variable. Not to mention the fact that the variable of like p needs to be defined, right? In this case, x's is just a free variable, and it's not really going to understand right. Like x's is literally is a fully free variable. It has no idea what this is now. This needs to be bound to the quantifier. Yeah. Okay. Well, that should be it. And then you would just solve these. And I can't imagine these are particularly difficult. You would just do the classic for, you know, for any. I mean, what I do for these is I just go to the syntax help and literally copy this line. All right. Once you do enough of these, you don't even have to check that much anymore. For any, make sure you get this here. It's the outermost variable. Grab that for any of those satisfying your hypothesis. Assumptions match quantifier range. Perfect. Enter down. For any x, go prove that this is equal. You know the drill. Oh, can I match data calculations with goal? What the heck? Oh, I started copying this. Oops, sorry. It should be that. There we go. Yep. And then this up here, you would just do a for any a, pop this off. Yep, cool. We've done, let's see, all of week 11, 10.4, I don't even know what 10.4 is. Easier-ish, oh no, so wait, 10.4 is the one we did earlier, duh. Okay, 10.4, easier-ish while loop. Yeah, I think they're both pretty equivalently easy. Or like, okay, yeah, they're right. The second loop just has a slightly harder post condition, which is good practice though. It's just, like, I feel like it becomes a pretty simple proof by cases. Once you have the or, like you do the De Morgan and do the or, and it's almost identical. Everything else you keep the exact same. Your your if statement and your while loop are all the same. Sorry, I'm not trying to say. Yeah. Your if statement and variant, all that's the same. It's just post condition that changes. Okay, is this something vital you should study? You'll watch over the vid once it's posted. Yeah, hopefully we stop this soon so we can get it up. I just obviously Pablo has to come back before we can stop it, right? But we should definitely be stopping the recording as soon as we can. Right now, it's Pablo's is recording it, but he had to hop out, so the recording's just kind of been rolling for 4 hours now. Yeah, something else you should study. Yeah, I don't know. I don't know if the clean star stuff's going to be on the exam. If it was me, I would be grinding that right now just to make sure that I know how to do that because it's the only thing I'd be worried about. But like, that might just be a waste. Like, it may just not be on the exam, and there might be better things to spend your time practicing. I'm not sure.
It might also be worth spending your time sleeping.
That is also a very important dimension.
Did
So
I miss?
do remember at the end of the day, right? This is just a puzzle solving exam, and you want your brain to be in tip top condition.
Yeah. Did I miss anything important? I was getting dinner.
No, I don't think you really missed anything. I was just reviewing the same like induction axiom stuff I showed
Okay.
earlier.
My roommate's ordering pizza. Well, we have to go pick it up, but
We were also just setting up this like the x's, just doing the structure for it, and
yeah.
I realized you have to like change the variable and you have to rename the variable in p.
You do?
Or sorry, you don't have to. Sorry, but this matters. Like obviously here you can leave it as A, but this has to match the variable that was part of P. You know.
Oh, well, it's arbitrary.
Well, I mean, like you could leave it as X's and then change it and then rename the variable in P.
Yes,
right?
but it to make sense, it has to match.
Exactly. Yeah.
Yes.
You will get an error if it does not match. Like
yeah, it just to make sense.
you will get an error if you it won't work if this doesn't match this and this. That's the important thing.
Yeah, I mean, yes, get a good sleep, everyone. Like that's my advice.
Caffeine is not a solution to sleep. Caffeine is not a solution.
Yeah, get a good sleep. Arrive early. Like he says 10 minutes, I would say 30 minutes.
Yep.
Because if
Yeah,
everyone's
everyone
early,
knows the exams always starts half an hour late, so it's all good.
if everyone's early, that means we can deal with that means that we can hopefully get started actually on time. Oh yeah. There's actually, if you do you can actually access the virtual, like the environment remotely to make sure it's working. Where is it? It's here somewhere. Services. You can also just search it. Computer labs. So if you click, I think he actually put this in the announcement now. If you click web client here and go to this link, you can actually log in to you can make sure it's all working right. This one might not be worked up yet. The 2LC3 host pool. Yeah, okay, it is. So I would suggest everyone logs into this first, and that way, when you get to the lab, it'll take less time to log in because you've logged in recently and Windows has done all its Windows things. You can also install your font of choice on here. So I'm probably the only one who wants who make sure I have the right font installed. So yeah, just make sure that you can sign into Avenue and access CalcCheck through this, and then do the same thing when you get to the lab.
That's true.
And he did send out the lab assignment emails already, which is shockingly early for him. Because midterm 2, it was 3 a.m. the day of the midterm that we got them. So yeah, because these things they're so slow. So like make sure they're working properly. Oh, there we go. Z arrows. I have not looked at this notebook. It's terrifying.
Oh no, this is not important. Don't worry about this.
This is not important, no. The link, I will send it. Oh, that's the fake chat, not the real chat. Here's the real chat. Just make sure you do this in a oh yeah. After, I might be gone by then. I guess I might stick around.
I'll pull up during the midterm with Candy, or during the exam with Candy. It's all good.
Yeah. Yeah, so make sure you can log into this. And at least it's very laggy in the browser. It's slightly less laggy in the labs, at least. If it was this laggy in the labs, it would suck. Or we just hope that they're broken entirely and we can write on our laptops. But it kind of sucks if you have a small screen.
Guys, what's the worst thing he would do if I just like pulled up to the midterm, quickly peek at like the URL at someone else's computer and just copy the like notebook into mine and just start working on it? Like,
just run a port scanner.
how do you
Like
do that?
just like I should probably not be
Oh,
saying
I
this
see what
on-
you mean. Yeah,
I
okay.
should
So
not be
this-
saying this on video.
You're
but,
saying
like,
this on video, but yeah, run a port scanner to go
like
find
you can
what
just
meant
run
to this.
nmap and it'll tell you what ports are open.
It's a good idea.
But also, I believe he does check the logs for people who are accessing them outside of the McMaster network. So make sure you connect to the VPN first and then do it.
Okay. Yeah, well, I'll be
But
on
also,
campus anyways,
I suggest not doing that, because I think that definitely constitutes academic dishonesty.
Well, I'm not doing anything bad with it. You know what I mean? Like, I'm just taking them. I'm just taking the
Yeah,
exam.
it's really just a sign that he needs to add more security protocols.
Yes,
I'm also not sure.
indeed.
Oh, but I'm not sure what happens if you open them outside of Avenue. I think that it might block if you're not logged in through Avenue.
That's unlucky.
Because for the quizzes we have like password slips.
So maybe he has actual security for it. Who knows?
So I think it might require you to be logged in through Avenue to show you the exam. I'm not sure. I haven't tried because I don't want to get in too much trouble.
When you have this and you need to do induction on a sequence, how do you say that the base case is covered? You could just assume this before doing the induction.
You can also, yeah, and also you just get to x. You can also just get to x falso quod libet, depending on the exact case.
Oh, I see what you're saying. Yeah, because you'd have empty set not equal empty set false, and then x falso proves anything or implies anything. Yeah, so if it's for partial correctness, then you can just, because you have implication, you'd be fine.
Oh yeah, the variant boundedness. You can't say by assumption, but you just have like you substitute in length epsilon greater than 0, and then that is false because length epsilon is 0. So then you get false, and then you can just use x falso quod libet because that implies anything. I think this was 10.4. My solutions. Oh, I also just did assuming, and then I had different proof here. I proved a lemma. I don't actually know the best way to do this one.
Because otherwise you could. Oh, but I see the thing. Okay.
I think there's a couple of different approaches to this. This was my approach.
Hang on, let me think. I want to see what my funny way would be to do this. Wait, new question is, why would you even? Do you need to do induction on this? Wait.
Well, I did induction to prove this. I think you do need induction.
I would not do induction for this.
Because length is an integer, not a natural number. For some reason.
I would be doing this instead. 1 sec.
Oh, I'm not looking at the screen.
Oh, okay.
Okay, there, I'm looking.
I think this makes way more sense than doing induction for this one.
Wait, okay.
Right, and then is there not just like an easy way to say that this is like 1 plus something, which is greater than 0?
Oh,
Like, there's a theorem for this, right? Like, what is length?
that's just definition of length.
Okay.
You might be right here. And then
what do you do here? Like,
oh, no. Length. The issue is length is an integer, not a natural number. So length could be negative.
oh, so you do actually kind of want the induction.
So that's why I need my. That's why I made my lemma that length is 0 or more, because for some reason he declares it as an integer, not a natural number.
I see. Okay.
Okay.
Yeah, it should be a natural number. You can't have negative length, but it is an integer.
Yeah.
Lame. Okay. When is length defined in this notebook, or is it somewhere else?
It's literally right there. It's like literally right above the proof you're doing. Like, yeah.
Oh, right okay. Yeah, first to Z. God damn it. Okay. Wonderful. Yeah. Okay. So you would do. Wait. So I wouldn't even do this assuming then. Hang on. New plan.
You do use assuming. Well, you can also try it like this. This is how it
Yeah, I'm
happened
trying.
initially.
This now is my new
You're going to
plan.
need to give a type for x's, I think,
Nope,
for
disagree.
induction to work. I'm pretty sure.
I think you're right.
Induction is the one case explicit types are required.
Yeah, by induction on that. Wait, no, hang on. What am I even trying to? Okay, can I stop trolling for 1 sec?
This is just x falso quodlibet.
Exactly. Yeah, that's what I was seeing.
Irreflexivity, yeah.
Please, keyboard. Thank you. Yeah, I'm just curious if this will work.
X cons x's.
But I think the issue here is that I don't like. I want the non-empty sequence decomposition to break this up and then use my induction hypothesis. Or maybe
well,
I don't even need that.
Just give it a
'Cause
try.
if I get true on the right side, then I'm
No,
fine.
I think no, you can get because the left hand side you can do the left. I wouldn't do it like this. Because the left hand side is trivial.
I think I know
the
what I'm
left
doing.
hand side is trivially true. The left hand side is trivially true because it's.
That's true. I don't even
is
need
not
that. They're both trivially true. Look at this. Because this is just. Oh wait, no, it's still. Oh yeah, no, because then I'd have induction hypothesis.
Oh,
Well,
yeah,
actually,
you're
okay.
right.
This gets a little gross. Though,
Oh,
still.
there's a little bit of.
I don't know what the right way to do this is because I would be doing this to get this, and then I know that this is greater than 0, and I know that 1 is greater than 0, but I don't know what the right way is to like prove this in order.
That's where I got stuck, but I think there is an easier way to do this. Is it just a transitivity? No, because you have it. It's something involving addition. Oh, I remember how I proved this. Okay, just go back, or should I just do it on my screen?
I mean, I think I kind of just want to give me a sec to think about this.
Okay, well then I will do it on my
Yeah,
screen.
you can go for it too. That's fine. Oh, hang on. I understand. So I want this is like a super scuffed way to do this. I'm cooking. Please tell me we have facts. Okay, we have facts.
I think
Oh.
we're doing the same proof. Mine is just less scuffed.
Oh, never mind. I can't. I have a worthless induction hypothesis because this sucks. Okay, so my epic idea does not work. I can't. This ends up being silly. You do want to do assuming after all. Okay. Oh, good run. Which means now you're just trying to prove this each time. Okay.
Wait, let me. Oh, yeah, because you can't use the induction hypothesis, can you?
Yeah, no, I cannot. Okay. So new plan. Oh wait, this still sucks though.
I think. Let me just work on this for a second. So if we have.
Hmm. What is that right? What is because this base case should obviously be immediately false, but it's so weird to prove.
Okay, probably have to go now to go pick up dinner.
Yeah, that's chill. Okay.
Are we? Is this going to be the end?
I think this is an acceptable end.
9 hours and 15 minutes.
Yep.
All right. I just gotta screenshot this. All right. Unless there's any last minute questions. No problem. This is entirely selfish because the best way to learn something is by trying to teach it.
This is true. I don't know what I'm teaching this for, but you know.
Well, yeah, that's on you.
Yep.
Yeah. Feel free to post any questions here, or DM me, but ideally post them here because other people will respond. Yeah, I don't know if I have anything else to say. I guess good luck, everyone. How do you get the invariant if they don't give you an invariant? Look at the post condition, look at what changes in the loop. Yeah, kind of that. You have to be able to get from the negated loop condition and invariant to the post condition, and the invariant involves something that the loop does. So if you're iterating through a list, the invariant will be some statement about the part of the list that you've looked at, or sequence, I guess. And you hope they give you a ghost variable, otherwise your invariant is going to be an exists prefix abomination or something. All right, we go. Goodbye.
Right. Goodbye, Daniel. All right, guys, I'm cooking right now. Peep this proof. I'm cooking it up. Wait, what am I even whatever I'm trying to do is just does not make sense right now. I have reflexivity of equals. Wait, this doesn't. Wait, I've proved garbage. I've just proved it's false. I need to prove it's true. Wait, what am I doing? This does not help me. I need to prove this is true, but it's false. Huh. Oh, guys, I get it. I get it. I get what we do now. Oh, I'm cooking. Now I got it, guys. This time I got it for sure, okay? We need left identity of implication. Dude, we just bring back the same theorem, okay, guys? We bring it back. See, it's that we have the same theorem now. Now I can prove what I was doing before. Now I can do my classic eps not equal eps, you know? Your reflexivity, we get false. X falso quadlibet gives us this on the bottom, right, guys? Okay. Look. Okay, sometimes you have to explicitly declare your base case if it's not a fan. So I just have to tell it what I'm actually writing explicitly. Because see, right now it's doing this what Daniel was talking about earlier, that I'm trying to prove this whole thing equals true. Because it's expecting a subproof for this. Oh, sure, no. What I should do instead is I should change my subproof. Sorry, this is fine. But right now it thinks my subproof is this, which is not quite what I'm trying to do. So I'm instead going to write subproof 4 to prove that it's specifically, I'm just proving this. I don't really want to show that it equals true. I'm just trying to do this. In fact, I think one other option is if I were to just make it a triple equals, I think it would... Yeah, if you do a triple equals, it figures it out. But if you do a single equals, see, it tries to show that these two are equal, and this being equal to true isn't implicitly the same, but being equivalent to true, Boolean equivalent, is implicitly the same as saying just the statement without the true. So it figures it out from there. That one's a little weird. Yeah, okay, so this works now. And then it says, yeah, because this cannot match stated calculation with goal. Okay, wait, I actually don't know why it couldn't. Because this should be doing a calculation for... Yeah, something. Maybe I need a for any. I don't know. For any x... Okay, calculation matches goal. We're good. So never forget the for any x. Now I just need these to work. Wait, is it a problem? Wait, I think I forgot that my induction hypothesis still sucks. A whole plan, but I forgot it. But yeah, my induction hypothesis is just still awful. Shit. Okay, well, that's not good. Oh, wait, no. Yeah, my induction hypothesis is this, and that's fine because I have this now. Yeah. Okay. Induction hypothesis with assumption 1. Wait, sorry, let's do it here. Induction hypothesis with assumption 1 gives me that. Fact 1 greater than 0 gives me that. Oh, we're cooking. Yeah, well, I want to make this one line now. Beautiful. Okay. All right. Item potency and right identity. Wait. Yes, easy proof. This is obviously the best way to prove this question imaginable. Clearly, this is the only correct way to do this. You should always write it this way every time. That's horrible. Wow. Actual trolling. Yeah, okay. That's funny. 20 proof. Sometimes I just get bored and mess around and do something like this where it's definitely the wrong way to do it, but it's just fun to see if the idea works. And the idea did work. Do you see the nonsense I'm doing here? Like, I literally assume this useful part, and then just, because I know it's true, bring it back in. I got a DM from someone asking about how to do the fake invariant thing people were talking about, but honestly, at this point in the course, I don't think it's a good idea, and I've never done it. Like, I don't fully understand what the idea is. It's like the idea that you can cheese marks by, if you're completely lost, just put in a variant you don't think is correct, and like show some logic for it. But I think you're much better off, like they chose like a super wrong invariant they knew they could prove at least the post condition for. If you're like incredibly lost, that's the idea. Is that like if you just want to get some marks for the post condition, choose a bad invariant that's just only proves the post condition, like and just use that. But I think you're much better off trying to figure out what the actual invariant should be. Again, just try to look at the loop and figure out what properties you can say hold. Keep in mind that you have to be able to prove the post condition with your invariant. So typically what you want to do, right, is if you're doing, oh, this is a if statement, right? Yeah. If you're working with a while loop, right, you know you're going to have the negated loop condition at the end, right? You know you're going to have this at the end. So let me get rid of all this nonsense. Okay, all of this. Okay. Yeah, you know you're gonna have to prove this at the end, right? And you also know that at the end you're gonna have the negated loop condition. So the first thing you should do is negate this, right? And look at, well, if you have this and you have this, what can you say, right? And now in this case, they have one more thing they keep true. This is typically, sometimes you need this property too. Like you have this you need to prove, but sometimes it's if you want to look at the variables and look at some kind of relation between them. If your if statement is all about numbers, then you want to look at some kind of mathematical sum, right? Maybe you've got some numbers that always end up adding up to each other, or always adding up to like the initial values you start with, that sort of thing. In this case, we're dealing with a sequence. X0 is our initial sequence of values. Each run of the loop, we pop off an item and append it to use. And then x's is just becomes x's without that item. So we strip an item off of x's every time and also happen to attach that same item to use every time, which actually means that our initial item set is just equal to these joined together, which is exactly the property they end up putting in the invariant here. But this is the sort of thing you should be able to piece together by looking at this, going, hey, these two sequences, I do something to this and do something to this at the same time every time. They actually end up adding up to the same thing at any point. You to do a while loop question, you want to have enough understanding of the material to be able to make that connection. So if anyone has any questions about sequences in general and how they work, feel free to ask. I think the natural number ones are a lot more straightforward in that regard. And those are kind of the two main concepts he's had you guys do while loops on so far. So yeah. I think he has not had you guys do a while loop for clean star stuff, which is a good sign. Okay, well, if no one has more questions, this may finally be a good point to end it at. I think Pablos is still AFK, which is unlucky. You have one? You have one? Okay. Back to the 10.4 loop. Okay. Let's see the 10.4 loop. Okay, we're right here. Okay, here's the 10.4 loop. Wonderful. We were doing the invariant clause. Why did we solve for more than just the invariant? Okay, let me go find, Daniel posted his proof, right? Let me see where he wrote all his stuff. I assume he made like a text file, right? I think he just dumped a text file. Because I'm just going to use his. I have my own, but I'm just going to take his. just so it's the same instructions everyone else saw earlier. Oh my god, Daniel, where did you post this? Jesus Christ. It was, we took this, yeah, here we go. Okay, let's download this. Okay, wait, hang on, no, I want to open this up here and bring it over to 10.4. This is, yeah, okay. Okay, so he's got a lemma here. Okay, let's just keep making new code cells. Wait, I think I made one. I did not want to make one below. What's the way to delete it? I don't remember how you delete this. Well, it is what it is. There's a new code cell now. Okay, so insert code cell above. Okay, and we have exercise for the reader. Very cool. Insert another code cell above. Oh no, I don't need to. I did not need to do that. We have partial correctness right here. Okay, sorry. Give me. I'll check your question just a sec. I just had to settle this up so I could properly talk about this. Guys, does anyone know what the command is to delete? I feel like he said it. Daniel said it, but I didn't remember it. Was it K? Was it Shift K? No, I don't know. Yeah, I don't know what it was. Whatever. Okay. Hop back down. Is it just D? Oh, you click, wait, X? You go over here and click X? Shift X? Is it Shift D? Shift D is duplicate, right? Do you just push delete? Wait, do you actually, is it actually just delete? No, it's not the delete key. Where do I push it? I don't even know where I like click to do it. Shift delete? Yeah, I don't know. I don't know how you do it. Because Shift D is gonna, yeah, Shift D does duplicate it. Shift K, Shift V, Shift X, Shift D. No, Shift D does, yeah, okay. I've already, Shift Q, Shift W, Shift E, Shift R, Shift T. I'm pushing every letter. I'm gonna push every letter till I figure it out. I definitely did not push, wait. Why does A also make them? What? Wait, B just goes to the next one? What? Shift B just goes to the next cell?
It's just D. It's not shift. It's just D.
Oh, crazy. Wait, I swear I tried that. I swear I tried that. Oh my, oh, there's so many. Why does it stop entering me down? This is the worst ever. Oh, I understand the strat. Okay, we do this. It takes you to the last one that you clicked on each time. Okay. Oh, I optimized shit out of this. Easy. Okay. Now I'm finally ready to tackle the question that was asked. So my apologies for the wait. Okay. So, anyways, why didn't we just go pre to post or pre to invariant? Okay, because here we did our precondition, right? This much made sense. And then we have our while loop, and we had to make a proof to do the while, right? Because if you check your theorem list, right, the only way that we can, because our goal is really just to start down here and go to here. This is just a classic proof. We just want to start up here, go to here. But to do that, we have to somehow get through this while loop. We have to show that we start with something, and after the while loop, we end up with something. And the only theorem we have to work with this is this while inference rule, where you can start with Q, and you can end up with not being Q on the bottom, right? And to do that, you have to show a subproof for this, right? You have to show this somehow. So that's why we go make our invariant proof. I don't know if I fully understand the question right now. So to do our invariant proof, we have to show that we start with all this and then run our commands and end up with Q. Because if we show this, then we have this and we can just jump from here to here now. Right? So this invariant proof here is just a proof for this. So if we go up here, right, invariant is just B, that's our while loop condition, right? We just put B and we put Q. And then we run our commands and we end up with just Q. We end up with just this part. Let me check again. Guidelines for how it's supposed to look, and you thought it was corresponding. Invariant for LM, loop condition invariant, loop body invariant. So that's exactly what I just described, right? This is exactly what I said. Ours here follows the structure. Loop condition, invariant, commands, invariant. That's exactly what we have here. No, you're good. You're good. No worries. The and whatever bit. Yeah. So because this is fully just our invariant. This whole thing is our invariant, and then this is just the loop condition here. Yeah. Yep. No worries. All right. Respectable in 5-hour LC3 call at this point. Does anyone have any more questions? I see no questions. I think I might be free. It's over. You have a question? No, you don't. Sorry, you don't actually. No, I don't think you do. We're just gonna, quickly. No, sorry, I feel bad. No, it's okay. You can ask your question. Go ahead. Sorry, what's your question? Go ahead. No? No, sorry, she didn't have a question after all. I knew it. No problem. No problem at all. I think I've had enough of the 10.3, 10.4. I'm probably not touching any of those anymore. I don't even think I've looked at 10.3. Only Daniel has the 10.3 solutions. I haven't actually done that one. Or even here it is. What is cell 6 specifically? Oh, it's just the precondition. I'm surprised. Is this not the same as the regular precondition? What's different? Isn't this? I think this is a bit easier actually than the precondition for 10.4. So I think I had it earlier, but basically Daniel has a 10.4 proof. Yeah, let me go find that. So up here, like way back, he posted it. I don't know if you can pin messages to general, but I'll just post it again, I guess. Okay, what was this? So it was when I posted the meme. Yeah, here we go. It's right above this. Let's do that without pinging him. Yeah, so this is the solutions for 10.4. So you can try to look at the precondition for that. It should be simpler because there's one less assignment to do. And yeah, we just don't have as much in our. I guess the thing is you have an exists in your invariant. I'm realizing now that you have the exists wise. So it may just require an instantiation or something. Oh, you know what? Maybe it is a bit different. I think I remember now. Sorry, it might actually be a little bit different. I'm realizing. Where did I even put this? Did I not? I opened it. Where did I? Is it just here? Did I open it here? Yeah. Okay, it's actually slightly different, isn't it? So our invariant is he gives us. Yeah, he gives us this invariant here. And our initialization commands are just these two. I think this is the correct initialization setup. So you start at the bottom, and then you do assignment with substitution. So we're going to start with this, and then do this command, and then end up with, we'll have something, and then we'll get true, and then we'll get something. Okay, so it should be like this. If we do b equals false, we get this. If we do this substitution, we just end up with that on the top. There we go. And now we just gotta solve this. So, okay. Okay, yeah, I see. This is a bit of a weird one. You have to recognize this being true means that y's. Okay, so okay, well, we can't really say much just about the fact that x isn't contained in y's. Doesn't really help us much. But what is really helpful is this observation here. You see how we're saying that y's concatenated with x's. I'm just gonna call this x's because I don't have actual x's, right? I only have x is 0, like the initial value. You see how y's concatenated with x's is equal to x's? There's really only one case where this is true, and that's where y's is the empty set. Y's has to be, or the empty sequence. Y's has to be the empty sequence, or this just isn't true. So with that in mind, we can actually set this up. We're going to do this. We're going to make a version of this where I'm just going to start with this. I've replaced y's with the empty set. This is clearly just inherently true. X is obviously, like for any x is not a member of the empty sequence. And this is not true, or like this is true, that because this is just the identity. So I can prove this if you want to right now. Left identity of concatenation, right? So this is reflexivity. We have membership in empty sequence is just that, right? And then lastly, this is just item potency, and then reflexivity. So we got all that, right? To give us just this, but where y's is an epsilon. And then here's the thing. Logically, we're trying to go in this direction, right? If I have a specific example of a y's where this is true, then obviously there exists some y's where it's true, right? Like that's just trivial. And the way we do this is it's just E introduction, right? If we go quickly get another one of these, open up our theorem list. That's just the direct definition of, oh, I don't have a word for it. Let me search introduction then. Here we go, E introduction. See this? If you have some statement where you've substituted x equal to some expression, it's the same as saying there exists some x where it's true. So I just need to create this substitution here. I need to create a substitution with a variable that represents epsilon instead. So I'm just going to quickly do that then. So I'm just going to make a little substitution where I'm going to say that on this whole statement, we're going to have y's is equal. Oops, I got to do square brackets. We're going to have y's is assigned to be epsilon. And I just need to replace these with y's. See that? And now this should just be directly exists introduction, and we're good. So that's that. I guess I should have copied the whole thing, but no, you know what? You have to make sure you get this structure correct. But yeah. Hang on, I wanna pop this into a smaller view. Yeah, here we go. Fire pizza. All right, guys. I think that is enough. I think we're gonna call it there. Good luck on the exam tomorrow, everyone. I think my calc check brain is exhausted. Why am I getting thanked by someone who's not even in the course? I guess Pavlos is just gonna have like a extra hour-long recording of nothing. It's kind of sad that we can't really get this recording up in time. There's not really a better way to like immediately get a recording uploaded. When we do this sort of thing. Good, if we do a long session, we can't like. The solution would be to like, I don't know. I just don't know when Pablos is gonna be awake again. You know, like. But I don't know. It is what it is. That's kind of we schedule it for a reason, right? Like it's ideally everyone gets in here in person and can just see everything the moment of. Maybe the solution is like to just start stopping the recording and uploading it each hour. And, like if we try to do one of these again where it's this close to the exam. I don't know. Yeah, normally we always record these and put them up on YouTube. It's just tough, like when it's literally this close to the exam. Like even if we got it up by tomorrow morning, it wouldn't be helpful, right? So we might not be able to get it up at a useful time. It may just end up being more of a resource for next year. Tough. Oh, I guess yeah, it's like decent, but like having the time to actually watch on a 5-hour recording and then how much the while loop was worth, I don't know, like maybe a third of the marks. Oh, more than that. Wait, 44% is insane. Really? It was worth that much? That's crazy. Hey, that's look, half of that is free post-condition and precondition marks, probably. It's all good. Again, I don't have access to the recording, right? The issue right now is that Pablo started recording it, but he had to leave. So I don't know, like I think, and also like editing, trimming it, and then exporting that takes more time than just uploading the whole thing. Like unless you have like most websites that can actually trim it, you'd have to like properly import it and then trim that and still upload. Like it would be a little bit, it'd probably be a bit faster to trim parts of it, but we'd have to find the right part to trim it. Like it would probably just be a bit of a longer process. And I don't even know right now what we would decide is the most important part. This help session started at 4. It has literally been almost 5 hours, and even then, like Daniel was doing stuff beforehand, but he wasn't recording it. But we started the recording literally at 4. Um, yeah, yeah. Daniel has been in call since 10 a.m. This guy's insane. I think it was like 11, right? Yeah, if this call is saying what it's saying right now, I think he started around 11. Yeah, nuts. Evening is still long. Good work, Calbot. Oh wait, this is the wrong. Oh, said this at the wrong channel. Oh, I'm not streaming anymore to see, but I was just looking at the help session. Someone posted a question in the help sessions chat instead of this one. Yeah, so I think I posted, I replied to the 10.4 solutions above. We didn't really post the 10.3 solutions. Daniel just showed them off. But yeah, his 10.4 solutions. How has it already, how have there already been that many messages? I just replied to it. Wait, am I crazy? Where did it go? Oh, here we go. I found it. Okay. Let me just download it again and then post it, I guess. It's just this. There you go. This is just a solution for 10.4. Pretty clean lemma for the invariant. We do a little inline subproof for the if statement. It's all good, guys. You guys all got this. He curves it a lot. No need to worry. Just get some rest. Make sure you're approaching it with your best mental state tomorrow, ready to solve all the puzzles on the exam. You just gotta have a good, like, you just gotta be ready for puzzle solving, right? You like cramming all the material is not gonna help if you're tired and you can't really think straight on the test. So just get some rest. Don't overexhaust your brain right before the exam. Like again, I don't know what's gonna happen with the recording. We'll get it up as soon as we can, but like right now, Pablos has like a 5-hour recording he's got to try to upload. So I don't know if he's gonna try to trim it down or what. I don't know when he's coming back on. So whatever happens, happens. And only the last 5 hours are recorded. The first 5 hours were just Daniel doing whatever he wanted. Yeah, we should just break into Pablos' house. I agree. Yeah, and you want to see Andrew thanking Daniel for his service and not me? Like, what's going on here? If you ask me. Daniel is the GOAT. That guy is just incredibly impressive. Yeah, previous years did not have bags on their exam. Also, my year had bags as a homework, but I don't think previous years did. No, no one really knows what the details are. In fact, I think he like arbitrarily curves everyone individually or some nonsense. I like actually don't, I have no clue how it works. Because we're like pretty sure different people get different curves and we don't know what the process is. I think at the end of the day, you know, you just roll up and do what you can on the exam, you know. Yeah, if you fail, you can get a waiver and then you just retake it next year. Yeah, this is true. For third year, first semester is really chill. So if you have to take LC3 during that, you'll have a lot more time to focus on it, and it shouldn't be a problem. So you just have 3 MI3 is a pretty simple course, as long as it's the same prof still teaching it, and you can take like, I mean, it depends on if you did stats in second or third. I did stats in third semester, and that one was also pretty chill. And you kind of have like freedom of tech electives and stuff, and so you can choose an easier tech elective as well. And SH3 is just a pretty fair course. Like not as easy as MI3, I think, but like it's just a pretty fair one that you just put in a respectable amount of time for and get a respectable grade, you know? It's got good labs and assignments.
SH3 was my favorite course of the entire undergrad, guys.
Oh, hello,
10 out
Sam.
of 10. Hello. How are we feeling, guys? I literally just joined. How are we feeling for 2LC3?
Thumbs down, unlucky.
Ah, shucks. Fuck. Did the help session, guys, everyone, is the help session helping? Are my academic managers slaying? Hi, Tasmin.
Academic managers did nothing. Me and Daniel carried. We're the goats.
You're a volunteer academic manager. It's
Daniel literally was already in here. He's look at the time on this call. Look how long this call's been going for.
I'm on mobile. I can't see. How
Okay, it's
long
been
is
going
it?
for 10 hours.
10 hours.
Daniel has been here since 11, just doing problems and stuff. So I joined up this call at 4, but there was already a ton of people in here. A ton more people joined, and we actually hit the stream cap. Like only 50 people can see someone stream at once. So I had to stream
Oh.
Daniel's stream, or he had to stream mine when we were doing problems.
That's funny.
It was very silly, but yeah, that's the most people we've had in here before in
Oh
one of these
god.
sessions.
You know, I always say 2LC3 is the course that brings everyone together.
Very
Like
true.
this is where you build community through suffering. I'm not gonna lie, because this is also how I feel like this is how our class got like grouped in together. Because we had like the whole, what was it, call check channel.
Like, I don't know. I feel like our year was pretty unified before LC3.
Our year was generally unified, but like LC3 really was like our I don't know. It's when I started being more active. When I was sending my answers for
Yeah,
exercises.
I was
Guys,
definitely most active in the Discord during LC3, but like I feel like we
mhm.
were already like I don't know, even for stuff like 1DM3 and things, like everyone was already talking a bunch for
Yeah,
those.
that's true. But anyways,
Mhm.
guys, this course will soon just be a memory. I promise you that much. And like, I got a bunch of DMs asking me if I remember exam content, and the fun part is I don't, because this course won't matter in just a very short amount of time. This course will not matter, so keep that in mind. And if you have to retake it, who the fuck cares? It's your life will not end because of 2LC3. I promise you that much. But yeah. Does that bring you hope, guys?
College fails specifically
Like,
13 people, so just be above the bottom 13 people and you got this.
is it 13 people? I thought it was like
It always fails exactly no.
okay, girl. I was gonna say I feel like it was like 5% of the class or some shit like that. Like you guys will live. I promise you, you will live and you will see beautiful days past 2LC3. Um, and the curve is real, guys. Like I didn't like I got a way better grade than I expected. Um, so just believe in that. Believe in the curve. Believe in yourself. And you will get through it eventually. Even if you have to retake it like once or twice, you will get through it. But yeah, those are my words of encouragement. I will now leave. So good night everyone and good luck on your exam. Bye.
Alright, good night guys. Good luck tomorrow. Have fun. Get some rest.